with a desk. Anybody for it? Take a very serious poll here, so I'm going to need to see a show of hands. Who's excited to be here? Thank you for joining us in the beautiful city of Valencia for the 2024 edition of the OpenSIPS Summit. I know many of you have traveled from far, near. The fact that you traveled and got here, that's great. Thank you for coming. We really appreciate you because it's you that makes these summits. Give yourselves a round of applause, please. And I'm going to roll with that while you're in the clapping mood. I'm going to talk a little bit about our sponsors for this year's summit. Coming in as our platinum sponsor, the home of SIP engines, SIP Hub, which is the commercial arm of the project that we're all here to learn about and celebrate. You guys got any needs for these types of things? They're all over the room. They'll be teaching you in some of the classes on Friday as well. Don't feel shy to reach out to them. Coming in next, our famous media director, Maxim Sobolov, and his company, Sippy Software. Max, please stand up. Anybody that's with Max? That man is a professional underwear QA person. He's QA number 3. Moving on, we have from the US, I'm sure they're a global company, but from the US, Five Nines is joining us. I believe we have some in the audience. Please, gentlemen, or people, just you? Okay, there we go. And one more, come on, stand up, guys, thank you for your contribution. We really appreciate it. Moving down our list, as we wait for it to flow. Yes, there we go. The guys from Genesys are here. They'll be in the gang battle series after the show. Gentlemen, please stand up. Thank you so much for your contribution. Did you want us to clap for SIP Hub? Was that it? I'm sorry. I might have missed out on that. We can, but you see I'm not. Flavio, are you in the room? Here you go. Stand up. Flavio from SIP Pulse, another one of our gracious sponsors. His team is actually preparing for the gang battle, so that's why they're not here. And from SIP Front, gentlemen, can you please stand up? Buyers, sorry. Yep. But this man here, we'll have another one later today. Thank you so much for your contribution. You and I are going to have a word. Gotcha. Don't lie to me in front of all these people. As we wait for the transition. Here we go. So we also have some sponsors at the next level here from, they're not here from Voiceland, but they really wanted to be here. Let's give them a round of applause anyway because they're going to see this online. Thank you, Voiceland. And nope, I don't think anybody's here from, I don't know how to pronounce it. Is it Voice? Senior. Voice. They're not here either, but they're going to see this, so let's give them a round of applause. Thank you for supporting the project. And last but not least, I think, Jonathan, are you here? Yes, you are. Please, Jonathan Hume from Connects, stand up. Gentlemen, thank you so much for your contribution. So here we are, and I have to eat some time entertaining you people. No, I don't? Oh, I don't entertain people. I can. Don't vote for him later. So, who's a first-timer here at the OpenSIPS Summit? Raise your hands. That's amazing. Wow. And can you name off some of the countries? I'm going to just kind of point around. Name the countries you're coming from. Brazil. Come on, don't be shy. Australia. Spain. You traveled a long way. Austria. Poof. France. I can't say it. The Czech Republic. Belgium. Kazakhstan. Ireland. I know you're from Spain. And Jesus is from heaven. Currently residing in Valencia, Spain. So I can see we've got people come from all over the world. Do we have anyone from the US? Everybody, thank you for making it, taking the time, and I know that especially, the time of year, travel is a little, but y'all did it, y'all made it. Again, thank you so much for supporting the project. We hope that we have some interesting stuff for you guys to learn about, ask questions about. But let's talk for a second about who this guy is, other than my comic relief. Are you done screwing with the laptop after I told you? No. Okay. So this gentleman, what? Listen, man. I've been doing this for a while. So this gentleman here is the founder of the project, Mr. Bogdan Iancu, not Lanku, but Iancu. He's got a self-made badge now just to set things straight. So how many years has it been? 15, huh? Yeah, so that's what? That's almost a decade now. Wow. And we've made our way around Europe a little bit too. We did. Last year we broke the circle. We went to the US. The summit came to my hometown in Houston. Everyone got to see what a scummy, slummy place that was. There is no coincidence. If you didn't feel safe walking around Houston, you really weren't there. So I wanted to talk real quick about the organizers of these events, because a lot of work goes into that. It's not just meeting on, a conference platform and talking about it. There's a lot of planning. There's a lot of work that goes into it. And usually the ones that have the most work are the ones that are on the ground. They're usually the local sponsor, the local organizer, if you will. They're the ones that really make it happen in the cities that we do this. So for them, Celeste, Lorenzo from QXIP, God bless you both for bringing us to this beautiful city and making this happen. I need a bigger round of applause for them. And a mainstay in the organizational unit is the king of media. This again is our Maximus Sobolov. Coming to us from Israel are the Gutman brothers from Voice Center. Please stand up, be recognized. I recommend that's about as close to them as you get. They helped with a ton of stuff as well. And again, a lot of these guys are just mainstays. They're part of the long track record of putting these together. And last but not least, obviously the team at OpenSIPS. because without them, we wouldn't have anything to be learning or celebrating about here. So Bogdan, Liviu, Baby Jesus, Razvan, please stand up. Gentlemen, thank you for a decade plus of knowledge, possibilities. We really appreciate it. Have I done everything, boss? So, you know what? Before we actually get this started, I don't think I've ever done this before, but has anyone got any questions about what maybe they expect, whether we're going to get arrested, I mean, about these few days that are about to launch here? Any questions at all? Any worries, concerns? Any food allergies that we need to know about? Wonderful, wonderful. Tonight is the dinner, correct? Okay. So I should say something like this. What time is the dinner, Celeste? 8. So at 8 p.m. tonight, which will give you some time to go and relax your brain muscles from all of the work you're going to get today, we're going to be having an event dinner. I believe all of you have been asked whether you're going to be coming or not. Those of you that said that you weren't, I seriously think you need to reconsider. Come to me if you need any advice on how to do this. But we'll be having dinner at El Coso on the rooftop. We'll have an amazing meal, some drinks, and we have the rooftop till 1 a.m. So we all plan to come, stretch out, relax. Don't feel rushed to get out of there or anything. There'll be great food, and we're right on the beach. Which, by the way, my wife is down to the left of us, and she'll come and party as she can as well. By the way, she's here because of the glorious man at Voice Center. I will tell you, those that are married and have never brought your wife, hold on to that dream. Because somebody will come along and crush it. Are you ready, Bogdan?
I just filmed it for your wife, by the way.
Good. Proof of this day and this treachery should live in the annals of open source communities worldwide. Don't let outsiders in. All right, you got the door? You ready to go? Yes. Yeah? The adrenaline's pumping?
Nobody can escape.
Nobody can escape. So without further ado, let's kick off this year's summit with Bogdan Iancu, our founder.
Yeah.
Hi everyone. Thank you, Alex, for introducing everyone, sponsors, organizers, and of course our team for the project. It's I'm really happy to see so many people joining for this. I think it's almost the 10th edition of the summit. Yesterday we were talking during the dinner about the history, how first real summit started. We went okay, let's give it a try to see how it works in Amsterdam, and then we found out that actually the guys from KXIP are there, and they helped us with organizing in a really nice way for the next years over there. So that was a turning point in terms of getting the event up and running. And yeah, since then we had this wonderful team behind the event with KXIP helping in Amsterdam, and wow, now surprising here in Valencia, so they keep moving, so we have to keep up with them.
It's a good system. It's a good system.
Yeah, well, it works, so let's keep it this way, right? Also, Max doing all the time the great job with broadcasting and everything, and the guys from Voice Center helping with all the materials and graphics, the artwork and everything. So yeah, we have this great team behind helping us to have the summit actually happening. So yeah, let's dive into the actual content, because we're gonna have first 2 long days with presentations covering different areas. We try to group them somehow by the topics. We have a lot about tomorrow about Web RTC. We have about IMS presentations. We have about AI and so on and so on. So even if it's starting the main topic, let's say it's about voice over IP, everything is interconnected. So we're gonna touch different other kind of things that may go around voice over IP. So it's not only about OpenSIPS, it's not only about voice over IP, it's actually an entire ecosystem where that's just the core, but with a lot of additional projects, additional topics. So yeah, there'll be like 2 full days of presentations. Thursday, after so many theoretical presentations, we're going to do some practical things. So Thursday, it's the day for hands-on experience. We have the demos or the workshops, people actually showing live how to do things with OpenSIPS or other softwares. So get some bits and pieces in terms of how you can achieve different kind of things. Yeah, in the last day, for those who opted, we have the training. But keep in mind, this evening we have the dinner, so 8 o'clock, Alex already said. And tomorrow we're going to have a wonderful boat trip, like 1 hour and a half. Right from here, there is a nice boat which will take us along the coast to see the nice Valencia area. Right. So yeah, let's start. As every year, I'll try to summarize as much as possible about what are the latest things when it comes to OpenSIPS. We already have a kind of how to say pretty well defined scheduled, like release, a major release just days, weeks before the summit. So we have a pretty good new content every time for the summit. So yeah, definitely I am going to talk about the new 3.5 release. So that's the idea in the presentation. And of course, these releases are actually, if I may say so, the product or the end result of the OpenSIPS project, as entity. So in order to keep up with releases, definitely we have to keep up all the time with the project, which actually just the project itself requires a lot of resources and time to make it work, coordinate, because first of all, the project, we have the OpenSIPS software, let's say, in the central part, but there are a lot of additional pieces of software around it, so we need to coordinate all around them, which is sometimes quite a challenging task. So we are talking about the so-called software magnitude. We need to correlate all the time it comes to developing a lot of additional tools and so on. So when you do a new release for the OpenSIPS project itself, software itself, we need to keep in mind, it needs to correlate with, for example, the CLI, it needs to correlate with the API stuff, and so on. Eventually produce new SIPSER testing scenarios for the new features each year. So yes, there are a lot of work going into synchronizing and keeping in a consistent state all these softwares. And besides the software, we have actually what we call the community magnitude. There are a lot of people involved in terms of development. So there are a lot of contributions, a lot of patches, a lot of reports, and so on that needs to be again taking care of them. We need to consistently integrate into the project and so on. So yes, that's something that we need to take care of. And also from the usage perspective, I mean users perspective, people using OpenSIPS, again there is a huge community that requires help sometimes, and we need to pay attention, okay, what are the needs also, so not only in terms of reports, bug fixing, but also in terms of features. Because all the time we say OpenSIPS is an a project driven by the needs of the people. So yeah, we need to closely pay attention to mailing lists, whatever channels we have, in order to see, okay, what are the needs of people using OpenSIPS, what are the next steps in terms of development and so on. So yeah, there are a lot of software magnitude, there is a community magnitude, we need to make them work somehow. So what's, let's say, the way to do it? Starting with the 3.5 release, we introduced a new concept into the project, the so-called working groups, because we felt the need of having a bunch of people focusing especially on a certain topic, especially when you have some really large topics. So yeah, it's difficult to do that on a generic mailing list. So the first actually working group we had was about the work we did in 3.5 about the IMS. We tried to collect as much as possible information about from people, okay, what should we do in that area, because it's a vast area, and not only in terms of okay, what should be in there, but how it should work and how actually we can turn this into a really usable and manageable, let's say, solution. We didn't simply want to say, yeah, okay, we did some pieces of software that in a secret kind of a combination makes IMS possible, but something that indeed it's understandable and usable by the people. So we felt this need of involving as many people as possible in taking the decisions about designing, implementing, and actually how to deliver this the IMS part. So that was the first working group. We are thinking about adding more on different topics, but okay, that will be in time. Another thing we started long time ago, and we want to improve our and actually to enhance are the community editions. The idea is with OpenSIPS you can do so many things in terms of covering different kind of VoIP scenarios. So basically to configure OpenSIPS to act as A, B, and C, and so on and so on. And in all these scenarios, it's not only about OpenSIPS, like having a script. Ideally, you need a lot of other ingredients around. You have how to set up the proper database, how to set up the proper let's say web interface. Maybe you have you need a calling API next to it, and so on. So basically, all the ingredients you need in order to get like a fully working solution. So the idea with this community editions, and to try to identify, okay, we have some couple of ideas in mind, some typical scenarios, and try to pack them. Ideally, like we want. In the past, we went for virtual machines. Now we want to move into Docker-based systems, but to have something already pre-packed that really works. Just spin out, you deploy, and you have something working. it's a good starting point. That's it's again a basic configuration, but can be used by anyone, like for a fast starting, just to see how it works. And it's a good starting, like for dissecting, to see how it works and so on. And then you can say yes, I can start building on top of it, customizing and so on. But the idea is to maintain. Okay, again, these are just a couple of ideas we were thinking of, but not limited to. To actively maintain. Anyone can, from the community, because that's why it's a community edition, can actually contribute. Let's say adding, for example, if we do like basic SBC, say okay, I want to contribute and add some new functionality over there. I don't know, to support presence, for example, and so on and so on. So yeah, that's the idea. Not only code, but also again configuration and setups. And the last, but not the least, starting this year, we try to improve the way the development works. Basically, focusing on the idea of teamwork-oriented development. Instead of having, how we call them, development cowboys. Everybody does whatever they think it's nice and good and so on. We try to say, okay, actually, no, that's an open source work. It's a group at the end of the day. So also the whole development concept should be something like, a joint effort. So the idea is, okay, when there is some new work or contribution, we need to see, okay, how it fits actually into the new software. We need to go through a process of reviewing, because we had surprises in terms of overlapping, or maybe better approaches in terms of how you design, not necessarily code, some features. Also, in terms of validating the whole code before just uploading, and then surprisingly, wow, a lot of tests are just failing. So basically, a proactive reviewing of the work. The idea is to improve the code quality and to be sure that everything that we have, and it ends up in the OpenSIPS repository in terms of feature and code, is consistent. And it's not just a pile of code that maybe used in different ways, but again something that has a head and tail at the end of the day. So yeah, that's on the project side, and now focusing on the actual, let's say, code or features for the 3.5 release. By the way, this release, it's not an LTS, so on the three main branch, we're going to have also a 3.6 next year, which will be LTS and probably the end of line for the three major lines. So we said, okay, it would be nice to end up with an LTS. Yeah, the 3.5, probably you already got the idea. It's focusing on the on IMS. Even before the 3.5, there are a lot of ingredients here and there and so on in the code. But if you try to put all the pieces together, there were some kind of a key components still missing, or maybe the way to connect all the dots in order to get the full working solution. So as said before, the whole work in terms of IMS was driven by this working group. We had the whole process of identifying, okay, what needs to be done, what exactly needs to be developed, or what should be the actual deliverable when it comes to the IMS solution in OpenSIPS. So again, that was the idea with these working groups, to coordinate all the people involved in some quite large, let's say, large-scale developments. As a result of the working group, in terms of IMS components, what we have right now at this stage in OpenSIPS, it's focused on the CSCF component, so basically the middle layer when it comes to the routing. That's the most, let's say, SIP related part of the IMS, and we said, okay, let's have this covered in a very well and consistent way before moving on. And as I said, the deliverable, it's not only code, so the idea was not only to have at the end some code able to do that, but also configurations. So working setups for the IMS, because actually IMS is not so simple. It's not like, okay, I'm loading a module and boom, I have IMS. It doesn't work like that. It's a lot of logic. You have, even in the CSCF component, actually there are 3 subcomponents inside that needs to do a lot of routing. They need to do a lot of queries, interaction with other components, and so on and so on. So yeah, there is a lot of logic in there, and that needs to be, let's say, exposed by these scripts. So that's still, if I may say so, pending part of the IMS work. So far, we successfully managed to deliver the code part. So in the next weeks and months, we're gonna work in trying to pack everything in a really usable and friendly way. Of course, the main idea is to have an, as I said, fully functional solution, so not only some pieces of code. Just to have an idea, what this IMS work involved. So what's the footprint in IMS? We have the CSCF components in there, the P, the S, and the I. And for each of them, I try to highlight, okay, what kind of work was done for each of them. So we had to develop, for example, the IPsec protocol for the proxy component. We had to do the we had starting, I think 3.4 or maybe 3.3. We had the diameter support. There was a lot of work to be done over there in terms of, for example, to get server support in diameter, so to have OpenSIPS being able to act as a diameter server also, or to be able to handle different kind of raw data AVPs in the diameter packages. So again, a lot of extensions over there. On the other hand, for 5G, when interacting with the core side, the network core side, for the proxy side, the documentation says, okay, you need actually to use HTTP2 and not diameter. Diameter it's only for the 4G specification, but if you move to 5G, then theoretically HTTP2 is mandatory. So we said, okay, let's have this support in place also. So there was a lot of work also to get this client server support for HTTP2 in OpenSIPS. And then in terms of authentication, we had the work for the AKA authentication support, which at the end of the day you may say, yeah, it's just another way to do digest authentication, but actually it's really complex because it requires diameter interaction. You need to fetch through diameter, or to get pushed by through diameter some authentication tokens that needs to be managed and consumed each time when you do authentication with the device. So there are a lot of places, where this, IMS, how to say, needs different features implemented. Even in presence, there is, I think it's the BRAG registration event. It's not necessarily like IMS specific. I mean, it's not intended when the specifications were written for IMS, but it's actively used in diameter by the mobile devices just to find out, okay, what's their status in terms of, the status of their registrations. So there are a lot of other components which are, features which are used in the IMS solutions. And the biggest challenge, that's just the tip of the iceberg, right? It's not limited to that. There are a lot of bits and pieces in different other modules, in registration module, in user location module, in dialogue module, and so on. But we said, okay, let's do a consistent approach on that. Let's not come up with, IMS specific versions of these modules, and actually try to implement as an extensions of the existing modules when it comes to all this. So to avoid as much as possible duplicates. Again, that was a good result of that teamwork development, and also of the IMS working group. But we will have today quite a nice presentation from Razvan and Liviu on all the details about that. So I don't want to steal their content. That's just a brief listing of what we have in the previous slide in terms of the working for the code itself. And yeah, this there was a lot of work in terms of collaboration thanks to this working group, and we had contributions to this in terms of code, and NG Voice. They committed in terms of software in terms of code into OpenSIPS with a lot of diameter specific features. For example, this SIP reg support, which actually they are like 2 new modules for both presence user agent and also for presence for distributing support. And yeah, the collaboration with NG Voice was a really good example how, coming from the industry side, you learn exactly, okay, what you need to do in order to get something really fully functional. And as mentioned, yeah, the whole IMS work, it's not code only, but a lot of scripting that we need to do. We are actively working, and again, that will be also a collaboration effort to have a Docker-based system, and not only for the OpenSIPS itself. I mean, the 3 components, the CSCF, but again, to integrate to the core network, like Open5GS or anything else. Also to have, in order to get like a fully functional solution, also with the, with the home subscriber, so with the HSS system. So to have something that you can spin out and say, yes, I have something to play and to work. The idea was, at the end, developing all these interfaces, was to have a really, really flexible solution. So we tried to say, okay, we don't want to hard-code a lot of logic into the modules, but rather, let's say, expose the logic at the script level in terms of, okay, what do you need to put in all the diameter packages when you interact with the other components. So that's something that you do at the script level. Of course, there will be the community edition which gives you a working thing, so you don't have to reinvent or to do like reverse engineering of the code to figure it out how to make it work. You have the samples, working samples, but if you want, let's say, a customized version, because yeah, in IMS everything is possible. There are so many flavors of it, depending on what you want to do, that would be inevitable that you would like to change something over there. So that's why we said, okay, let's go for a flexible, easy to customize approach. So to try to make as many people as possible happy with this solution. And well, let's say when it comes to usage, you know, you can go and do a lot of things after that, because at the end of the day, you know, it's just an, how to say, an IMS component that you can use in order to build on top different other kind of services. I mean, it can be used for the mobile operators, or if you want to play in the MVNOs, or if you want just to do services on top, or whatever. So you can just take the whole thing or parts of it, because again, you're going to have a lot of samples on how to do it, and thanks to the flexibility, you can adapt and do a lot of things. Again, later today, we will have Razvan and Liviu talking about you know, how we actually build this CSCF component step by step, and you know, all the time the best things are things that you see how they work. Tomorrow, no, sorry, the day after tomorrow, we have the workshop where again, Razvan and Liviu will actually show you a fully working IMS, let's say, solution. We have BTS with us, so we're gonna actually put it in practice, make some calls through it. So yeah, we're gonna see some end results, not only some slides. Now, what else is in 3.5? Because each year, okay, we have a main topic for the release, but it's not limited to that. There are a lot of other things besides that. And the most relevant things for the 3.5, well, now we have the SQL improvements. Basically, why we focused on that. So why? Because, you know, at the end of the day, SQL, it's more or less there from day one, right? Or almost day zero. So we said, okay, why? Or what is to be improved in that area? Well, there were a couple of things over there. First of all, yeah, I don't think there is any kind of, let's say, working deployment that's that it's not using SQL. So basically, any kind of SQL flavor in there. So it's more or less mandatory in all the, or I mean, not mandatory, necessary in all the deployments. And we had AVP Ops in the past module. You will see why I'm saying in the past. Doing that for OpenSIPS. And yeah, that's actually a very old module, originally designed for something else. Probably 70% of that module was like obsolete because it was intended actually not for DB operations, but more for AVP operations. So yeah, somehow, you know, its purpose disappeared. And we felt the, you know, we have this feeling that most of the SQL capabilities of OpenSIPS are not properly exposed at the script layer. So you have a really powerful internal SQL engine able to, you know, perform queries over different kind of backends. Some of them not even supporting like an interrogation language. I mean, they don't. You cannot do like a raw SQL query. For example, we have the DB text support in OpenSIPS, and that one doesn't support anything like that. So you cannot interact with it from the script level in the past. And there are other features we will see later, again, which were not harnessed in the proper way from script level. So there are like a couple of reasons for saying, okay, we need to pay attention. So, well, in this case, we had the old AVP module. We said, okay, let's park it. That's it. Enough with it. And we tried to salvage as much as possible. I mean, what was relevant from it. Put a lot of new stuff, and to get the SQL Ops module in as a replacement, or like a continuation rather. So what actually offers as new stuff this SQL Ops module? Well, first of all are the what we call the structured queries. Before, all the time you were just writing a raw SQL query, and that's it. Meaning, first of all, you are limited only to the backends able to understand a raw query, and at the end, you are not taking advantage of any of the potential improvements offered by the internal API, just because you are going through an you are just going through a raw query. So now we have this structured query where you say, okay, for example, I want to do an insert. Okay, I have this list of columns, I have these values, I have this. So basically, you know, you instead of passing the query itself, you just pass different kind of parameters, meaning that and that and that. And everything is JSON encoded, so pretty nice. So in a structured way, it's very readable. And because you have the JSON support in the script, it's very easy to to work with that. We actually support all typical SQL queries directly from the script. And now, because these script functions, they are not doing raw queries, but actually they are going in the internal API of OpenSIPS, you can, again, work with any database backend that you have in OpenSIPS, even the ones not supporting raw queries. Again, like the DB text, or maybe if you want like Unix or DBC interface, and so on and so on. This is just an example, just to get the idea, like, okay, how an SQL select looks like. With the JSON saying, okay, what columns you want to select, or then, okay, what's the structure of the where statement, everything again, JSON and encoded. So, yeah, pretty straightforward, and most important, efficient. Why? Because now using the internal API, you can take advantage of the prepared statements offered by the internal API. So things that you were not able to do before with raw queries. And why it's so important is, well, the prepared statements gives you like 20-25% boost in terms of performance when it comes to the queries. And it's also safer when it comes to SQL injection, because you have data separated from the actual structure of the query. So there is no way to, to, let's say, abuse and try to do attacks. So that's actually some chart testing. I think it's like maybe from 10 years old, when the prepared statement support was introduced in OpenSIPS. It was used by the internal queries, but not by the script level queries. And this one is, I think, what's over there? For the location, user location, typical queries. And this one gives you like roughly 25%. So there are actually some measurements we did in the past, right? So now you can take advantage of this at the script level. We tried also to make it more flexible to use. Initially, all the DB support, all the DB operations were in this AVP ops. So whenever you had to do a query, you had to go through an AVP. Sometimes you didn't want to do that because we know all the stories. Like, okay, you end up with like huge amount of AVPs going all the transactions and so on and so on. So sometimes you just have a, you want to do a query with a very small scope in the script, and you don't want to pollute the whole memory with the AVPs. So on the other hand, the AVPs are good because you can do arrays, multiple row queries and so on. So for that purpose, we said, okay, let's try to find the middle way to support something else than AVPs, because probably, I would say in 60–70% of the cases, you know what you do, and you actually expect only one row in terms of result. So we have the SQL query 1 and SQL select 1, which are able to take as result any kind of variable. So somehow, we broke this dependency between queries and AVPs. Just again, to get more flexibility. So that was the part of with SQL improvement. In terms of new modules, we have a new launch darkly support. That's for feature flags. Actually, it's a service. It's not an the actual, let's say, central part. It's not in OpenSIPS. It's connecting through a SDK to a cloud. And yeah, it's really, really useful when it comes to the microservice. If you want to integrate all different kind of components around, microservices like the flag. So basically, at the end of the day, it's a flag. It's not so complicated, but it gives you a really nice way, to use such feature flags from different places, not only from OpenSIPS. So basically from any kind of API interfaces and so on. And this development was sponsored by Five9. Result of collaboration with them. In terms of scripting, it's very easy, something very easy to use. Again, it's connecting to the launch darkly cloud, where you have to pre-configure the flags and so on. But from scripting perspective is simple, and at the same time the whole implementation is resilient. I mean, even if you are not able to connect to the cloud, things are still working. So it's not like a kind of a bottleneck in terms of the OpenSIPS operation. And we have also the message queue implementation. That's very, very, very simple concept where you have generic messages that you simply want to basically push between, at the end of the day, processes in OpenSIPS. But you want to do that from the script level. So this is already supported internally by OpenSIPS with the IPC interface. But if you want to do at the script level, so basically you have a task, you don't want to handle the task right at that moment. You just want to, let's say, deal with it later in a different process. Then you can simply create the task, push it into the queue, and later consume the queue, in a different process in order to offload, the main processing and stuff like that. So again, it's a very simple idea used for, again, to rebalance somehow the load based on inter-process communication, but at the CFG level. Like, you just put stuff into the queue, and then later, let's say in a separate maybe timer process or whatever you want, you can consume, and like here we push queries in the queue and we just run them later, just an example. So yeah, again, it's a simple feature, but sometimes very useful. This was a contribution from a video SaaS into OpenSIPS. And there are many other things we had, like you know, in the SIP rec area, we try to do it more flexible, because again, the SIP rec is also part of you know, the recording capability in different kind of IMS scenarios. I will not go into, there are quite low technical details over here. And also in the still shaken part were some you know, valuable extensions, like with the new, let's say, upcoming RCD support, we had to extend the module to support multiple identity header with different passport types, or you know, the ability to add the p-identity bypass header in order to be compliant. So there were like small changes in there too. These are the, how to say, things that can be listed like the big ideas. But the whole 3.5 was like a huge, had a huge impact on the code. So we had like 9 new modules added into this release. There were like 27 enhanced, so basically modules which were new parameters, new functions, new, you know, MI commands and so on. Overall, you know, there are like almost like 200 modules in OpenSIP, but we had 128 impacted, like fixes, new things, and so on and so on. So, you know, more or less it touched all the code. There were like 748 commits overall. It's like in one year, with this impact in terms of lines of code. So that's why I'm saying we had a lot of work impacting the code, even if some of them were like small bits and pieces in different kind of codes. And before ending, Dan, just to
hello. Yes, I'm Dan Jenkins. I run an event in the UK called CommCon, but it's not just happening in the UK this year. It's happening in San Francisco as well. So it's happening in London, 5th and 6th of June. So what, 2-3 weeks time. And then that's 12th and 13th of June. San Francisco, I should know these dates better. In San Francisco, so literally a week later. So, we like to give things away to people, and we did this last week, 2 weeks ago, last week. When was Janus come? End of April. That doesn't help me, end of April. Anyway, 2 weeks ago, in Italy, we gave away a ticket to CommCon, ended up going to someone from Bloomberg to come to San Francisco, which is great. So, if you would like to come to CommCon, it's a really great event, come and talk to me about it, in either London or San Francisco, then come and get a selfie with me and post it on social media somewhere, tag CommCon somehow, and we'll find it, and then you will be up for winning a free ticket to CommCon. Yeah, I'm going to talk more about CommCon briefly during my talk tomorrow. So I won't bore you with that right now, but yeah, come talk to me and come grab a selfie with me before the end of tomorrow, because I won't be here after the end of tomorrow. Thank you very much.
But not like really forever, not be here.
No.
Okay. You look amazing.
But it's free. Free.
Dan, thanks so much. Let's give Bogdan a quick round of applause and get our next speaker out here. Well done, sir. So our next speaker will be coming to you from our sponsors at Genesys. Ben Newland will be talking about how these guys use OpenSIPS in their company. Should be quite interesting. Take your time. It's okay.
Good things come to those who wait.
Let me see a show of hands. Who's coming to the dinner tonight? I'm looking for that one person who doesn't have it. Lorenzo, did you have your hand raised? I didn't see it. No one to pick on, huh? You all want to be part of it. That's great. Just want to let everyone know too, we do have a scheduling change on our next presentation. We're going to have Celeste Mangani coming up from QA, right? You're next, right? I made a joke. It is you though, right? You're going to be next because you're coming from down here to here. No, to here, right? No? I've been fed the... Oh, here. Ah. I'm sorry. Wait, you are here. Not you, him. You know what? That's a fistful of lies, okay? Livia, did you not tell me this man did not even register? Like you were a ghost, like up to 15 seconds ago. So there will be no scheduling changes next. I've taken up too much time for Ben, but ladies and gentlemen, Ben Newland from Genesys.
I'm just going to do the whole presentation right here. Yeah, so my name is Ben Newland. I'm a Senior Director of Development for Telecom and Voice Services at Genesys Cloud. And I'm going to talk a little bit about our use of OpenSIPS. You're going to hear a lot during the conference about how you can use OpenSIPS to do the things that you want to do. And what I want to focus a little bit more about is what you can do for OpenSIPS, how you can leverage your ecosystem to ensure that your OpenSIPS deployment will be successful, scalable, resilient. And this is going to be using some of the best practices that we have, I certainly wouldn't say perfected, but we have championed over our time developing Genesys Cloud as a cloud-native application. So just to give a brief overview, I'm going to talk a little bit about what is Genesys, what we do, our core design principles that we apply to developing our platform, and some of the best practices that go along with those designs, and then just a little bit about our culture and how that applies. And I'll be tying that into OpenSIPS specifically at the appropriate junctures. So, as an introduction, who is Genesys? Genesys makes Genesys Cloud. It is the industry-leading AI-powered experience orchestration platform. That is a mouthful. If you don't know what that means, it's okay. We are positioned highest in ability to execute for contact center as a service by the 2023 Gartner. More than 4,800 organizations, over 100 companies, 99.996% uptime, 350 features a year on average being delivered, over 45, this data's old, so well over 45 million conversations hosted daily, and many, many apps and pre-built integrations across the infrastructure. So this is what we deploy and this is what we drive to the market. How do we do that? That's the interesting part. So we have a few core design principles. We have many more than are presented here, but it's only a 30-minute talk, so I need to drill it down a little bit. So one of our biggest design principles is microservices. We are all in on microservices. We have been for a very long time. This is not a new design principle. Microservices have been around for about as long as OpenSIPS, to be honest. But to really commit to it, we've been committed to it from day one with our cloud deployment model. And really doing it well, there are a lot of advantages there. So the ideas of the asynchronous communication, isolation, single responsibility, each service working with full autonomously, and with exclusive state, really strict separation of responsibilities. The second principle we tend to run with, which goes kind of hand in hand with microservices, is the idea of an immutable server. So any mutation of the binary in our deployed services is absolutely prohibited, right? What we are deploying in our test environments is identical to what we are deploying in our production environments, and any change requires generation of an entirely new image that will flow through the pipeline as normal. Again, many of you are probably familiar with these principles. I see some head shaking as we're going on. And so what this fosters is a real focus on stability, scalability, and resilience, focusing on the ability to grow horizontally, on the ability for our system to heal itself automatically, focusing on principles of loose coupling, tolerant readers, circuit breakers, these kinds of things that enable services to survive failures, which are inevitable in any environment, but even more so in a cloud environment, as many places are deployed today. So as our CTO, Glenn Nethercutt, says, is to expect failure while actively trying to avoid it, is kind of one of our guiding principles. So I'm going to drill into each one of these a little bit more. So how do we do this? So the microservice aspect, and specifically as it relates to OpenSIPS. When we deploy OpenSIPS as a microservice, our service consists of the OpenSIPS application running along with a sidecar. In this context, the sidecar is an application that we build that runs alongside of OpenSIPS on the same image. So why do we use a sidecar? Well, OpenSIPS has a lot of modules that provide a lot of functionality to do different things, and these are great for leveraging in OpenSIPS as a standalone system. But we have a really robust ecosystem. Genesys Cloud is obviously much more than OpenSIPS, much more than voice. It's chat, it's omnichannel, and other things. And so we have a very robust ecosystem that interacts with many other microservices, external libraries, third-party integrations. And the sidecar allows us to utilize that prior art, internal libraries, third-party libraries that may not be able to interact directly with OpenSIPS. So we found that this is an excellent model to be able to additionally align with the principles of isolation and bulkheading that I just talked about, or mentioned at least in the last slide, to really let OpenSIPS focus on what it does best, right? Let OpenSIPS focus on being OpenSIPS, on being that super performant SIP processing engine that we know it can be, and extract a little bit of that ancillary operations out into another module. So as I said, the sidecar offers some integrations for us. It provides some instance management functionality, database reloads for modules that support it, things like SQL Cacher. It also provides an interface to mechanisms like HashDB local or shared variables, which we use for providing inputs, runtime inputs into OpenSIPS, changing its behavior at runtime. It provides an integration for exporting data outside of OpenSIPS, events, CDRs. We all have needs to get that information out of OpenSIPS in various formats. And then it provides some resiliency functionality, some things that are not necessarily inherent in OpenSIPS and maybe shouldn't necessarily be. Some functionality around circuit breakers, especially for external HTTP connections, proper fallbacks for external dependencies, health checks, which are very, very important in a microservice and a cloud service, and various cluster operations, maintaining the state of the service as a whole and individual instances, especially when it comes to the cluster capabilities that are built into OpenSIPS. So now that's our service, so to speak. That's our microservice. That's how we sort of build it from a very high level. So now how do we get it deployed? And this is our second principle, is immutable services. So obviously, CI/CD pipelines, again, not new. They are a very robust and very well-used way to get your code out into production. And we have a very robust CI/CD pipeline around building the services that I just described. It starts with your build process automation. Ansible, Puppet, Chef, we're familiar probably with all of the different names in the process automation that can provide this. Whatever flavor you are comfortable with, that's definitely where it starts. We tend to run with two phases. We have a build phase, and then we have a run phase. So using the same automation framework, we'll start off with a build phase. And the output of the build phase is an image. It can be an AWS AMI, it can be a Docker image. Our tooling actually can build both. A long time ago, thankfully we don't have to do this anymore, but a long time ago we generated a bootable server image that could flash an entire physical system from IPMI remotely. And this is sort of tied into the infrastructure as code principles, right? We want to be able to take any system and start from a clean slate and know exactly where it's going to end up. So this image that you get out of the build process is going to contain every single dependency that your system is going to need, already built into it, and the configuration that's necessary to run in any environment that you choose to deploy it to. Your testing environments, your production environments, whether you have one or many, everything you need to run is going to be on it, including the build automation for the next phase, which is the run phase. So now at deploy time, you have selected your environment that you're going to run it to, you execute your run phase, and it finalizes the configuration for the specific environment you're in. It's going to template some script files, maybe OpenSIPS scripts, maybe other scripting files with specific values that are keyed into the environments that you're in, ensure all of your processes are up and running, and then hand the instance off to your processes to continue performing the tasks. The key here is that during the run phase, there should be no package installations, no package updates, no binary updates whatsoever. In an ideal world, the environments that you're deploying these into would actively block any such attempt to pull external dependencies onto your instance. Because it's absolute what you don't want is to be running a different version of a library in one production region versus what you're running in a test region, right? Everything's got to be locked down. So this all pulls together in your CI/CD pipeline. Again, I know many people are intimately familiar with this process. You have your builds triggered directly from your code repos based on changes, both CI builds and the actual deployed image builds, if they're separate, which they don't have to be. You can potentially configure your deploy path based on the build source, the branch. So maybe your feature branches are deploying into your testing environment, and maybe your master branches or main branches are deploying directly to your production environments. In an ideal scenario, this results in a code check-in, PR being merged, potentially flowing all the way to your production environment in a completely automated fashion without ever being touched by one of your developers. That is the ideal goal. And it's a tough place to get to. And one of the main requirements for getting to that goal is testing. Really, really robust testing. In the context of OpenSIPS, there are a couple of testing targets we've identified that are very important to make sure that you are deploying a quality product and to reduce your risk of needing a rollback after a deployment. So with OpenSIPS, you want to be verifying, obviously, the SIP protocol, right? That's what it's all about. That's the base of it. We're here to do SIP. And you need to make sure that your SIP is compliant, that it is not only compliant to the RFC, but compliant to your needs, that it's backwards compatible. You don't want to be introducing regressions while you're making new deploys. You need to be able to handle bad actors, unexpected inputs. We all know the scammers and scanners that are out there that are going to be poking your SIP server. We all know that some of your customers may not really know how to configure their SIP server, and it may do some weird things. And you've got to be able to handle that as well. You want to be able to verify the behavior of your dependencies, both in the happy path and in this condition where your dependencies have failed or they are providing bad input. And then you need to be able to verify all of your ancillary operations. Some of the data exports I mentioned coming out of ours, OpenSIPS, events, CDRs. You want to verify your health checks, make sure those are all running properly. So all of these are sort of the heavy hitters, the big areas that we focus on when we are validating any particular build for deployment into our production environments. We did this by building a test framework. We built this quite a while ago, a very robust test framework that is built on Docker. It runs on Docker. It is built in Python. The configuration for the testing environment and all the tests that run are configured in YAML. It is able to model external dependencies like databases, SIP clients, REST APIs, and it provides superior visibility into the state of the running test, tracing, logging, so that we can troubleshoot errors and we can find when things go wrong. Now, if any of you are familiar with the OpenSIPS ecosystem, if that spiel sounded very familiar, it should, because SIPCert is a tool within the OpenSIPS ecosystem that does all of those things. If you read their description on GitHub, basically reads like exactly what I just said. Now, full disclosure, we don't use SIPCert. As I said, we built this test framework in-house quite a while ago to perform these functions. But SIPCert is an example of the kind of tool that you can use to really leverage the testing capabilities to make sure that your AMIs are clean and make sure that you're deploying faultless code. And we are very interested to see where that project goes. I know it's relatively new. See where that project goes as it matures and hope to work with it as well going forward. It's a very, very cool idea. So what does this, what's going on? There we go. All right, and so what does all this lead to? Well, operational excellence is a modest way to put it. So this is a chart from the DORA, the DevOps Research and Assessment Institute. This is a standard set of DevOps metrics used for evaluating process performance and maturity. The metrics provide information about how quickly DevOps is responding to changes, the average time to deploy code, the frequency of the iterations that you're deploying, and insight into failures and failure rate and rollbacks, things like that. So these metrics are an excellent way to assess the maturity of your pipeline and of your DevOps operations. And obviously the elite column there is where we always strive to be and where Genesys generally tries to operate. So what does all this lead to? Everything, building the images, building your microservices, having a robust CI/CD pipeline, and testing. What's really the goal here? Scalability and resilience. That's what we're talking about. We're talking about building a stable platform and having confidence in the ability of the platform to grow and to remain sound. So some of that is built into the microservice design principle, right? So the principle of isolation, separation of responsibility, right? Do one thing and do it well. So we all saw the graph that Bogdan showed just a moment ago of the IMS platform. Even within the CSCF category, we saw that there are 3 different implementations of CSCF that can be made. So separation of responsibility is not something that's new, either in the IMS world or in the SIP world. SIP registrars, SIP proxies, these are examples of isolation. and separation of responsibility in play. Now, a lot of times the standards will only mandate that these are logical, separate entities, but if you're following a strict microservices paradigm, these are also actually separate instance and service deployments because they may have different dependencies and different requirements that you want to be able to account for in your ecosystem. So things like a transactional proxy versus an application server versus a registrar versus a back-to-back user agent would actually be completely independent and autonomous SIP microservices in this reference architecture. And the other microservice basic principle that really speaks to scalability and resiliency is this idea of loose coupling, right? You do not want to be tying your service to another service in a hard manner. You want to be a tolerant reader, you want to have circuit breakers and fallbacks in place, and you want to make sure that anything that doesn't absolutely have to be done in real time is not being done in real time. So OpenSIPS provides a large array of async capable operations. The async module itself, message queues, the new message queue module, which I did not put on here, but is excellent for this, as well as the fairly recent Kafka module, RabbitMQ module, are examples of that. So on top of that, those microservice principles, you need your service orchestration, okay? And there's a lot of different providers that will offer some level of this at different levels of functionality. You've got Docker Swarm, Kubernetes, AWS provides a few different services that do this. But the key, the sort of fundamental principles of the orchestration on top of any other bells and whistles it may provide is horizontal scaling and the ability to self-heal your service via instance replacement. Well, how can you do that? You have to have visibility. Visibility is key into making those decisions for your service orchestration framework. And you really need visibility into two key things. You need visibility into the health of the service, right? So what does that mean? It can be things that are dependent on the state of the instance itself. Maybe there's network interfaces you need, local dependencies that you need to make sure that are there, individual processes that have to be running or your service can't function properly. It's important to note here that external dependencies should never be part of this sort of health check. And that means not explicitly part of the health check, but it also means that you have to be very careful not to insert into your health check any operation that depends on an external extendency, because you are, in effect, pulling that external dependency into your health check. But you don't want to get into a state where your service is thrashing due to the failure of some external entity. Restarting your service is not going to make that external dependency come back. It's just creating more problems. And then on the scalability side, you need to be monitoring the load. And this means different things for every service. And this is one of the ways that isolation and single responsibility really come into play. Your service may be CPU bound, it may be bound by disk I/O, may be bound by writing to a database, depending on the specific SIP function or any other function that you're providing. So you need to be able to see that as well. So just to drill in a little bit on OpenSIPS health, or on the health check part of it and how that relates to OpenSIPS. OpenSIPS is a multi-process application. We have multiple different types of processes within OpenSIPS. You've got your worker processes listening to your interfaces, you've got timer processes, you've got internal processes, main process, and then you've got your MI processes, and we need to make sure that all aspects of this are running properly. So just a few examples of some of the health checks that we use within our OpenSIPS implementation. Obviously, SIP options pings, pinging every interface and protocol combination, making sure that your workers are there, that they're listening and responding properly. We're monitoring shared memory usage, OpenSIPS load stats. Those are, again, pretty obvious ways to tell if your instance is remaining healthy. We've also implemented a watchdog implementation using a combination of a timer route with a shared variable that we're kicking to make sure that those processes are continuing to run as expected. And then one warning that we ran into is you do have to be careful with MI contention. Running as with a sidecar, as we said, and doing a lot of data reloads, you need to be sure that your health checks are not going to get starved out. Something like a FIFO MI process is single access, but the UDP, datagram, even the HTTPD MI implementations have a configurable number of processes or workers that are going to respond to those requests. And you need to make sure that your ancillary operations are not starving out your health checks and causing an instance to think it's unhealthy when it's really not. Just a little thing that we ran into quite a bit ago. So that's about it for the technical side of what we do and how we try to leverage OpenSIPS for maximum capabilities. The last thing I wanted to talk about a little bit is just the culture at Genesys, and specifically our insistence on a blameless culture. I think this is really, really important in any organization, really, but especially in technical organizations and engineering roles. Having a blameless culture means that we focus on incidents in learning from our mistakes, not finding out who made the mistake. This leads to faster issue resolution, continuous improvement, and a very high morale engagement. People don't have to be worried about being blamed. People aren't worried about trying to figure out who did it. They're trying to figure out how we can all move forward and learn. We were introduced before. This is our Genesys team at OpenSIPS. If you have any questions or you just want to talk to us, as you see us walking around the conference, feel free to come up and say hi. And that's all I got.
Ben, thanks so much. That was awesome. As we get our next presenter up here, Evan, do we have any? I'll take one question. Do we have one question for Ben? Okay. Don't you go anywhere, I told you.
Yeah, hello. One question about how do you deal with failover, in a sense that I've seen that you're using CacheDB local and you're using like internal state of the OpenSIPS in the container. So how it's gonna work when the OpenSIPS container will fail for whatever reason in production? So how the failover process is going?
Sure. So
I'm old, sorry.
So it's going to depend a little bit on your orchestration framework and the platform you're delivering to, right? Genesys is pretty public about the fact that we are deployed into AWS and we are native within AWS. So of the orchestration options we use there, one of the primary ones we use is AWS auto-scaling groups. And that allows you to hook up the health checks to your instances so that they can be automatically replaced. But from a data standpoint, we've really tried to leverage some of the clustering capabilities of OpenSIPS to make sure that instances can disappear and be replaced with a new instance without any loss of data. One of the things that I didn't get a chance to drill into here that is a core principle at Genesys as well is the idea of externalized state. So you want to make sure that any state that your service needs in order to operate is hosted externally to the service, so that services are nameless, faceless entities that a new one can stand up and begin running in the place of the old one without any changes. There are some issues with that with SIP, right? Because as we know, things like IP addresses and some of the networking components of SIP are sometimes embedded in the protocol, and that can make it difficult for a brand new instance to stand up and pretend it was that old instance. But that is probably a little too much for the answer to this question. So.
Thank you, Ben. Do you have any other questions for Ben or his team? They're seated down here. If you really want to get some FaceTime with him, get a few people, start a gang. Our next presenter, coming to us from the beautiful US of A, and SignalWire, the home of FreeSwitch, which is a sister project in the open source community. I'm sure all of you have heard about it. Is Evan McGee. He's going to talk to us about cloning a Mockingbird.
Yes, indeed. And I'm going to apologize to the camera guy right now. I'm going to be wandering around a lot, so we're going to put...
Oh, I thought it's because of the shirt.
Put you to work. No, I could never apologize for this. Alex, if you could pull this off, I'd happily get you one, but we know you're still working on that.
I can't do it.
Okay, all right, great, it's up there, perfect. Let me start my timer. Great, I'm already a minute in, terrific. So, here's the thing, I'm gonna be moving kind of fast. This talk is gonna be all about voice cloning, voice technology, generational AI, and audio. You might have, if you've seen me at a conference recently, I've talked a little bit about the same stuff, so if you've heard this before, I'm sure that the rapidity to which I speak will cause you to need to listen to it again. So, I do apologize for moving fast, but we got a lot to get through. So let's kick it off, right? So let's just state the obvious right now, where we're all living in today. We are living in the future. It is the future right now, right? If you guys remember 4 or 5 years ago, the idea of cloning people's voices and that kind of stuff was impossible in a realistic scenario. You could do it, but it didn't sound particularly great. It took a little while to do, it took a ton of audio, and the results were not awesome. All it really takes is a little AI, so let's back this up. I gave a similar style talk in 2018, where I tried to clone Matt Jordan of Digium at the time, his voice at a conference. It didn't go so well. And we're gonna see here, this is not Matt, but this is an example of the state of the art from 4, 5, 6 years ago. So here we go, let's see how this plays. Go. Nope. Okay, so that's a base language Chinese speaker. Here is taking that voice and cloning it and then trying to put it into English from 6 years ago. Here we go.
A long time ago, the 2nd December, a cup of water.
All right, not so great. Here's today.
A long time ago, the 2nd of December, a cup of water.
Now, why he's British, I have no idea. Why I made that joke. Poor man, British, no idea. But you can tell, a lot more expressive, a lot more emotive, way better. We're gonna get to a better example at the end, don't worry. Uh-oh. There we go. All right, so let's do this. So how does this all work? So this talk is gonna be a little bit of a deep dive into exactly how this process works, right? Who here knows a lot about sort of generational AI and tokenization and that kind of stuff? Raise your hand. Great, okay, a little bit. Who here uses like the chat GPT or any kind of GPT system fairly regularly? Great, awesome. So it basically works exactly the same way, right? When you're doing text, any kind of GPT style text, you're basically generating a series of words that are tokens, and we're gonna get into what tokens are in a second. With voice, it's exactly the same. You can treat audio data as a series of tokens that can then be predicted. This is a general sort of encoder framework over here. Like, you're gonna see this is sort of a base way of doing it, right? You have sort of your input text here, what you're trying to synthesize. You have your waveforms over here that you're actually trying to encode. So this is the training section, and the rest of it is the sort of inside of the network. But the part we really want to talk about is what makes you, you, right? Well, how are you identified differently than any other speaker? Why are things different? And that's that section right here. So the layer right up there, the embedding layers are the important part. So the way that I'm speaking, when you're typing, what you're doing is generating an embedding. And an embedding, you might ask, what is an embedding? So we're gonna take a quick tangent here, potentially unnecessary for everybody. But an embedding is a vector. Who here knows vector math or has linear algebra background at all? Anybody? Great, okay, lots of people. Great, this is gonna be very straightforward then. If those of you who don't, it's also super duper easy. It's very, very simple math. So vectors basically are sets of numbers that have a direction and a magnitude, right? What that means is they start like 0, 0 in an axis and they go some sort of direction, whether that's plus or minus, and go, let's say it's 2 dimensions, so you have this way and this way. You can go up to the right, you can go down to the left. That's all that really matters. In 3D space, it becomes, in and out and back and forth. And as you'll see later, in the number of dimensions we use for things like OpenAI, there's many, many more dimensions. There's somewhere north of 1,500. But it's basically just an array of numbers, right? So let's take an example here. So here is a example, a classic one of word vectorization. This is, believe me, we're getting back to audio in a second, I promise. So these are basically the coordinates in that grid of these words. So all these words against the dictionary have been slammed together, put into a big corpus. These are the actual values of them. So you can see the word royal there actually has a, well, the arrow's the wrong way, but You can see that it has a vector value of like minus 0.3, so it goes backwards. And basically the answer, what I'm trying to get across here is that if you take the word man, which has a 0.7, 0.3, and basically add to it the word royal, you're gonna get king. So I actually have those, the numbers a little backwards, but as you can see, sort of man and woman go to king and queen by adding and subtracting the word royal. And once you change the words into the actual arrays like that, you can see how you can just add them together and then pop up what the next thing is. That's exactly how any of it works, right? Here's a better example of that too. So king minus man. So you get over there, you have king minus man plus woman equals queen. And that all just comes out of the math and that predicts what is next. And that is exactly how the systems work. So when you're doing that at a very, very high level of dimensionality, then you can imagine the world explodes out, right? So suddenly you're not encoding things in 2 dimensions like that, you're encoding things in 1,500 dimensions. In fact, the ADA2 uses 1,536 or 38, and the newer OpenAI ones use less. The more dimensions you use, the more information you can capture out of them, but you're also sacrificing compute, because you can imagine doing math over 1,500 elements is quite a bit more expensive than doing math over like 256 or lower. So you have to really scale the number of dimensions you're doing, depending on kind of the accuracy you're trying to get to. So we're gonna get into what's a token real quick. So tokens, as you might see them when you're doing OpenAI stuff, you're paying by the token. So what is a token? It kind of depends. You can actually define a token any way you want, but a token generally means that you're breaking something up into distinct components that have some sort of linked like presence together. So in this case, the token either takes multidisciplinary, switches it up into multidisciplinary, right? Those are distinct elements of the word that can apply to many different kinds of words. And that's a way to save on the compute power of doing these things. Instead of having to store multidisciplinary and interdisciplinary and cross-disciplinary, it can do cross, inter, multi, discipline, and airy, and combine those with other words. So suddenly you can actually reduce the dimensionality of all human speech to a much more finite state and set. Very exciting, very, very cool, because it lets these things actually move faster. This is one of the big sort of advances made in the past few years that allow all of this cool stuff to happen. So what is an audio token? Audio tokens are the equivalent of those next text word tokens, right? Audio data itself is much, much more complex. So an average 1 second of speech equals about 3 to 5 tokens. So if you do the math out in terms of number of seconds, you actually get to the part where the spoken word is about 50 times more dense than the written word. So you have to actually do a lot more. And there's much more information in here. There is tone, there is prosody, there's anything even carried in the amplitude and the frequency modulation of what we're talking about. There's background noise, and if you're singing, then you have all the tonalities of the music. So it gets to be a lot of data. So inside of that, you have to capture it. To do that, you need to use basically a couple different tools. You're not just talking about what text comes next. You might be talking about what sort of semantic stuff comes next. So you break down speech, you get semantic things, like the actual words that I'm saying, the order they're in, how I'm saying them. And then you have sort of the acoustic stuff, like how's, am I happy talking about it? Am I super sad? Well, is it gonna be hot in here later, and is the AC gonna work? Like, I don't know. You have to make sure that you take those into account. So all of those get encoded differently. And I know, blah, 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 blah. Where are we going with this? Okay, great. So here's how it works, right? You put them into like a phoneme encoders for the text over here. The codec encoder is the one that actually does the acoustic modeling. You throw them all through the system in there into a diffusion model. The diffusion model is the one, it's the generative AI part that actually has trained into it that entire vector field of all these different speakers. So it knows in my voice, if it encodes my voice, it knows that all of my dimensions align with all the dimensions of the tens of thousands of hours of other speakers that it has, and it can place me somewhere where it can clone me very, very accurately. And doing that process takes a lot of data. Doing the actual generation, as you know, can be quite computationally expensive. So anyone who saw the OpenAI announcement yesterday, one of the coolest things that was going on was how fast they were able to do that inference, which should show you how much compute and how much power they're throwing at this. And it turns out that with a few $1 billion, you can make some pretty cool magic. So yeah, here's another kind of example of it, right? In voice, we're also working into ML spectrograms, for those of you who dive into the audio part of it. So we have sort of the source utterance, you got an emotion encoder, and again, you can have as many encoders as you want. How much money do you have? How much CPU time do you want to spend on this? Encode the emotion, encode the content, encode whatever you want. You can have as many of these as you want to do, put them all into the model, and then Bob's your uncle. All right, so again, we're living in the future. This is great for those of you who know Star Trek, The Voyage Home. which apparently is not as well known as I had anticipated when I first started these talks. Anyone watch Star Trek and the Voyage Home, the whales? Great, okay, good, I'm not alone here. It's a great movie for those of you who haven't seen it. All right, so let's go back. So let's talk about the people who are actually doing this for real now that you can use today. So these are the kind of 3 main companies that I have primarily utilized recently. There are many more now. Voice cloning is basically becoming a commodity, as all voice synthesis stuff is. But these guys work pretty well. The clone of voice, you need about 30 seconds to 5 minutes for a regular one. Some say 10 seconds, don't believe them. 10 seconds does not work. 3 or 10 seconds does not give you enough information on a voice, particularly in any sort of long-form narrative context. If you're doing it just like generating text for an IVR, they have to say, press 1 for sales, like that's fine. But if you're doing anything important, you want more data, because people's speech patterns do vary over time. You know, I put a lot of emphasis occasionally, I'll randomly pause, very randomly, and you want to make sure you capture all of that. For the best quality, 1 to 2 hours, if you're doing audiobooks or something like that, or you really need someone's voice to be pitch perfect with all the other ums and ahs, and believe me, it will capture ums and ahs. Now, for a little while there, I think actually it was, maybe not OpenAI, but one of the systems started, like, the system started laughing randomly. Like, you type in text, and it would cough, and like, and then like, or like, oh, and laugh at its own jokes, which was, you know, kind of creepy. But it was clearly they had some training data and there's some audio that had gotten into the system. These are some numbers, again, pulled from Mr. Dave Horton. The first 2 are, the last one I did myself for Murph because he hadn't profiled that one. Dave is a great guy and does a lot of awesome work in the open source world, so check him out. But these are the sort of the time to first byte, right? If you're really looking for something real-time aspected, 11 Labs is going to get you at 906 milliseconds. You know, Play.ht is great. They get it about 92 milliseconds, but they do buffer quite a lot of audio silence at the front, so your actual audio doesn't come through for about another couple hundred milliseconds, so it's a little bit of a red herring there. And Murph is sort of right in the middle. All of them do a great job. All of them are very reasonably priced for what they offer, depending on what you want to do, right? And again, you own the audio that's generated at the end, so if you generate something and it's the same audio every time and you cache that locally, that's no problem. You reuse the same audio. Right? You can do something on your side that compares what you want with a cached audio result. And you can give this, the reason to do this kind of thing is for, you know, any kind of purposes of branding or any kind of purposes of someone who needs like an authentic voice for their own system. They might not want to use the voices that everybody else are using. But then the open source versions, right? And unfortunately, the world is changing very fast. So those of you who know audio might know the Coqui project, and as of a few months ago, it shut down. And that's very sad. They tried to keep up, but this race is changing very, very quickly, and it's a very, very expensive game to play. You have to have a lot of audio, a ton of compute to generate these back-end models. When you're training all of that data on all of our voices, hundreds of thousands of hours, you're burning a lot of GPU time, and unless Microsoft is paying you to do so, you're really gonna have a hard time at this point. So you have to find a coherent business model. The good thing is that, again, for us, as open source practitioners, many of us, there are many models that are coming out that are excellent that we can use for specific purposes. Now, again, you might not want to use them for day-to-day because they have a lot of overhead of running and maintenance and things like that. These are all pretty much experimental or built off of papers that people wrote, but they do have the advantage of being totally under your control. So for things like data residency purposes, GDPR purposes, or any kind of data control access, you can use your own. The granddaddy of all these is Tortoise. This is for real time. If you guys want, Tortoise is the guy, James Bettker was the dude who invented this one. He's a guy on his home computer with 4 GPUs over the course of about 4 or 5 months. Did a great job. He works for OpenAI now, so if you're thinking about hiring him, he is sadly well employed. But he is over there working on probably their stuff that you just saw. But he created this one. Originally, it was called Tortoise because it was very, very slow. Real-time voice AI generation is still pretty slow. It was 20 to 30x real-time. It's now down to 0.2 to 0.3, so you can use this in a real-time context. There are versions of the internet that have even WebSocket adapters, so you can have a lot of fun with that one. Needs that sort of 2 to 5 minutes of audio to clone properly. VoLE is one you'll hear about a lot, and VoLE-X. This is from Microsoft Research. These guys, this is another one. This is an implementation of the VoLE paper by Plachta. But it's great. This one is great. This one is specializing particularly VoLE-X in cross-language. You're talking in, it does Chinese, Japanese, and English. It can translate across all 3 of them pretty seamlessly. So the one we saw earlier does a great job doing that one. It doesn't require very much training data. I found the results to be good, but sort of sporadic depending on how the model works. You, again, want different languages. People are out there trying to do more languages. One nice thing about the commercial solutions, by the way, is that they support 20 plus languages out of the box. So you get that with them. Open Voice is another one. This one specializes in color and tone transfer. So if you're trying to do something like you already have audio and you have, let's say you have somebody speaking very monotone, or you have a recording of somebody for some reason you need, and you need to apply a much more aggressive, like, peppy tone to it. I want to make it sound more like this. Then you can actually transfer that tone and color onto a separate voice and get it up at the same level that I'm at. So again, use cases for all these different things. Unfortunately, a lot of these things all work separately, so they all do very different things. This is how they do theirs, right? This is the Open Voice model of how they do it. This is how speech parameter motion accent goes in, captures all that stuff off the top. The color tone extractor lays on top, so again, it's extracting all the color and tone. They specialize in removing that and building that into the encoder flow. This one is probably the best one that's out there right now for actually doing like English voice cloning, VoiceCraft. Requires about 5 seconds. It is not real time at the moment, but it is getting there. People are working on it. The VoiceCraft one has, I think, the highest quality for English language voice cloning, and I know they're working on other languages as well. Again, it comes down to having and needing tens of thousands of hours of quality audio in the target language, and then quite a lot of other work, and then a lot of GPU to do all of that. So, remember, and all this kind of fun, you've heard a lot about this kind of stuff, now you kind of know a little more how it works. We're going to get into the safety part of it, right? Everybody in every industry likes to talk about how cloning voices and artificial audio is going to destroy the world. And my wife is a journalist, and I talk to journalists a lot about this, and all they talk about is like, oh my God, like the world is ending. They're already scared for their jobs just for the idea of AI writing their stories for them, let alone being able to call their parents and demand they bail them out of jail for money. And it's happened. This is happening right now. It is actually going on. People are using these tools for various purposes. So there's some stuff you got to do when you get into this if you offer this stuff for the public consumption, which I'm not sure a lot of people here will do, but one thing to worry about is audio watermarking, right? You can do this right now. There is one big one out there. If you have to, use Audio WMark. It's probably the most state-of-the-art one that is available today to watermark audio. But this is a big topic. And so coming out soon, WaveMark was a paper just released, I think in January. And WaveMark says, if you look at the radar diagram there, this radar diagram, you can kind of see the blue one is the attack, basically protection from Audio WMark, and the green radar is the one from WaveMark according to their results. So as you can see, it's much more robust against all kinds of different sorts of attacks. And that is coming soon. So if you are in this world, think about the idea that you're going to want to put watermarking in any kind of public product. There is no code for that one yet. And I have it in very tiny letters. It could be you. If you're great at reading papers and want to write this code that does this work, it's out there. It's out there for free. They just didn't want to put the code out because they just didn't. But we'd love to see that soon. So I would keep your eyes peeled for that one coming up. And now I want to give you a little tale for a second. For those of you who read Italian, you can kind of read that while I'm talking. So a couple weeks ago, I was over at the lovely JanusCon in Naples. Thank you so much, Lorenzo. It was a wonderful conference. I highly suggest going to it next year. And I went from there to Istanbul, and from there to Bulgaria with my family, and then I flew back again, and I got back into Pistoia. I'm staying in Italy for a number of months. My family, my kids are going to school there. And I was so tired. I was so tired. I got 1:30 in the morning. It's been a long week and a half. Anyway, I go to the Esselunga the next morning to get some food, and I am from America, so I'm not used to bagging my own groceries. So I put my wallet down while I'm bagging the groceries, and then I walk out of the building, leaving that behind. So naturally, about a day later, I start getting all these random charges on my credit cards. Why I've been carrying them, I don't remember, but they had clearly been stolen by somebody, and they were racking up fees of about $1,000 a minute at some boutiques around town. So naturally I call, and I'm like, I would love to get that back. And I call, I go to the bodega, the boutique, and I say, hey, did someone just come in here and buy $1,000 worth of women's shoes? And she says, yes. She has the receipts, and on the receipt, the person had put their phone number. And I was like, well, that's not very smart. So I took that phone number, and I threw it to WhatsApp, and sure enough, it popped up, and I wrote to them the following message, right? And I don't speak Italian that well, so this is through Google Translate, as well as my poor Italian, basically saying, before I go to the police, I would love it if they would give me back my wallet. I don't care about the money or the cards. I really just need my driver's license, because that's the biggest pain in the butt to get back in the States. And I can't rent cars, which means my wife has to rent cars, and she is not a huge fan of having to deal with that process. So anyway, I call her, she says, no, I didn't have it. You can read it in Italian. She basically says she bought them for 500 euro off a guy on the street. And then she'll leave me a voicemail on WhatsApp. And again, I don't speak Italian. So here's what she sounds like when she is giving me the voicemail.
Ciao Evan, spero tu possa capire il mio italiano, perché non so se parli italiano o inglese. Volevo dirti che sono già venuta io in questura a fare la...
Okay, great, awesome. But I can't use Google Translate for that, right? And it's not baked in here. So what did I do? Well, I walked back over to some of the tech that we use, and I got her to speak English.
Subtitles created by the Amara.
Hi Evan, I hope you can understand my Italian because I don't know if I speak Italian or English. I wanted to tell you that I have already come here this hour to file the report.
She did not go to the police. She did not file the report. But that was the use of the voice cloning stuff with the voice dubbing tools. So that's her voice dubbed over into English in the real-time stuff. That was, I believe, an 11 Labs product one right there. But a lot of them offer that now. Voice dubbing is another thing. So the reason I wanted to give this example is that, first of all, you can hear how good that sounds. That sounds just like her, in my mind, in English. It also nailed the translation. And it nailed all the aspects of it. If that were baked into the WhatsApp product, that would be sort of an incredible thing. You saw a little bit of that again yesterday with OpenAI. So all of these things are coming very, very soon. And baking them into the products really is the name of the game. As an update, I did go to the police and file the report, and they were like, you're never seeing that thing again. So, but the Carabinieri area were very sweet. They were very nice. Oops, yeah, there we go. Okay, great. So we're gonna go a couple more last little things here. Again, if you're gonna go through this stuff, I know I have just a few more minutes and I'm gonna get to questions, but I got 5 minutes. Thank you, Alex. Hot five, guys. Okay, here we go. Let's rock through these. So a couple more uses of AI in here. I know for those of you who, again, with JanusCon, I did this game, so no cheating, no cheating. There's a bad audio segment in here. Part of the problem with generational AI is it can have like audio artifacts, particularly if you jack up a bunch of the parameters where you're turning up the ability to give more emphasis or tone or whatever else. You can really change the weights and it can make it sound all kind of wacky. So who can spot the bad audio in here? Just kind of like point and shout. Which where? There? Yeah, somewhere there? Okay, I'm gonna assume you're correct. So yes, this is the bad audio segment right there, right? You can kind of see it. But you know, from the waveform, it doesn't look terrible. You couldn't really tell. Again, and also, audio being a continuous data stream, how are you able to detect when there's bad audio? Well, you can change it into a MEL spectrogram, and that makes it a lot more clear where the nasty stuff is. Much more visual to see. But again, you're like, great, I still need to detect this in a scenario where I can fix it. This works particularly well in a offline generation aspect, where we're generating lots of stuff in advance. In a real-time scenario, you'd have to do this a little bit more quickly. But you can also use vision AI. So we trained a vision AI to actually know what good MEL spectrographic data and bad stuff looks like. So as it goes along in a windowing feature, you can actually see it. So don't just think you have to use AI in audio or text only. You can use vision stuff to detect vision problems. So look at MEL spectrograms for any kind of that data. You can also spot this bad audio segment. I'll just go through this one quickly. Is right there. It looks the same, right? This looks like there's nothing there that's like that special, right? It looks just totally normal. The spectrogram gives you a hint that it's wrong. You're like, ugh, that doesn't look right. But it doesn't get all of it, because that section also sucks. That section sounds like her, the woman saying, yeah, go on. And then the next part of it's just like stuttering. So you gotta find all of that. So what's the way to do that? Well, the way to do that is do something like Whisper, right? You can use Whisper from OpenAI, or you can download it. Whisper is the word level timestamps with confidence. You run the entire thing through that. You understand that what is being generated actually is real words. It gives you a confidence score. So if it knows that if you're doing English and a number of other languages, that it would not be very confident that what you have is intelligible. So you can regenerate that section of the text again, see if it gets better. If it doesn't get better, then you know that probably there's something in there that's either a problem or it's meant to be pronounced that way. Whisper timestamp also runs very, very, very quickly. So you can build this in your workflows very easily to detect any kind of thing. Whisper timestamp is also great if you're just doing speech to text. And that's it, everybody. So I hope you took away from this a couple fun things. One, a little bit more background on how this stuff works. It's not magic, it's just a lot of math. Maybe hopefully thought about some of the ways the open source stuff can apply to your particular use cases. If you have any questions about it, come find me. I love talking about this stuff. And now, I appreciate your time. Thank you.
I have time for 2 questions. Who's my first question? Come on. Well, you were thorough. It's quite apparent. What? Well, here we go.
Okay, so going into the future, like, there is like a lot of doom and gloom for voice cloning. So what would you propose as being solutions other than kind of the voice print to prevent bad actors from using this technology?
Sure. So, just take it easy. I would say the biggest thing that's really going to come up here is that that bad actors will use it. Part of it is going to be much like the way when Photoshop was developed. It's like they use, right? Everyone knew for a while people were like, we can't trust images anymore. And over time, people learned how to detect what was and wasn't real. A lot of it's just based in context. You know, if you're looking at a beauty magazine, all the images are probably touched up and faked a little bit. You look at Instagram or anything like that, these things are not quite real. It's going to be that way with audio and video as well. And I actually take a lot of solace in the fact that my kids, who are 8 and 10, are much more aware of what is and isn't sort of factually real. They do get confused early. We had to walk through some stuff like how things were done for them, but they're pretty good at knowing like what is fake. I think for people, you know, our generation, slightly younger folks who are not as used to being skeptical, it really is going to come down to knowing like the context of what's going on. You know, would your family members ever expect to receive a call from you asking for money, or would you get a call from the IRS? Now, these are confidence scams that exist in SMS today and everywhere else, right? I have a good friend who, you know, a smart guy, really great guy, you know, was just kind of like, just went in for one of those texting with the random person in, you know, Korea for just loving, like, he just wanted some of that sort of reciprocal love element. And if she had been able to call him and sort of fake that audio, it would have pushed that a lot further. So it certainly is an area that we're entering, and I think that the doom and gloom aspect of it overshadows the positive effects. A quick other tangent is there's a singer out there, anyone who's a country fan, of which I'm not particularly well versed, there's a singer who lost his voice a while ago, 10 years ago. He had stroke, complete paralysis of his voice, can't sing anymore. He just released his first new single last week, or earlier this month, because his producer used AI of his voice to clone him, and then had another singer back it, and his family couldn't even tell. And so there's many, many, many positive and awesome aspects of this, and we can talk about that forever. But the doom and gloom part is also there.
I need our next speaker to come up here while we're getting you ready. I'm going to take one more question. If I'm correct, there is another speaker coming, right? Or are we at the coffee break? Are we? Is it time to drink coffee and wake up? Yes, indeed. This is true.
One more thing to mention, I know Dan already talked about going to CommCon. I would also second that one. If you enjoyed this, at CommCon, I'm going to be talking a lot more about the actual industry use cases and this kind of stuff for all kinds of things, and the fact like how NPR uses this kind of technology and that sort of stuff. In London. So get your tickets to the one in London.
Or San Francisco.
Or San Francisco.
No,
but
London only.
If you want to see Evan, it's London. Okay, so there is not another speaker. Did we have another question by chance? No? Okay, if there's anything I want people to take away from that last bit of it is, don't subscribe to fear.
Exactly.
Okay, we're gonna get through it.
Fear is the mind killer.
Exactly. There is no gloom and doom, there's only possibilities. Some of which might carry misfortune, but it's not all doom and gloom. So with that, my colleagues, I release you to the coffee break. You have 30 minutes, get out there, enjoy it. This is brought to you by SIP Pulse. Flavio, thank you for watering us and feeding us. there's a rumor going around that there's going to be a raffle tomorrow, and some prizes are going to be given away. I did hear an engine start earlier today. That's not going to be one of the prizes, though. So. But there are going to be some cool prizes. We'll be talking about them a little bit later through the day. Just make sure that you guys are here tomorrow, because being present is really the only requirement of winning a prize. Okay, so I'm going to introduce to you the master of disaster, the grandfather of the back-to-back. Giovanni Maruzelli comes to us from Italy. He's going to be talking to us about, well, 5G, IMS, all that stuff.
So, that's me, but the important thing for this presentation is that people told me that there are no colors, no pictures, no animations. But I have an explanation for that. There is an inclusive presentation for the visually impaired. So it will be more an audio presentation. So, what is LTE and 5G? It's only internet through radio. All the other things has nothing to do. 5G is like Wi-Fi, glorified Wi-Fi that gave us very fast bandwidth, latency, jitter, and this has a lot of usage, particularly into buildings, into the processing plants, all the private 5G networks that are springing wherever now we have Ethernet or Wi-Fi. IMS is, on the other side, what the carriers at that time devised as an extension and embracing of SIP for their internal use. So it's a vast superset for managing quality of service, security, authorization, scaling, etc., etc., etc. At the end of the day, it's still SIP in some way, but we will see that it has a lot of things. Why this is interesting for us? More or less because the market for all that is services has moved toward IMS. So carriers open their platform so they can interact with us as a solution provider or a technological partner to give services on top of their own core. So why we're interested in that? Because we want to stay relevant, make business, and continue with our technologies. We can see mostly 3 big markets, and it will be giving to enterprise or public administration voice services on top of their 5G infrastructure. RCS, that is, let's say, instant messaging glorified on an IMS platform, and all the breakout external application server for that connected to carrier RMS, for example, internet banking or whatever that is sent out. Now we're going into the core of this presentation, and we'll try to aim to lay down a common framework, very simplified, but that will be useful to understand then the presentation of both Razwan and Liviu about how IMS is implemented into OpenSIPS. But at least we need to know what is IMS and how it works. And because there is a lot of mystification and esotericism and difficult terms, etc., at the end of the day, we will see that it's kind of easy to understand. So, a call comes from a device, a smartphone. It passes through the tower, the radio tower, and from the radio tower, it goes into the EPC or 5GC, so the packet core. The packet core gives internet connection to the device. Most of the time, there is nothing more. I mean, because the device is just connected to the internet and is not interested in making a call. When the device is actually making a call, video call, audio call, or an RCS, like SMS, is at that moment it uses the internet transport to like we do in our voice over IP. So it will go and connect through a form of SIP to our IMS core. The IMS core is the TCP/IP voice over IP internal into the LTE or 5G. That's it. So let's see how we structured that. So we arrive to the packet core. The packet core checks what is into the SIM card, to give the device access to the internet. When the SIM card is validated with we will see the various things into the SIM, but when it's validated, then if a voice or a call is established, then again this destination is checked with the same database that has checked the SIM to see where that call has to go. Then at that point, that DB will understand if the call is for another device, it will send back to the radio and arrive to the other device. If the call is mapped like a dial plan to a service, that DB will send the call to the application server, for example, for a voicemail. That's it. This is all IMS and 5G. Then let's see a little bit more details. So from the bottom, the device arrives to the proxy CSCF, and the proxy CSCF interrogate the interrogating CSCF that then choose which one serving CSCF will use, and then it speaks with the home subscriber system, that is database, location server, and all that. At that point, it will go to another device, like exactly the same thing back, or it will go to an application server for the internet banking of the situation. Now, let's see each one of those steps. Device and radio. So, don't try to do, not actual things. Anything is fake. The soft phone doesn't work, emulation doesn't work, nothing works in a reliable way. Also, if you want to experiment, try to steer clear from software-defined radio, USRP, all those things. Very nice, I mean, you can have a lot of fun, but then you have 1 meter between the radio and the cell phone, and you will have a lot of headaches to make it work. So buy on a real tower, small one, but a real tower on eBay. I used one and it will work, and it will work for like 50 meters, and that's definitely something. Then, after the device entered the platform through the radio passes the device to the core. The core is typically Open5GS, just to understand. The core consults the HSS, the home subscriber system, to check the identities on the SIM cards. And the core, at that point, give internet connection. So the device now has branched into the network. Then the HSS will understand where to send the device and the call to someone else, or just to use the internet. What is the HSS? HSS is one of the most important parts of IMS. It's the home subscriber system and is the sancta sanctorum of a carrier. There is the most protected and scalable database possible that, I mean, all Vodafone is run on HSS. And it has dual use. From one side, it speaks with the packet core to validate and to understand the identity on the SIM card. From the other side, it speaks and interacts with IMS to understand where to send the calls. So it's actually both dial plan, user location, and service mapping. And eventually, if it's not in the internal platform, the HSS will understand, we will see how, where to break out toward external services, application server. The IMS, call control function of IMS are implementation of SIP proxies. And particularly the SIP proxy, as we are used to, is exploded into three main names. That is the proxy, CSF, interrogating, and serving. Those are, we often use one of each, but in real implementation, you have dozens and dozens of them, because you need to scale and you need to have all the proxies that are near to the edge. I mean, each tower has its own, etc., etc., etc. So, very big infrastructure. And the user location database is the HSS. So, actually, you have the both the interrogating and the serving that takes care about where there are registrations, but the database, what will be Postgres for us, actually is the HSS, that usually is a NoSQL. HSS has a very nice structured way to organize information, to query information, etc. You have regular expression, but you have also nested condition. You can check, for example, is that user registered, and what time is it now, and the regular expression of the destination is this and that, and based on all these, you will have an answer from the HSS that will tell you where to send the call. The application server is then what will interact with the call if it's not for another peer, if it's not for another device. So it can be voicemail, it can be weather report, it can be whatever media server or business logic server you implemented. And this is a huge space for our services to be sold and connected to carriers like over the top, so as a breakout and not as an internal part of their infrastructure. The call state control function is what in IMS is the role of a SIP proxy. And you have those different names that were used to see compacted into one only proxy, but we saw that for scalability and reliability into big infrastructures, those are actually branched in stars and in graphs that extend from the center, and the center can be seen as the HSS, the home subscriber system, to the edge, to the proxy that is stay on the tower near the radio. So a call comes in, the proxy speaks to the devices, and speaks to the devices in AKA, so in IPsec. And the proxy asks to the interrogating server what to do. The interrogating server chooses which HSS to speak, and the HSS tell what serving proxy to use, so where to branch to stay closer to the edge. And yes, the serving will ask at its turn to the HSS what to do with the call, if it's for another device or if for an application server. And each one of the kind of core CSCF speaks an MX SIP, that is the SIP extended for IMS, while the application server speaks ISC SIP, that is kind of different, but the important thing is that they have two different interfaces to speak with the home subscriber system. And those different interfaces are justified because their role is totally different. The SCSCF, those are the internal into the carrier or into our infrastructure. And so they can do, they're powerful, they can know things, they interact with the subscriber, with the authorization, etc., etc. From the other side, the application server has no those rights. The application server has a very small subset, but consistent, of interaction with the HSS. So, for example, can update and read information that belong to them. All of those roles, so both the application server and the CSCF internal, can be OpenSIPS. The role of EPC and the role of packet core, we mainly use Open5GS, And as a home subscriber server, we use PYHSS. And this is a base cell, or you can have a tower, Huawei, etc. Those are commercial devices that you use, that were mainly developed to give connectivity to camping, or an area of 100 meters. So you put on an antenna, etc. And they are very sturdy, and they're perfect. You just put it into power over internet, and it works. No bizarre things, and I can guarantee you that you can have many nights of fun with the software-defined radio before making it work. And from the side of USIM, you get SSICOMMS, that is kind of standard for interacting with our things, and that's you just go to the website and buy. And into the SIM, you have many identities. A SIM, a USIM, is a very, very common, it's actually a computer, and it's very complex as an object, but for what is our interest, we can think at EMP and EMPU. The EMPE is the, let's say, secret code that gives you access to the network, to the internet. The IMPU is your user identity, like your telephone number. So it's used then to generate both the URI for SIP and TEL. Then SIP and TEL are different URI, and both can be telephone number, and it's interesting how to deal with them, but it's a little bit too much detailed. And the EMPI is for the packet core, so it's the one that you check to give connectivity. The IMPU is for routing calls and services, and the SIP user that is derived from IMPU is what is actually used by the IMS core and application server, so by OpenSIPS. Another great area of interest is APN. When the device connects to the packet core, is given by the packet core an APN. APN, you usually have at least two, one for internet, one for IMS. So one for connectivity and one for calls. And very often you can also have a third one that is for emergency services, like call police or things like that. And those three are like managing quality of service, bandwidth, delay, jitter, etc. And it's just incredible how much engineering has been done into that, and it's actually reliable. I mean, it's incredible, but it's reliable. Particularly on 5G, it's actually reliable. This is okay. And they told me that I have a very little time, so I'll try to go fast. With all that I described up to now, we're able to register a couple of devices into a packet core and an IMS, and route calls between them. This is our port. And And then has exactly like in diaplan of free switch or in diaplan of OpenSIPS, if the HSS will interpret the destination, it can decide to put it toward an application server that can be internal or external. And the IFC are the triggers and the actual way that the HSS implemented the dial plane. So just memorize this name, IFC trigger, and there will be where you will put a lot of effort into. And another, the last two interesting things is an application server that is something external from the Sancta Sanctorum has a way to interact with HSS. So, for example, it can receive the registration each time a device registers itself to the IMS. A copy of that registration, with much less info, will be sent also to the application server. That's from one thing. The other interesting thing is the application server can ask to HSS to be updated in real time each time users do things, change status, get registered, unregistered, or subscribe, or change, for example, their subscription to a service. And this is how external application servers are integrated into the carrier offer. And now I'll get some questions, if there are, and because I think that I used all my time.
Wow! I'm stimulated. That was amazing. I hope all of you are really now getting a deeper view and a dive into what we're talking about with all the IMS changes in OpenSIPS. Do we have a question? One question. Okay? He had his hand up first, folks.
Yeah, just a question. As I got correctly, the HSS is the only, let's say, the central database that is holding all the information about the user. Means there is no smuggling databases information about the users that's smuggled, let's say, smeared across the IMS.
Absolutely not. HSS is an incredibly complex structure that actually the HSS actually contains all kind of information. But from rights, profile, what is the services that a user subscribed. I mean, all the knowledge of Vodafone about me is into the HSS. Obviously, one thing is what the internal infrastructure of Vodafone can know about me, and totally other things can be known by, I don't know, the my internet banking that interact with HSS, but from a different interface. The home banking interact with the HSS through the SH diameter interface, while the other one is the normal internal, I mean, a much more powerful thing.
No, hey, what? Don't. That's my job. Let's give Giovanni a round of applause, everyone. Thank you so much, Giovanni. So what we're going to kind of do here is we're going to smush two presentations into one. These two were inseparable at birth until this one was declared Jesus. I'm sorry, Livia. Life's tough for all of us. You look like an Abraham, though. Liviu and Razvan are in the OpenSIPS project. They have been heavily involved in all of the IMS work, and they're going to talk to you today about building a CSCF IMS component and in various steps. So, gentlemen.
Thank you, Alex. Right, so I'm Liviu Kirku, and together with Razvan Kraina, we will go through pretty much a lot of theory in this hour, and so it's going to be quite a marathon. In my part, I'll be kind of talking about IMS, and then the interfacing that happens around the components where we can use OpenSIPS for. So a bit about what Giovanni said, but kind of with a different info around it. So hopefully there's not that much overlap. And in the second part, Razvan will go through the concrete changes with the authentication support, which was added in OpenSIPS 3.5, which is not sure if Bogdan mentioned, but it's in beta release phase right now. So we are on a month and a half of testing for all of this new code that has just been pushed out. Yeah, about IMS. First of all, who is making, sorry, I mixed up the slides. So the IMS is, like its name says, it's a subsystem of 4G or 4G, 5G deployment of an MVNO. And it's what interests us for the OpenSIPS project, because we can, or it pertains to components that we can build with OpenSIPS, right? As long as there's not much point focusing on other components such as the core or the radio part. It's got, the simple idea is that it's a bunch of specifications or guidelines. It's a framework, and the more you follow it, the better you will interrupt with other carriers and operators, and you will kind of speak the same language, right? Because it just adds abstractions on top of what we are already building our platforms with in terms of VoIP. So who is drafting all of this stuff? Who is making all of these specifications? Which, by the way, they are quite a number. Yeah. I'll get to how we can churn through all of these specifications and how we can get to what we want and make sure we are following the correct version, because you can get lost. Between all of the releases that the 3GPP puts out. So 3GPP is an association of standards committees. So they pretty much, it's the standards committee of standards committees. So you got people from a lot of countries. These are the main organizational partners. You got people from the US, from Japan, from Korea, China, and India. Oh, and of course Europe with the Telecommunications Standard Institute that validates everything. So all of the drafts put up by 3GPP actually need to be validated by the ETSI ultimately before they are officially released. And with the IMS, this is kind of what it looks like. The OpenSIPS components will go here into the IMS core in the middle. Oh, sorry, where's the camera? Oh, you're falling. Sorry for making your life hard. Okay. So let's go through a flow of data from the user equipment and see what kinds of components it goes through. Most of these which will be implementable with OpenSIPS software. So first you have the entry point to the network. You can come in via either via radio or fixed line, or via the PSTN or wireless. And now you hit the entry point, the proxy call session control function. And here we are in the IMS network, and here we have a bunch of protocols. Most of them are IETF. You get SIP and SDP, MSRP, and in the new specs they recommend HTTP2. I'll get to that. And we actually have a demo on Thursday with how we can build HTTP2 interactions, both acting as a client with OpenSIPS as well as acting as a server. The entry point is, as I was saying, the PCSCF, and it often offers also SBC features, right? Topology hiding, cleaning out those via headers and hiding the details of your platform from the user equipment, the outside entity. And pretty much the most important part is this the IPsec interaction over the GM interface with the user equipment, and that's where a lot of focus has gone for this release with the 3.5. You will notice the new proto IPsec module that Razvan pushed out. Next, it's the kind of the edge of where the administration of your domain starts, and that is the interrogating call session control function. It is typically deployed together with the SCSCF, or either in the same rack or either on the same software instance. Because the ICSCF pretty much only is responsible for selecting the correct SCSCF to process the call. Next, of course, we are on the SCSCF, and here's where a lot of the service happens. You get routing of SIP requests. There is the billing handling, SIP session timers, and also the user registration takes place here. And as you can see on the diagram, there are lots of interactions, both via SIP with a full line or via diameter protocol with the HSS. As I was saying, I'll also get to these specific interfaces, and we'll go through them one by one, and also in which technical specification you can find more information on in just a minute. What other stuff is of interest here? Of course, as Giovanni mentioned, you've got the HSS, which is pretty much the main storage of data, and a bunch of components interact with it. So of interest is this interaction with the serving CSCF, that it will handle the authentication part. So you get some message exchanges such as the MAR, where it pulls the authentication vectors from there, but as well there is the TAS, the application server, that also it can pull profiles, and we'll talk more about that as well. And you can have multiple HSSs, and that is where you will need an SLF, which it decides which HSS it should use based on the given call, on the user that placed the call, of course. Other useful info here are the MRF. Is the MRF function, which and it handles media-related services, right? You get voicemail, announcements, transcoding and multi-party conferencing, all of that. It's as part of the MRF generically. And of course, there is the circuit switched part of the network, and the interaction there, you need an exit point. So that is the gateway functions. That is the exit point is the BGCF, the breakout gateway, and the call will ultimately reach the PSTN through there. Also on top of this is the service side of things, the TAS, and you get a lot of telephony services here, from redirects, from proxying, and yeah, pretty much. And where does all of this stand? This is part of the VoLTE framework, which was released in 2010, and it offered faster call setups. You had redefined voice quality and less background noise and video calling. And this is kind of how everything fits together. We were talking about the IMS core, and in the VoLTE specs, they define the EPC core, the Evolved Packet Core, and how all things line up using the interfaces. In terms of OpenSIPS and what we have and what we are missing before being able to implement all of these specs. In terms of SIP signaling, there wasn't that much missing. There were some things added, maybe in the last release, in terms of the RCS. There were some processing that needed to be added, a couple of functions. But apart from that, it's all just RFC 3261 logic, and from there it's only a matter of defining whatever headers custom headers, of course, they included the specifications from 3GPP. So all of that is fully configurable from the OpenSIPS configuration file. Next, of course, there are the diameter-based interactions, and that is where some things were missing, and we took care of them gradually. The first, this is actually the third year, I would say, where we have been slowly moving towards finalizing the IMS, fully the IMS 4G support. And we started with a diameter client that handled the basic methods, maybe an authentication and a CDR writing method, and then we iterated on that and then added generic client support. So now this was in 3.4, you were able to build generic diameter requests and basically implement a lot of these interfaces. And for this release, for the 3.5, we also, and thanks to the IMS work group, by the way, thank you to Giovanni, thank you to Karsten, and thank you to everybody who got involved. We learned that there is also a requirement to act as a diameter server. So components such as the HSS or I can't tell them off the top of my head, I'm not that good at IMS yet. They often need to invoke either the SCSCF or maybe even the PCSCF. And in order to do whatever processing that's required. So all of that has been added as well in 3.5. So without further ado, let's go through these interfaces and what they look like and kind of what is the responsibility of each of them and what protocol it functions on. So this is a rework of the previous diagrams. You can also see the IMS core, although it's in a bit more detail now. And we see the interfacing. With yellow, there is diameter communication, and with teal, there is SIP protocol. Both of these are control plane. This is the control plane, and what it means is that it is internal. Whatever is outwards or facing the user equipment, or maybe the interconnect equipment, you may get interconnect with a foreign network, is considered user plane. So that is in green. And one of the first interfaces is so now let's cover the diameter first. Let's go through all the yellows. Of course, with the IMS core, we don't care about this. GY or GX interfaces, it's not we're not going to solve them too often or in the foreseeable future with OpenSIPS. And one of the first ones is the RX interface, which is, it dictates session policy. It is invoked both during origination and termination of calls, so it's quite heavily used. And it is used to allocate resources for call and that kind of stuff. All of this is in, you will also notice this acronym, TS, in the 3GPP lingo. It stands for technical specification. So this is covered in TS 23203 and 29214. Great. I forgot to turn off Slack. I won't do that. Next, the CX interface, also quite a big one. It dictates interactions between the serving CSCF and the HSS. And it's used for pooling profiles, and also used during registration, authentication. All of this is described in 29228 and 229. Next, of course, the SH interface. We've been hearing about. This is actually interaction between the TAS and the HSS as it makes requests for user profiles, or it updates those profiles. There is the PUR, profile update request. You can also subscribe for notifications, so whenever data changes in this database, right, because maybe the TAS isn't the only one who writes to it. So now the TAS can subscribe with an SNR, the subscribe notification request, which is matched with the profile notification request. And notice how SNR, you're acting as a client, right? You're the one pushing it. The TAS does the SNR, but the push notification request is backwards. So now the HSS invokes you as the TAS. So this is a clear example of when you need to act both as a diameter client, as a server, and as a server. And of course, you should be able to build a task with OpenSIPS. This is covered in specification 328 and 329. And finally, an interface that's not often mentioned, but it's of course it's interesting to note, the RO interface. Of course, we have telephony, and you must have charging, right? So this is the online charging as you interact with the OCS, the online charging system component of your platform. Also fully covered in those two specs over there, 32225 and 299. And that covers the diameter of the VoLTE specs. And let's continue our journey with the SIP and SDP interfaces. And the first one is, of course, facing the user equipment. And this is the GM interface, as it is hooking into the PCSCF and entering the IMS core. And here we have the registration and the authentication, which is mandatory here. It's in 4G, there is AKA version 1, and in 5G, actually they deprecated AKA v1 in favor of AKA v2. Of course, this will establish an IPsec tunnel, and Razvan will be describing in more detail how all of this works and how the new module is expected to behave. Next is the interaction between the PCSCF and the SCSCF. Actually, this is the MW interface. It is actually an interfacing between any CSCF, really. And in production, it's typically physically separated from the GM, right? Because now you are, all of a sudden, we are talking about an internal interface to the same PCSCF, but it needs to be, from a security standpoint, right? You need to physically separate the two. Next to it is a similar interface, the MX, pretty much used for interconnects with the IBCF, the interconnection border, with, of course, two other IMS networks, because all of these need to be interoperable, and yeah. What else? Then we go to the SCSCF, needs to interact with the TAS, the telephony application server, in order to request various services from it. All of this is SIP, so just custom headers, everything described in that monstrous of a document, which is the 24229. It's got 1,250 pages, or something. I don't know, I can't see from here. It's somewhere along the 1,100 pages. It is a huge PDF. And of course, you don't have to implement all of it, right? You can just head over to what section you're interested in and follow along that chapter. Like Razvan, for example, yeah, there is a part with the AKA support in that document. It's kind of, yeah. So now let's move towards the two remaining areas of the IMS core. So it is the CS part, right, the circuit switched to connect to the PSTN. And there is this MG interface where we communicate with the MGW, the media gateway, and the MI, which it's around the same concept, but now you get a media gateway selector, the border gateway control function. Yeah, it selects the MGCF. I'm getting a bit lost in all these acronyms, so it's, yeah. And last but not least, the media-related interactions with the media-related functions for all of these supplementary services. This is done through the MR interface. As I was saying earlier, transcoding, multi-party conferencing, tones, announcements, all of that. All right, so what is the next step? All of these were specs drafted in 2010. And 3GPP, in 10 years later, they had already pushed out drafts for 5G, which promises better codec support. You get that adaptive multi-rate wideband codec, the AMR wideband. 5G also comes with faster call setups, all kinds of low latency capabilities, but there are also drawbacks. I mean, the drawback is related to the signaling itself, to the radio, the frequencies which shorten the distance to the 5G antenna. So that means you might run out of signal, and they predicted all these problems. And the solution to that was that you are kind of required to also keep your 4G network. You cannot just build a 5G only network. So if you look at, yeah, maybe for like a playground, sure. But so this is kind of what it all looks like in the big picture. Notice the IMS core is there. There's not much change to it in the 5G specs. And now they came up with a new 5G core, but there is also the VoIP packet core, the EPC, that's still there. And interesting to note here, the color of these lines, we went from diameter, right, which is here, it's gray, to these blue lines, which is HTTP2. So that is the main difference in terms of what we need to add to OpenSIPS in order to support the next generation of specs. we go from diameter to HTTP2. And of course, all the interfaces have changed. So all we discussed earlier with the RX interface and the whatnot, your CX is your MG, all of that is redesigned, rethought, and there is a new bunch of drafts. Again, tens of documents if you search through the portal. Just let me check the time. I've been standing here and I'm not sure if I'm going over. Oh, perfect. So 5 minutes is right on track. And I guess that's all there is here. And yeah, as I was saying, there is only a need to fill this gap with the HTTP 2.0 support in OpenSIPS before we could declare it ready to build 5G components with. And 5G also comes with, this is the fallback mechanism. It's hopefully we have all of it that it takes to achieve it. We are still, let's look into finalizing the 5G support first, and then we can go into all these fallback specs and see if there is anything missing here. But hopefully it should all go smooth. And I wanted to show you kind of some quick examples of how you can dig through the 3GPP docs and how you can navigate all of it and find your way without that much hassle. Let's take the SH interface, for example. And what is it, of course, with the between it, just quick reminder here, it pertains to the interactions between the HSS and the TAS. And one of the first mistakes you could make is just Google for it, right? Okay, give me the HS interface. You will find it, right? ETSI spec, all good. But the problem is it doesn't correctly sort the version. So you could be all of a sudden following along the wrong document. You could be doing some outdated spec. Instead, just go to the portal. They have a search box over there. And you can locate the exact spec number, and you learn about, there is a versions tab there which shows you the latest draft. Some of them might not have been yet validated by the ETSI. And speaking of that, this is how they validate it. So this is the, of course, it's a small, the process is much more complex than that. They don't just put a 1 in front of it. But from our perspective, that's what it looks like, right? They take your PDF, into their PDF, they put an ETSI header on it and the 1 in front of the number, and that is the approved spec, right? So on their website, they actually do a very nice job of listing all the documents. And by the way, now we know what to search for. We see that the latest is version 17 here, and we can. They have a nice directory listing. Everything is in there. You can always get to the latest draft just by manually digging through it. Actually, if you go to this URL here, I actually have it bookmarked, so everything is reachable. For example, here they started. So this SH interface started in 2002, and it iterated for 20 years, and we've gotten to release 17 of the SH interface. And what changed in 20 years? First of all, the diameter app code has changed. So this is an example of how you could be following along the wrong specs, right? Just make sure you're always on the latest. This is a Warwickshire capture of what these diameter packets look like. By the way, if you're not familiar with it, it's just a list of ADPs, really. Key value. That's all there is. There is a key and a value here. You got username, CP, realm, SIP domain. And that's how the data is conveyed. And this is packed into requests, right? You get, this is your pulling data, you are pushing data, and you're subscribing to notifications using these opcodes, right? The operation, the command codes, which, by the way, they've changed as well for some reason. From 1 to 3.4, they have a bit more refined. Nowadays, it's 306 to 309. These are the 4 requests. And with these changes have come a lot of new AVPs, right? The complexity of the networks has grown, so starting from just 8 AVPs, we get now maybe 35, and it shows the kind of the breadth of information that is to be absorbed in these documents. There is a lot of stuff going on. Also, the error replies have changed as well, right? From just a few errors to a bit more exceptions to be handled from these components. And with that, I hope there was enough theory, and I will let Razvan go through the CSCF and how the authentication works in 3.5.
Thank you, Livio. So, as you've seen, and for those of you who have played with IMS, you might have seen that it's a mess. It's a lot of documents, it's a lot of specifications, a lot of versions as we've seen so far. And from the development point of view, you need to somehow take a step back. Try to see what's useful from that huge documents, what's useful for me and what's not. So this is what I will be trying to tell you and to show you is how we took a step back and how we developed everything that we have so far in order to support IMS. This is the diagram we will be working on. So let's stay here. This is a diagram. So basically you have a device, you have a phone, and you have a core network. And the first protocol that you use the telephone needs to connect to your network, and it connects over radio, as Giovanni said, to a radio station, and that converts it to, that creates basically gives it an IP connectivity or an internet connectivity. And then we have the IMS core, which is a subsystem of the core network, that provides the voice or video calls. It has like 3 components, the PIMS CSCF, it has an HSS, and well, how it works. So when you want to make a call or when you power up your device, you need to register on the network so that the network knows that you are there and you are now available to receive calls. So how it works, you simply send the SIP register. This happens either on UDP or on TCP. There are several methods of describing where, or discovering, sorry, where the PCSCF is. You can store the information in the SIM. As Giovanni said, the SIM is not just a dummy, thing. It's actually a very complex device. But the idea is that the specifications say how you can discover this PCSCF. I'm not getting into details because it's not something that OpenSIPS can do, or it's usually a configuration stuff. As soon as we get the register, well, we will send it to iCSCF. Why? Because iCSCF is the one who knows who's responsible, what service server is responsible for that register. And how does it do that? Well, it goes to the HSS and say, hey, who should be handling this? User, UE stands for user equipment. Who should be handling this user equipment? It basically sends a UAR, user authorization request command over diameter, asking who's responsible of handling that this user, identified by IMPU and IMPI identities, as Giovanni said, and in return it gets a new URI. It says, well, in our point, this SCSCF can handle this SIP register, and we simply send that SIP register to the SCSCF. Of course, we may have many, because that's why we need the iCSCF, right? But to simplify this diagram, I only used one. Now we got the register on the CSCF side. What should we do? We need to authorize the user. We need to make sure that it's one of the subscribers we know. How do we do that? We go to HSS and ask for authentication. This is what the multimedia authorization and authentication request does. It basically goes to the IMS core and to the IMS HSS, to the database, and says, ask him, how should I authenticate this user? Now, there are different methods of authentication. I only put two of them because those are the mostly used ones, but there are others as well. But the idea is it depends, because it depends on the profile that you have, it depends on the device that you have. Most of the devices don't actually allow SIP digest, although the specification allowed it, they don't recommend it. So that's why to enforce security, user devices don't actually use it. That's why you may find some devices that do it, but not all of them. Most of them try to enforce security, and that's why they try to use this IMS aka authentication method. And we didn't have this. We didn't have it until this release. What it was supposed to do, it's basically a protocol that does authentication and key agreement. The idea is that the UE needs to be authenticated with the IMS core and the way back. So it's not like I, from the IMS perspective, need to authenticate the user equipment, but also the user equipment needs to trust me, needs to trust me with his credentials, with his calls, and so on and so forth. So it has to be like a mutual authentication agreement. It works like one-time passwords. So the idea is the user equipment negotiates over diameter, or over at least over different channels, let's say, negotiates some AVs, which are called authentication vectors, that are based on a shared secret that is created and is stored on the SIM card. So whenever you get to your operator, you get a SIM card. It has like an encoded key secret in there. That's he's the one that stored it, so he knows it. And based on that key, you generate some sort of one-time passwords that are negotiated through the authentication center here. And basically, this is how the two components negotiate their authentication vectors. And this changed dynamically. So every registration, you need to use a different authentication vector. This authentication vector has like 5 information. The first 2 are authentication challenges. So this is a way to identify which authentication vector we're going to use. Then we have a response, which is the, let's say, the AJ1 or AJ2 encoding of the authentication challenge, for those of you who know how SIP digest works, or how the authentication digest works. And it has 2 more fields, the cipher key and the integrity key. These are not being used in the authentication process, but rather on the PCSCF side, on the IPsec side. But we will see a bit later. In terms of implementation in OpenSIPS, we didn't have anything, as I said, so we needed to write a new module for that. Which is called auth aka, and what it does, basically it handles the entire authentication process with some glitches. So it builds the necessary headers, it parses the responses, it adds the information you require back into the SIP message. However, what it doesn't do, it doesn't go and fetch an authentication vector. That's because we didn't want to hard code the way you are asking for a password. We want to make it as flexible as possible. So that's why instead of hard coding the MAR command, which would be easier, we created an interface that can be used to go and fetch the credentials. You can fetch the credentials over diameter. You can go and just do a SQL query if you have access to that, for example, to the database of the authentication center. You don't really need to do diameter here. You could have just gone through directly through the MySQL database or whatever, and fetch the fetch the information in order to do authentication. Or you can use whatever different channels you want. But of course, in order to make everything work, we've also created a module that implements this interface that we've created. It's called AV diameter, and basically it runs or creates the MIR commands in order to fetch the authentication over diameter. But you could have used anything else. Its interface is quite simple, so it exposes two different functions. One is to authorize, so this function checks whether we have an authentication vector. It is an AKA authentication vector because it could be something else. If not, it will return false, and we will have to do an AKA challenge. You may have noticed that we are doing an asynchronous challenge. That's because, as I said, the module itself needs to fetch the authentication vectors. So you can of course do it synchronously, but probably you don't want to. Ideally, you should do it asynchronously. So the module, what it does, it takes all the headers, fetches the identities that it requires, and then calls the interface that implements the, let's say, fetching of the authentication vectors. And that's it. You get the credentials, you put them in the reply, and so we are here. We get the credentials, we get the MAA response, we put them in the 401 reply. We have the nonce, which was, if you remember, the first two parts of the authentication vector, the IK and CK, and send them to the CSCF, which sends them to the PCSCF. Now, this IK, so what's important is this green arrow is plain C. So anyone that's in the network and has access to the network, it's clearly visible. It's over a public channel, let's say. So anyone could see this information. However, IK and CK, they stand for integrity key and ciphering key. These are secrets. These should not be shared with anyone. This is how they look like. So this is what the ICSCF sends to the PCSCF. So it has a nonce, it has the algorithm that authenticates, and has to the information. Again, these two are secret. They should not be sent to the user. So this is what the PCSCF does. It basically it strips these parameters from the authorized and sends the message to the user equipment. However, it does something else, which is very important in this process. It creates an IPsec tunnel. It uses a special. It uses this RFC in order to know exactly how to negotiate the algorithms, how to create those security associations that are needed for an IPsec tunnel. Well, it uses also these extensions from TS33203. But the idea is that at this point, although everything is clear, so we should not forward any secret information toward the user equipment. I am seeing that we are implementing this 3329 RFC, which basically says how the IPsec tunnel is created. You have a bunch of parameters in the security client header that the user equipment sends when he wants to use this AKA authentication, and gives us a bunch of. Actually, there are more of them. I only had room for one, but it gives you like a set of encryption algorithms, authorization algorithms that you can choose according to your internal policies to connect to it. Once we get this, we also add our peak. So we need to tell, among all the algorithms that we presented, we are going to use this one. And on top of that, if you want to talk to me, you will have to use this information. We'll get there in a while. So, because this is how the IPsec works. So remember, at this point, we have a temporary IPsec tunnel nobody has used so far. We just created. We created only our side. And we specify that it should be encrypted with the IK and CK keys that we have. Of course, we may have multiple tunnels because we are serving multiple users. Therefore, we need to identify which tunnel is being used. So this is what the SPI values from the IPsec header mean. And the idea with IPsec is that you need to create actually 6, I believe. Actually, let's say 4 flows, 4 bi-directional flows for each single client. And each client should have a port from user port UC and port US. And the other endpoint should also have the PCSCF should have a port proxy C and proxy S. Actually, it's P stands from PCSCF. So each of them have 2 different pairs, and whenever you send traffic to the other endpoint, you should always use your client port. And whenever you send traffic, you should always send to the server port, right? Well, this is like a client-server architecture. This is quite easy. However, for us guys who are used to SIP, we know that usually when you send a request or you receive a request, from the proxy perspective, it's ideally to send it on the same pipe, to the same, from the same user IP to the same user IP. Otherwise, if you have NAT or stuff like that, it won't work. So this somehow breaks our, not OCD, the way we used to do things so far. So as I said, usually you do cross sending. So you get a request on this side and you send a reply like this, which is a bit different from the way we've been used. But yeah, this is the way it works. However, if you are using TCP, in order to preserve the same connection, you're not just you're allowed. You must send the reply on the same connection. So as you can see, you have to have this flow bi-directional, and this one for now is just actually this one has to be bi-directional as well, because if you originate invites, for example, you send an inbound call to the user, you have to get the replies on this flow as well. So we've done that. We've implemented IPsec as well because we needed it, and we try to simplify the way we expose this configuration in OpenSIPS. That's how we built the Proto IPsec module, which all you need to do is specify the protocol, not the protocol. We call it protocol in OpenSIPS, but it's the type of connection you want to make. It's IPsec, the IP that you're listening on, and the ports that you are listening on. You need to create 2 ports because, as I said earlier, you need to have both a port for client and the port for server. You can have as many ports as you want, but you need at least 2. And the module will simply manage all the IPsec traffic. It will create the listeners that you need. You will need both UDP and TCP listeners, and theoretically you might need TLS as well. It is able to do the socket switching, that we are not used to send replies over a different connection. And it is also able to do fallbacks in case, for example, you want to send an invite over TCP, but that fails, it will still try to send it over UDP and the other way around. So in case you are not able to send a message, it will try on both protocols. And this happens internally, so you don't have to do anything from the script or higher level. its interface is quite simple. So whenever you have a 401 reply, you just try to create the IPsec tunnel, and that's it. You don't really need to do anything else. Well, this interface, this command has different flavors to it. It allows you to choose particularly what kind of algorithms you may want to use for that particular client. But it's very simple, or what ports you want to expose in case you want to expose different ports. But it's quite simple. So now, getting back to our diagram, we were here, we got a reply from the CSCF, sending it to the P side, and then sending it back to the user with the algorithms that we chose, with the ports we've chosen for the client to contact us. And at this point, we simply wait. We simply wait because if the user shares the same identities and the same IK and CK values, it will be able to reach us on this new IPsec tunnel. If not, he won't be able to use it. That's why, we did create the tunnels, but they are just temporary ones, because even though we did authenticate the user. Actually, we didn't authenticate it yet. We sent it him announce. We don't know for sure whether he has the same credentials. So we just create a temporary tunnel. If he's gonna use it, then it has the right credentials. Otherwise, it doesn't. In the successful case, then we will get a SIB register, which is IPsec encrypted. And we could, of course, go to the same ICSCF to say, hey, who's handling this user? But if you cache something, you can go directly. For simplicity, I cached, theoretically cached the register, and we're sending it to the CSCF with authentication response. Now, well, we just do a digest authentication. So we had the response in the reply of the MAR command. So we just do it, we just verify that it works. If it does, we need to save it in our HSS. So we need to save, we need to tell, for example, this guy, hey, from now on, this server will be responsible of handling this user. So we do an SAR command, which stands for server assignment request. It's part of the CX interface that Livy presented, and it's being used to assign a CSCF for a user. Of course, it has other functions as well, but they're not that important. But what it does, it also keeps. So from this point, the IMS core also keeps track of this user and its location. And if after that, when we get a reply, a response, everything is okay, we send a 200 OK, and then we send a 200 OK to the user equipment on a different channel, in case if it's UDP. If it's TCP, we send it on the same channel. Yeah, that may be and of course this 200 OK is encrypted. So we got to this point, we are registered on the network, we of course want to play some codes, right? The user is registered, so we're able to receive calls. The IP text tunnel is established, so we have a trust relation between the IMS and the UA from both sides. And we have bidirectional SIP signaling working, right? However, for a call, we also need media, right? So when talking about media, things get a bit more complicated. That's because media requires higher bandwidth. It has to be real time, because if it's not, and it has to have very good quality, because if it doesn't, then it defies the purpose of using IMS. You could have just used traditional switching, because, well, you have voice over traditional switching as well. But you're using IMS to improve quality and offer extra services, for example, video, which you can't offer through traditional switching. That's the difference between. That's novelty when it comes to calling. The idea is that users cannot reach to each other. they have to go through the IMS core in order to reach each other. This is how we get to the IMS bearer, and basically this is a completion of the APNs that Giovanni talked about. These bearers or these APNs are virtual pipes. It allows you to dynamically or statically or dynamically create different pipes with different properties in order to ensure different quality for your service. 5 minutes? Okay, I should hurry. They have this GBR stands for guaranteed bitrate. So you have to split your traffic into one quality that you have to be. It has to be real time, and you have to assign better bandwidth, which is media, and lower quality, which is IMS signaling. For IMS signaling, you don't need that much bandwidth. Just need to send calls. These are assigned to the default bearer. This means that they work just out of the box. So that's why we haven't discussed about them yet. We just send the traffic and we get the replies back because there is no bandwidth reservation needed. However, for every single call, we need to reserve this kind of bandwidth and quality of service. That's why when talking about calling, as I said earlier, we need to bring the media to the platform. And since OpenSIPS is not doing any sort of media, we need RTPEngine to do it for us. So when the SIP invite comes, it is IPsec encrypted, we decrypt it, send it over plain SIP to the CSCF. We got the ringing. Now, we've got the ringing, but we don't have the media channel created yet. This is what the PCRF component gets into our diagram. Because this is the component that handles the policy and charging rules. It basically acts as a firewall that you can dynamically create rules with different properties for it. So at this point, we need to do an AAR request in order to create the media bearer for our call. It's part of the RX interface. It's over the diameter protocol in LTE. And what it does, it ensures a specific bandwidth for the call. It opens that virtual channel that we were talking about. As soon as we open them, we open it, we are allowed to send the ringing back to the user equipment, and the whole process gets repeated until we get 200 OK. So, well, some codecs may be negotiated using the pracs and updates and so on. We're not getting into that details, but this is more or less what's needed. We have RTP through a different channel through the media bearer connected directly to RTPEngine. Now, AKAV2, as Livio said, we need to implement that as well because AKAV1 is successful to man-in-the-middle attacks. So this is like an improved version of AKAV1, which does some sort of derived values from IK and CK. If we manage to do that, then basically we can get rid of IPsec and establish a trusted channel directly between PCSCF and user equipment over TLS. I'll go a bit faster. Now we're talking about 5G. I'm getting back to this diagram because, as Livio said, all we need to change in order to support 5G is this arrow. So I've showed you that we are using the AAR RX diagram, which is this one. And if we want to do 5G, we need to implement this one, which is a completely different interface. It's specified in the IMS SBA service-based architecture, and essentially it's an HTTP2 interfaces. And in order to enable this 5G voice in IMS, we just need to, or the simplest step will be to swap the RX interface with the N5 interface from the 5G. This will look something like this. So all we need to do is have the PCF talking with the PCSCF over the HTTP2 protocol. we've already implemented this in OpenSIPS, and as Livio said, we're going to show you a demo during the workshop. In conclusion, well, we've shown you what IMS is, what's its architecture, how you can build 4G. In further works, we need a lot of testing, and we need a lot of hands-on experience. That's why we need all of you to join that working group and express and help us improve OpenSIPS IMS service. There should be one more slide, but I don't have it here, and I don't have time, so thank you so much for...
There will be no questions, merely for the fact that all of you are hungry. Don't rustle your seats yet. We have a couple of things we need to discuss before we let you go. If you do have questions for these gentlemen, like they said, they're going to have is it a workshop or is it a demo?
It's both.
It's both. So there you go. The experience will be from both sides, and that'll be on Thursday, correct?
Yep.
So if you want to try and catch them like during lunch or any time, feel free to. Let's just give these guys a round of applause. Thanks so much. So I caught wind of, I think, a terrible injustice. There have only been 2 of you that have sought out pictures with Dan Jenkins. Selfies. And it's not that he feels lonely or anything like that, because in most other venues in the world, people would be lining up and the queue would be around the block. But we understand that you guys have been filled with lots of information. Really, CommCon is an amazing event. We really, in the open source community, we support everybody. We're all like brothers and sisters, so if you really want to get that free ticket, find Dan, get a picture. This guy. Okay, so we're going to break for an hour. Lunch is going to be out here. I see that it's not quite ready yet, and it is rather windy out there. Really? You're yearning for questions. Like, do I really get forgiven in confession, Jesus? No, I didn't think so. All right, we can take some questions. Who's got a question? Okay. You were second. He came up right.
How do you sign up for the working group? Sorry? How do you sign up for the working group?
Just, there's a wiki page that guides you to the mailing list that you just subscribe. So it's an open list that everybody can subscribe. Go to the wiki and you'll find working groups over there. If not, just ask me to send you the link.
Congratulations for the work. I spent 1 year working on this, and it's pretty amazing what you do. So congratulations a lot about that. And relating the testing part, did you do some stress testing? The problem that he mentioned that is there is no simulators. So how to stress the PCSCF and the RTC connection?
There are a few solutions to do stress testing. However, none of them are close to real-life devices because you have different phones in real life, you have different SIP stacks, different versions, different anything. You might find a stack. I think it's SRS-UE or UE-TRAN. There are a couple of projects that do simulate a 4G network, and you can, for example, take SIP-P. It has support for AKA authentication. You can originate some calls over the simulated LTE network. I haven't done that yet. I'm planning to work on that as soon as we have like a wrapped up IMS that we can just power up and start sending calls out there. We can probably implement that in SIPs there.
Yeah, because the question that I have is, well, the question that the people are making to me, the question that most people are making to me and the field of our research is how many connections we can create with this and how it's possible to, how many sessions we can support there. That's the main problem.
Right. That's not a problem from OpenSIP's point of view, but you have other, for example, you have antennas that have limited connections. You have, so there are other components that I think might be limitation in this. OpenSIPS can work as OpenSIPS like does and can handle thousands of connections. So, well, provided that you have like a hardware that does support it.
Gina, did you have a question? You want the mic?
Yeah.
Okay.
No, I just want to stress that the working group and all the work that is doing around IMS and new radio, LTE, etc., is going toward production. Is not at all a proof of concept or just a show. Is going to be and is built as a production server that is able to interact with carriers, with partners on a commercial basis, on an industrial grade basis.
Everywhere except the US. Are my American peeps with me? Are we suffering? Yeah. Okay, so I do want to mention that the food going in your stomach shortly, and I am delaying because I haven't seen it brought out, that's sponsored by 5-9. So the 5-9 guys, will you please stand up one more time? Let us give you, really? No? Give them a round of applause. Thank you for feeding us. Thank you for feeding us. So I wanted to talk about the prizes that are going to be available tomorrow. I'm going to actually unveil one of them. Anybody here of Owl Labs? Do you know what that is? Anyone know Owl Labs? Conferencing? Yeah? Okay. So we have an Owl Labs 360-degree conferencing unit. Really high-end. That's going to be our top prize. You can't stand where I can't see the food, man. Like, what? Yes?
They're taking it out. I was in the kitchen, they're ready, they said people can come out. They're already waiting with...
Oh, they are? Okay. Wow. All right. Get the hell out of here. Go feed yourselves. He's going to be talking to us about cryptographically verifiable billing. Yeah, we're good.
Great, thank you. So yes, my name's Jonathan Hume and I'm from ConnectCS. Who am I? So I've done the computer science stuff, I'm a programmer, I do various stuff related with OpenSIPS and different various implementations of it. I've been a VoIP engineer for around about 15 years now. Founded multiple VoIP-related companies, different countries, do different various things, and Connects is the one that I mainly do these days. So just a very, very little bit about Connects. We founded it in 2014, and it is just let me slide this over on my side because I can't really read this. It's a SaaS-based application for a cloud soft switch, basically. It's built for carriers. It's got a global customer base. We've got servers all around the world. OpenSIPS is the core component, and probably the nice cool thing here is that we've got over 250 active OpenSIPS deployments in sort of the infrastructure that we manage. We help out with various bug fixes with OpenSIPS, a few feature requests, things like that. Like I said, we've got about hundreds of customers around the world, over 100 customers, and we've got a team of around about 15 people. So we're not a huge company, but we've got some momentum behind us now, which is nice. Another nice thing that we've done with OpenSIPS is quite a few years ago they released some capabilities to handle things like Anycast. We've now got an Anycast cluster around the world, quite a large one, I'd say, and that's deployed in 10 regions. So that's another nice thing that we've been able to do with OpenSIPS. Now, the topic of this talk, I'm not going to have as many of these acronyms of the last one because there's too many, so I'll try and we'll reduce the amount of acronyms that we got. But what I want to talk to you about is basically an idea that I've got, and I'd like to share it with you guys, and I'd like to get this out to a wider community. Ideally, other switch providers, other carriers, other people in the industry who want to do interconnects. And we're not going to be doing all of the fancy IMS stuff. We're going to bring this back down to core SIP. And hopefully the types of things I talk about you'll be pretty familiar with because it's pretty basic stuff just implemented in a novel way. So that's our objectives here. I want to try and push these ideas through. It would be lovely if we can get these all the way through to an RFC at the end of the day. So basically there's a nice standard that comes out of this. So all the ideas here are subject to a little bit of change, and I'd more than welcome any comments from anybody who's got this, whether you want to ask any questions near the end or come see me later. So this is the problem that I'm describing. We have got multiple carriers, and when carriers send calls from one carrier to another carrier, you've got to bill. There's also the retail side of this as well, or the end user side, but I'm pretty much going to be focusing on the carrier side. So the providers can give you a CDR. So when you have your phone, you're going to have call detail records provided by your provider, and that provider's pretty much the source of truth. They're going to tell you exactly how it is, and you've got not a huge scope in terms of your capabilities to argue against that. What they say is true. And this can become quite difficult when you've got carriers to carriers interconnecting. You've got this whole reconciliation process to do to try and figure out if the records of one provider is the same as the other. So this is something that can be very, very tedious if you've got to do it via SIP traces, if you've got to try and find all of this out. So the concept that I'm going to describe is going to be using cryptography to try and do this. And we're not talking about complicated cryptography here. We're talking about something simple, and that's JSON Web Tokens. So JSON Web Tokens are these fantastic little things. It's basically JSON. Everyone knows JSON, right? All this information that can be kept in a JSON format, and it's signed and put into this particular token, and it's an opaque token, so you can, I'm getting it that way, man. You can see exactly what's inside the token. You can see all the information there, and it's essentially signed at the end. Now, there's a few different ways that you can sign this. You can sign it using a symmetric signature or an asymmetric signature, and we're particularly going to focus on the asymmetric signature here. So I'm going to, again, keep using Alice and Bob because everybody knows Alice and Bob. It's a nice, simple example to use. We're not, it's really, really easy this way. So Alice and Bob both have public keys, both have private keys. And Alice, because of this, Alice can assign a JSON Web Token that contains specific data, send it over to Bob. Bob can then verify that this information has definitely came from Alice. So the truth's there. The public keys can be exchanged either over private channels, out of band if you want to be really, really secure about this, or it can just be published and delivered via TLS. So this, essentially, if those who really, really want to have a bit of a siesta, this is essentially what I'm going to be talking about. And this is a way that we can just add a little bit of JSON Web Tokens into the SIP communications, and it can be used to verifiably confirm sort of every single stage of this operation. So that's it in simple. I'm going to go through and describe this step by step, and yeah, it'll be pretty straightforward. I think everyone will keep up with this. So the first stage, the invite. There's absolutely nothing special about the invite. The invite goes straight from Alice over to Bob, and nice and easy. So this is where the first key concept comes in. Bob tells Alice how the call is going to be charged. So he creates what's called a billing definition. This is the terms of, how I'm going to charge you. And this can be delivered via the provisional reply, the 180, 180, or even just the 100 trying. In here, we're going to construct this JSON Web Token. So the stuff that you see on this side, on the left, this is all stuff that will go in the JSON Web Token header. So these are generally all the reserved words. So we've got the algorithm that's going to be used, the type. We can put the public certificate URI in there if we want. These are two very important ones. These are probably some of the most important. The issued at time and the expire time. And then over this side, we've created, these are the suggested fields. These are the ones that we're going to include in the payload. And this is everything from the currency that we're going to bill in, the increments of the currency, the pulse, the minimum call duration, so all that sort of stuff, and the different types of rounding that we're going to do, whether we're going to round up and round down. Now, again, this payload is JSON, it's nice and flexible. If there's other specific criteria and different ways in which carriers want to bill, this extra information can be put in here. You see here that I have actually struck off what I put as the keep alive interval, because pretty much we can get rid of that and we can just worry about the IAT and the expire. So what we do is, just out of curiosity, everybody here, just put your hand up if you're familiar with JSON Web Tokens. I can whiz through this so much faster now. We're going to have a big Q&A time at the end. So everything that you've just seen before, we're going to encode, and it's going to look like that. Then we'll put it in a SIP message. Now, this is again something that I'm very interested to figure out what the best solution is here, because there's already a reserved SIP header here for bill info. But the problem is I'm not using it the same way here, so that's why I put the X in front of it, because the X, as you probably know, is a SIP header that you can choose to behave exactly as you want. So we could use the existing bill header, the existing bill info, but we're probably going to have to convert this into a param of a URI or something like that. So we'll just leave it like this for the moment. So this is going to be the provisional reply message that's going to go from Bob to Alice, and it's basically going to say in that message, this is how I'm going to bill, and then Alice is going to look at all of that information. She's going to be able to see if that matches her expectations. Is that the way that she expects to be billed for this call? And if it is, then Alice approves. If Alice approves, we're just going to let the call continue, same as usual. If there's anything wrong with this call, for example, all of a sudden the billing increments has changed, or the minimum call duration has changed, or obviously the cost has changed, then she can reject the call, send a cancel, stop the call progressing, or if it's already connected by then, you can drop the call straight away. So what she needs to do then, she needs to sign the call herself and agree to these conditions. So the way that she'll do that is she will take the signature part of the message that Bob sent, and she'll include that in her own reply. So you can see this time on the right side we've got the suggested fields. This is the billing, this is the signature of the message that came through. So you can't change the first part of the JSON web, you can't change anything in the JSON web token, and the signature will stay the same. So this is all that we need to prove that first message. We can then send that in the, oh I'm sorry, I've got it the wrong way around. On the 18301 is so whether it comes around, now this can be sent back in the ACK, or on the 200 connect, or if you've got provisional replies enabled, then this can be included in the prac instead. So that's what that will look like again, and this is the header, so this goes back in the ACK. And that's the first part, and the call's now set up. So Bob's approved, Bob sent a billing definition, Alice has approved. So when Bob receives the ACK back, that will contain the JSON web token that's been signed by Alice. Bob can compare this to the original one, and he can confirm that, yeah, Alice has approved this, she's agreed to these terms of the call, so now Bob has also got evidence that this call's all in agreement. Yeah, so we can confirm that the message is true. If there's anything wrong from the other side, Bob can also just decide to drop the call or continue to say, you know, not happy with this, and we don't have the problem. This is going to be okay for the next 30 seconds. So what we've done is in the JSON Web Token expiration time, we've set 30 seconds into the future. So within those 30 seconds, Bob's going to need to renew this call. So we need to do that through existing stuff that we've got in SIP. So we can do a keep alive. The typical keep alives are the options message, or you can do a re-invite. So either of those two methods would be compatible with this, and we do a similar-ish thing again. We're going to have the same billing definition signature that we had before, and this time all that we need to do is increase the issued at time for the timestamp that we're currently at, and we issue a new expiration time. So the expiration time again is going to be 30 seconds into the future. When we convert it into JSON Web Token, exact same as before. And the only thing that we need to keep in there essentially is this billing definition signature, because that's where all of the original terms are defined. So when Alice receives this information in the keep alive, she's got to confirm that all of this is good and true, that the original billing definition hasn't changed, because she can see that inside that message. So she can confirm from what she originally received. We don't need to resend the whole thing through again. And she can check the payload. Does she accept an extra 30 seconds to be added onto that call? Once this is done, she can send the reply JSON web token, again containing the billing definition. She doesn't need to have what was just sent over to her. The original billing definition is fine. And she can also, again, set the IAT and the expiration. Again, we just wrap it up same as before. This goes in the 200 OK, that then goes back in the opposite direction. When Bob receives the message from Alice, all he needs to do is confirm that that message is true. He can see the billing definition signature, he can see the expiration time, so all of those have again moved forward, so the call's good to go forward for the next 30 seconds again. And then lastly, after this call, this can happen many, many times over. As long as the call needs to go, it can be extended every 30 seconds, or if we're using re-invites, you can generally make that last a little bit longer. But we'll come to ending the call now. Now, obviously, either party can end the call, and in this example, we're going to look at Alice. Alice is still going to end the call. So she needs to generate a JSON web token again that needs to be included the exact same way as before. All that we need to do this time that's a little bit different is in there we put an action, and that action is a release, that we can release the call. And then this message will be sent straight back up to Bob. Gets encoded again, same as usual. And when this gets sent through to Bob, Bob will be receiving the message, and he can see the signed release confirmation. He can confirm that it's true because he's going to have the certificate provided by the other side. And what we're going to have here now is that Bob has got cryptographic signed message that Alice has released the call. So he's confirmed that that's the exact end of the call. It's obviously not going to be going on any further. And it's now moved from the keep alive interval. This last message will be taking the priority. So we don't really need to worry about keeping any of the other stuff. We've got, we're limiting the margin of error. Some other cool things that we can do with this as well is that as soon as we're collecting all of this information at the end, we are going to be able to have a total of all of these bi-messages that we've got that are cryptographically signed by the other party for both sides, and they're going to be able to confirm exactly how many calls were released at that particular time. So what we're not going to have over here is one-sided CDR records that can contain, yes, I've got a bi-message, it's fine, I'm going to say that, but now we've actually got a cryptographic evidence that the other side has released the call at this particular timestamp. And this can be really, really, really useful. I'm just going to whiz through all of this because, again, you guys know all about JSON Web Token, so you know exactly how this is going to go on the last side as well. So throughout this exchange, there's some things that we essentially need to keep from both sides. Now, one thing that I haven't done here, which some people might be thinking this is probably the better way to do it, is we're not creating a blockchain of every single message with inside another. Does seem like that might be a nice idea, but it's a little bit unnecessary because if we did that, that means that every single message in this blockchain we're going to have to keep, just so we can verify the last one at the end. And we don't really need to keep all of them. We only need to keep a few. And the few messages that we need to keep is Alice needs to keep the first message from Bob, which contains the billing definition signature. That's the evidence of exactly how the call is going to be billed. And she needs to keep the last message from Bob because that determines exactly when the call's ended. Whereas Bob, he needs to keep his first message, and the last message, that should have been from Alice, sorry, the last message from Alice, and, no, it is, the last message from Bob and the last reply from Alice. So with all of this, you can construct exactly how the call's been going on, and you don't have to have all of these intermediary things that are kept. So only about 2 or 3 messages need to be kept for the entire conversation. So, yeah, Alice will always have the billing definition. It's authorized on every 30-second increments. If Bob releases the call, Alice is going to have proof of the release. Bob should only have whatever Alice has approved. And if Alice releases the call, she will have evidence that Bob has agreed to the release. So this is something else that can happen with these missing buy messages. You can send a buy message off. You might not get the 200 OK. What can you do about that? There's not really a lot. That's sort of how that's going to work. But if you've got the 200 OK, you can actually say, you've now got cryptographic evidence. I can prove that you've actually released the call, and you know that you've released the call. So there's no ambiguity there. And from Bob can prove that Alice has agreed to the terms of the call. So that's obviously very, very useful from his side. He can prove that Alice has authorized every single 30-second increment of the call. And if Alice has released the call, he'll have evidence of that. And if Bob releases the call, he'll have evidence that Alice has agreed that that is when the call has been released. Some other things that we can sort of do with this. Yeah, we can again establish these error limits. So we can program this into SIP as standard to say we are not going to tolerate a certain amount of missing buy messages. So we can already do that sort of thing. But now we can program, we can do this from the financial side of things. We can basically say, as the calls are flowing and going through and we're progressing through all of this, that if we've got this many calls that have failed to be released correctly, we know there's this many 30-second increments that are unagreed from the other side, so we can pretty simply use that to calculate a total drift that we could potentially have, a total billing dispute amount. So we can focus that down and limit it in terms of the error margins that we're going to have. So what else can we do with this? This is quite a simple concept, but there's so many more things that can be built on this, so many ways, and this can be extended further. It's pretty simple. This is another cool thing. That's pretty simple. We can set up a third-party service here, a billing server that can contain both Alice's and Bob's public keys. The billing server can be hosted completely by a third party who's got nothing to do with them, and it can be fed information from both sides. So both sides can feed in the cryptographic messages that they've got, and the billing server can independently, either from one side or the other side, produce a new truth about exactly what is valid. And because we've got an independent server that's able to do that, that server can then essentially become an escrow. That server can then hold funds that can release them to the other side, and it's going to have cryptographic proof that when it's releasing the funds, it knows exactly why it's releasing the funds, that every single call was signed, building all up to this point. Now, that billing server can have information submitted just by one party, by both parties, in different orders. It doesn't matter. All of these things can come together in the end, and you can get all of this data out of it. Some other nice side effects, I suppose, from the way that this is done is the billing server doesn't actually even need to know who the calls are going from or going to. So all of that is just, we don't care about that unless we need to. The billing server can just see the calls, just have evidence of the calls themselves. So yeah, we can do the escrow with this. It's also possible to bring crypto involved, so bring various blockchain technology. So if we've now got a computational way, a cryptographic way of proving that call A existed, call B existed, etc., and one or both parties have agreed to this, it's not too difficult to do the next step and essentially create something like a smart contract. Smart contracts can verify these calls that have existed, and then you can essentially use a type of smart contract called a lockbox that can then deploy funds as soon as it's been presented evidence. Okay, got it. Yeah, thanks. So yeah, this can be done in near real time as well, because as soon as these things are available, it can be spat out. So you can have lots of things that are charging in real time. You can have lots of error risk being calculated in real time. This is going to overall create simpler interconnections. Some things that you might be able to do with this is because you've already got this cryptographic framework, you might be able to reduce the huge dependency on IP authentications because you're going to have crypto here involved. And one other quick thing that some of you guys might be thinking as well is the way that StirShare can already use these types of certificates and that are issued by a CA and everything else. Well, it should be entirely possible to use those same certificates to do the signing, so you can have another form of authority and identity on there to essentially provide validity to all of these calls on this framework. And just very quickly, because I know I'm running out of time, there's some other things that you can essentially have. You've got the retail and consumer applications. We can say goodbye to PCI compliance if you wanted to implement payment gateways if you've got control of the end device that can then essentially use this framework to deliver payments on top of it. A typical scenario would be that you would, let's just say you're calling a consumer support line, you're speaking with first line technical support. Let's just say you're not getting where you want to be transferred into a second line of support. Well, second line of support costs more. Well, what about if you were able to change the billing definition immediately on the fly when you connect to the second part of the call? So instead of having a separate call where that's chargeable more, you can be transferred, the cost of the call might increase there in real time. Yeah, so this is pretty much the same. I think I spoke faster than my slides. Yeah, you can essentially choose the amount to be signed, and it can be passed on to the client device if you've got control of the client device. You can show a pop-up box that allows you to do anything from a PayPal transaction, a crypto transaction. This can go straight in through the call all together in one go. Thank you for listening. That's my idea. I would welcome any feedback, and yeah, let me know if you've got any questions.
Give this guy a round of applause.
Okay, I have time for a couple of questions as our next speaker is coming up and getting ready.
Do you envision this transfer operating sort of like a STP-like offer-answer model? Because, with different types of calls, the billing can go in different directions, or maybe even the ability to query billing proactively prior to establishing a call, anything like that? It's cool. It's very cool.
So, yeah, absolutely. I mean, I I see the typical deployment here as it'd be nice if all of this is just integrated and works behind the scenes, but essentially you'll have a rate card from your carrier, you'll put it on your switch, the carrier will send you calls, you'll be able to verify that in real time with what your expectations of that call would be. So yes, in real time you'll be able to know exactly what you're charging. And sorry, what was the first question?
Oh, just about the potential to offer an answer, like
Oh, yeah.
in either direction, in case the billing, like for a toll-free, goes the other way.
Yeah, exactly. So the question was, will this work? Could this work the other way around? Absolutely. I think the concept of the billing definition doesn't have to be provided by one specific party, and I think there's lots of flexibility in terms of the exact implementation that this may take. So, for example, the invite could contain a billing definition and say, this is what I expect, or I'm going to send you a call and this is what you're going to be charging me at. So absolutely yes, and there's no reason that those figures can't be negative as well. So let's say the billing definition comes from the carrier, there's no reason to say I'm going to be paying you this amount per call. So yeah, it could go in both ways.
Any other questions? Okay, so as we're doing this, I'm looking for an HDMI adapter for a Mac. Does anyone have one? Oh. Where's Jesus? Okay. Question.
More just of an observation. We've picked up sort of like inter-carrier disputes and that. A lot of the time it can be because of drift of time, or one of the parties hasn't synced to network sync time. Do you have any provision in that for either agreeing or recording an exact definition of the time of the call?
Yeah. So yeah, the question is essentially if you've got two, if you're connected to a carrier and the carrier's clock's different than yours. So yeah, absolutely. The very first time that you will get a JSON Web Token back, you get the IAT, the issued at time. I think it has to be something that you verify, and if the IAT is different, then you'd be able to say very quickly, yeah, your IAT is X many seconds drift from ours. We're not going to connect. We've got a problem, or you could compensate for that. But yeah, great, thanks.
Any other questions? Okay, this will be our last question.
So first you mentioned that you will be having a blockchain of all of the transactions, right? But if your rate changes in the middle, would you want an audit of that as well?
Actually, that was my question. Does it actually change in the middle?
So, the question was if the specific call rate changes in the middle.
Yeah.
So instead of just keeping those 3 transactions, yeah, you'd have to keep an extra one. I think typically by the time that would reach a billing server, in the CDRs, I would probably expect that to come out as 2 calls. So yes, you'd need to keep at least 5 messages in that scenario. Yeah, thanks. Don't know if you've got time.
I do not have time for you, but this gentleman will be available for the rest of the day. Brett Nemiroff from Numerical is going to be talking to us next.
All right, thank you. Well, I really appreciated Jonathan's presentation. If you guys have spoken to me, you'll know that I have a fondness for JWTs as well, which you're going to see in my presentation. So we're going to skip through some of that stuff as well because I go deep into JWTs as well, but I'm going to be covering some of the relevant parts that I think for our discussion. Before I jump into it, though, I do want to address some of the stuff that we discussed earlier. Evan brought up a lot of really interesting points about voice cloning and some of the dangers of voice cloning. And I mean, I'm focused on the dangers of voice cloning because I do think that there's like a real security issue associated with voice cloning, especially as it pertains to telecom. And this is something that I had said when I spoke last year at this conference, is that I feel like our critical infrastructure, including our telecom infrastructure, is really kind of under attack. You know, we're seeing this in the news where certain foreign governments are launching disinformation campaigns. There's a lot of bad actors out there that are trying to initiate frauds and scams against us. And I think all of these issues, they really come down to one central problem. And that's that we have this fundamentally insecure communications mechanism, the telephone, which has pretty much not changed in the last 100 years or so. And we're just now starting to talk about ways to make it secure so that you actually know who it is that you're talking to on the phone. And the technology isn't the problem really, but what it's doing is it's accelerating how fast the frauds happen. We always had the problems of people calling you trying to steal your money. But now computers are able to do it too, which means that it's just really, really efficient to commit fraud, right? So I think a lot of these issues can be solved simply through introducing mechanisms of secure end-to-end identity information. And that's what I'm going to be talking about today, exploring rich call data, RCD. What is it and why can you trust it? So before I get too far into it, just a little bit about who I am. I'm a telecom engineer. Like many of you, I've been doing OpenSIPS for about 26 years. I mean, really before OpenSIPS, OpenSIR, and then before that, the original IPTEL SIR project. I do some asterisks and FreeSwitch, but I mainly stay in the OpenSIPS arena. But my focus really on a day-to-day basis is on identity and trust, introducing verifiable credentials into phone calls, and really establishing circles of trust. A big part of this is working on the regulatory compliance and standard side, and really evangelizing the technology with groups of people like you, because fundamentally I think if we're going to have meaningful change in the industry, you guys are the ones that are going to have to do it. You guys are going to be the ones that move fast enough to introduce meaningful change. So I'm going to be covering, first of all, just some common methods of transmitting identification in calls today, and then circles of trust, what are they and how to create them. I'm going to talk about the IETF RCD draft, and then about some real-world implementations. I'm going to show you an example of one in particular. At the end of my presentation, I've got some resources in case you guys want to do some research on your own. The first one is caller ID. I'm going to be focusing a lot on caller ID because this is what most of us are familiar with. Caller ID has really deceived all of us. I spoke about this last year. It's supposed to be informative. It's supposed to be a form of identification. It's in the name, caller ID. And we're typically expecting it to give us the name of a person or a company who's calling. It's not any of those things. You guys know that. We know that it provides useless information, and it's frequently used to deceive the person that you're calling. Unfortunately, that's what it's turned into. And you guys know, like, change your caller ID, it's super simple to do that. It is not in any way a form of identification. So I'm going to fly through this. I know you guys know this stuff, but you know, the most typical way of transmitting a caller ID today is using the from header right out of 3261. In this particular example, Alice is attesting herself what her own name is, right? And do we trust Alice? We don't even know who Alice is. So I don't know why we would trust this. This is a very, very weak form of identification. It could be set to anything, and anyone intermediate on the call path could be changing this information. Because of these specific limitations, carriers came up with RFC 3325, which allows for P-asserted identity, which is slightly better than the from header. In this particular example, what we're expecting is for us to ignore what Alice wants, and now it's specifically what the carrier is asserting the identity is. In this particular case now, Atlanta.com is telling us that the caller's name is Alice. But now we have to ask, do we trust Atlanta.com? Maybe we do, maybe we don't know who they are. It could be set to anything still. And also still anywhere in intermediate to the call path, this information could be changed. Now, in the United States, we frequently use P-asserted identity, but we typically throw the name away. And that's common, like, really throughout the world, is that we generally do not trust the name on any transmitted medium at all. In the United States, like I was saying, we ignore the transmitted name, and the carrier asserts the originating number. That terminating carrier that receives this particular phone call will implicitly trust the originating number. And what I mean by that is all they have is this particular header, the P-asserted identity header. They have no other information telling us whether or not this is true or not. So they have to implicitly trust it. They'll use that number, you can see the number in the header there, and they'll use that against a trusted source to do a name lookup. And you guys probably are familiar with some of the common companies out there that you can do name lookups. Once they discover that name, they'll insert it into the name portion of the p-asserted identity and transmit the caller off. But I have to ask, like, who do you trust? There's a lot that you can't trust in this particular call. This is just a header. There's no cryptography in this. There's no way of knowing whether or not this information is true or accurate. Do you trust the originating service provider? So assume, for example, here, you are the terminating service provider. I would say, no, we don't ever trust the originating service provider. We don't know who the originating service provider is. They could be anyone in the world. They could set the originating phone number to anything that they want. And they may not be performing KYC. And by KYC, I mean know your customer. I hope you guys all know what KYC is. They may not be performing any kind of anti-spoofing measures. In other words, they may not be doing anything to prevent their customers from putting numbers that they're not allowed to be using on their particular calls, or maybe that's part of their business plan is to actually allow for that. And these headers could be changed by anybody in the call path. And do we trust the CNAM providers? So in the United States, very frequently we trust the CNAM providers because they are a direct vendor to us, but CNAM is easy to spoof. And this is one of the things that I talked about last year at my talk. Actually, last year when I was producing my presentation materials, I actually received this call from a Darth Vader. This is a true story, this really happened. And I ended up having a really good conversation with the guy who did this, just to see how he did it. And you can see here a bunch of screenshots, I showed this last year too, of actual carriers. And these are major carriers and the mechanisms on their websites of how to change the caller ID. So in other words, what I'm saying here is this information could be set to anything. The carriers generally do not perform a lot of KYC simply for CNAM. And in addition to that, you can usually fake CNAM simply by putting somebody else's phone number into a phone call. So the combination of using p-asserted identity with CNAM already is not a good system. So I believe in order to restore trust to voice communications, we need to establish circles of trust. And what I mean by that is an established boundary in which you trust all the parties within that boundary, with really a coordinated policy of how things are done. So in communications, we typically trust our customers because we've performed KYC on them, we know who they are, so we trust them. We trust our vendors, although I'm not sure if we should always trust our vendors. We typically do not trust the originator of the call or the originating service provider. I think most of us don't trust clowns. I just thought I'd put that on the list. But the reason why we don't trust this information is because the technology that we have is this right here. We do not have something that we can point at and say, that's trustworthy. I know exactly where that came from. It wasn't manipulated. It came from a party that I trust, that we have contracts with, and we know how they do KYC. So what we need is we need a new technology. And what I'm proposing here are passports. Now, before you guys look at this and say, he's telling me to do shaken, and he's in Europe, I want you to know I'm not proposing stir shaken. I'm going to say that several times. Okay, I'm proposing passports. Passports are based on JWTs. And before I'm not going to get too deep into this because you guys said that you're already familiar with passports, but the important part here is that X5U parameter which points to a certificate. And that certificate is associated to a private key, and that private key is used against the red and the green portion here, the header and the payload, to produce the calculated signature at the end of the JWT. Okay? With all three of these things together, what we know is that the header and the payload content have not changed since the owner of that certificate signed that JWT. Okay, when you have a JWT, this is really important. You know the information was given to you by the certificate holder. So whoever had the certificate is the person who gave you that information. That's a very powerful tool. Now, walking through these individual pieces, if I take that certificate in the X5U and I download it, it's going to look like this. That's an X509 certificate. And if I decode it, it's going to look like this. Now, this is just a piece of the X509 certificate. And you can see here, if I break it down to pieces, at the bottom here is the public key that's embedded into the certificate. And then above it there in the green section is the subject, that is who actually holds the X509 certificate. And then at the top in red, that's the issuer. The issuer is the organization that produced the certificate for the subject. Okay? So generally we call the issuer the certificate authority, and the subject, we call that the end entity. Now, when you take a look at an X509 certificate and you compare it to like what's going on inside of the JWT here, what we're going to end up doing, and I just said this a second ago, is we're going to take that public key out of the certificate and we're going to use it to verify the signature that's on the JWT. Really, only then, if the public key verifies that signature, can we know that this certificate is associated with the rest of the JWT content. Now, just because we know the certificate's associated with the JWT does not mean that we trust whoever is in the certificate. Because that still could be anybody. It could be a self-signed certificate. Or it could be signed by a certificate authority that we don't trust. So what we have to do is, the first thing we do is we're going to take a look at the subject. We're going to say, is this an entity we trust? Maybe you do, maybe you don't. Maybe you have a coordinated policy. Maybe you have a handshake deal. Maybe you have contracts between the companies where you say, look, I'm going to trust you as long as you do KYC this particular way. Now, you don't want to stop there just looking at the subject, because you could literally create a subject with anything on a particular certificate. You do have to take a look at the issuer. And it's really, really important that you trust the issuer. So in the typical SSL world, this would look something like DigiCert, maybe an issuer. And DigiCert gives maybe you your own custom domain name certificate. Looking at PKIs, it typically looks like this. You have the certificate authority at the top. They are the issuer, and they give entity certificates to the subjects. Breaking that down to the X509 certificate, I know I'm just kind of repeating some of the content here, but just for importance here, the issuer there is the red section, the subject there is the green section. So this relationship is really important, because the whole idea of a PKI is if you trust a certificate authority, you can transitively also trust the end entity certificates. The reason for this is because certificate authorities, companies like DigiCert, they have certificate practice statements. These are audited statements where they basically say we only issue certificates to end entities that perform these specific guidelines to achieve certificate status. So if you trust the way a CA does their business, then you can also trust the end entity certificates as well. So, jumping into passports here. Passports are defined by RFC 8225. Passports are not necessarily shaken. Shaken is a kind of a passport, but it's not necessarily shaken. So, once again, passport is a token format based on JWTs for conveying cryptographically signed information. This is specifically what we want to do. We want to be able to pass cryptographically assured identity information end to end in the call. This is really what we want. We need cryptographically secure information to be sent end to end. Now, the passport extension for rich call data, this is specifically what I wanted to talk to you guys about. Now, this is specifically a IETF draft. I'm hoping that within the next year or so that they'll actually get a RFC number. We're presently in version 26 of this particular draft, so hopefully we'll get it nailed down sooner than later. That being said, there's already entities using RCD. I'm curious, is anybody here using RCD yet? Nobody. Okay, fantastic. Well, I hope we can get some of you guys using RCD. It's a fantastic technology here. Inside of the RCD passport extension, it offers these additional claims. It offers a name claim, which is basically just a display name. It offers an alternate presentation number, which is an additional number that can be used to represent that identity. An icon, which is frequently a URL that points to a binary for that particular entity. Now, I'm not going to get into these too much because I don't see these as much used in the wild, but there's JCards, and there's also URLs to JCards. Using JCards inside of RCD is actually really kind of neat. When this fully gets implemented end-to-end, JCards could be used for a call originator to basically be able to transmit a contact card to a call recipient, where they would be able to basically just save their information. And it could have everything like your email address and your birth date and your address and all that stuff embedded inside the JCard. And that would be cryptographically sent end-to-end. There's also a reason for calling, which is a text field that's also displayed or transmitted in the RCD, and an RCD integrity hash. Now, just real quick on the RCD integrity hash, and I'm going to show you some examples of this in future slides. But anytime you have an external reference to data, you have to have some way of making sure that that data hasn't changed since the time that the passport was created. So if you think about a passport that has a URL to an icon on it, it's going to be a URL to like a bitmap. The RCD integrity hash allows you to create a SHA-256 of the actual binary content for that URL. And then that goes in the passport and that gets signed. The integrity hash goes in the passport and gets signed. That way you know when the passport is created, you also know what the binary content is supposed to look like. So why do you need circles of trust? The issue here, and this is what we're faced with today, is that some business is calling a destination on your network, one of your customers, and they are asserting their own name and number. Do you trust them? I can tell you right now, I'm virtually certain, no, you don't trust them. I mean, most of you probably throw out the name completely. If you send me a name, I'm just going to ignore it. I will not pass it. In fact, you don't just ignore it, you strip it out. You make sure it doesn't get passed. That's how little we trust this information. And that's common, especially in international markets. But what if we had a coordinated policy between the originating service provider and the terminating service provider? Say you, as a particular service provider, had a partner service provider, and you guys had contracts between each other saying, this is how we're going to do things. And I'm going to trust you, and you're going to trust me. If we had that, then we can perform what we call call authentication. So the originating service provider would use their local policy and that coordinated policy to say, yes, this is the appropriate information for this call. Here's the RCD, here's their name, here's the reason why they're calling. Here's a logo that represents their business. And they would be able to create an RCD passport. Now this is really important. When they create that passport, it's going to look something like this. And you can see in there, this looks like stir shaken, but it's not. Okay, there's no attest claim in it. Okay, it's not shaken. In fact, that's the only thing that's really different, is that there's not an attest claim. That, and also when you take a look in the header, you see PPT says RCD and not shaken. Those are really technically the only differences. The rest of it, orig and dest is in there. Now, a lot of people think like in stir shaken that orig and dest is in there to like somehow do spoof protection or something like that. It doesn't do anything for spoof protection. Okay, I'll tell you that. And spoofing also isn't illegal, but I'm not going to get into that right now. Really, the reason why orig and dest is inside passports like this is for replay protection. If you don't have orig and dest inside the passport, somebody could just pick that passport up and stick it on another call. So it's really important that orig and dest is in there. That's not what makes it shaken. But you can see here towards the bottom, you'll see there's an RCD claim that has an icon, which is a URL, and a name, and then the RCDI. Now you see in the RCDI here, you have a path/ICN, which points to the icon claim inside of RCD. And that's the SHA-256 of the content of that particular icon there. And you can see, we basically take that passport, we base 64 encode it, and then we sign it with a certificate associated with that particular entity that's signing this, with the originating service provider. That gives us the blue section here at the bottom of the JWT. So they take that passport, they put it onto the call, they send it across the network, it goes from service provider to service provider. It makes it to you, the terminating service provider, where you perform call verification. Okay, in call verification, the first thing you're going to do is you're going to take that JWT, you're going to pull it apart, you're going to take a look at the private key, the public key, and you're going to verify cryptographically that this signature is correct. And if it is, then you'll know that the content on the rest of that certificate represents a specific entity. And then locally, you'll need to ask yourself, is this an entity I trust? Do we have a coordinated policy? Do we trust their KYC? And if you do, then that RCD that was in the passport, you can present that to your customer. So with this, we can create systems of coordinated policies between companies where you can transmit name information. And this is important because as people are losing faith in the voice telecommunications network, we need to come up with ways so that they can trust phone calls. Otherwise, I don't know why they're going to keep making phone calls. It's already tricky to keep getting them to make phone calls today. So I want to show you what this looks like today in some real-world implementations. These are real screenshots using RCD. Now this is inside of Shaken just because that's how we do it in the United States. But it's effectively the same thing. This is RCD inside of Shaken. Phone on the left here is an iPhone. Phone on the right here is a Motorola Edge 2022. Okay, these are native presentations. This did not require applications on the phone to produce this. And part of the reason why this works is because it's end-to-end verifiable. So the service providers and the hardware manufacturers are allowing this because it can be proven. And it's done using a closed ecosystem using a specific CA. Now, this particular project is BCID. You guys can look this up. I actually have it in my resources. So CTIA is specifically doing this BCID ecosystem. And it's just one example of the things, of what I've explained to you today, of using a CA so that you can have a coordinated policy for end-to-end RCD transmission. So what you can do, if you create your own CA, or you can partner with an existing CA, that CA can issue certificates to entities that you trust with your coordinated policy. And once you do that, as an originating service provider, you create your passport, sign it, send it to another entity that you have the coordinated policy with. They check to make sure that your certificate is someone that they trust, and then you get your branded presentation. That's what I got. I hope that was inspiring for you guys, and I hope you guys try to introduce RCD into your networks. These are some resources if it helps out. And if you guys have any questions for me, feel free to reach out to me. I'm on Slack all the time at Brett Nemiroff, right here.
Got some time for questions. Do we have any questions? I have one, I have two. Last time he beat you.
Okay. Thanks a lot for the presentation. So you explained a little bit about native information of the device that it was Motorola, I think. There are other models. It's something generic, or because we tried to demonstrate still shaking and so on, but we don't have native support for the presentation. We need to create applications that support that presentation. Right. So what we want is that demo effect to view the presentation like a verified code. So how to demonstrate it or how to use it. Thank you.
Yeah, so it's important to note that in these particular examples that I've shown you guys here, this is a coordinated effort between the CTIA, mobile carriers in the United States, and the hardware manufacturers. So there's no magic in RCD that just makes this happen, okay? This is an example of what RCD can enable. So if you have a mobile network, right? If you have even a VoIP network, it doesn't have to be mobile. The only reason why mobile is particularly interesting is because the phone comes with a giant display that we have some amount of control over, right? But this did require careful coordination of the carriers, which are having to do these particular operations to produce those presentations. But that's also coordinated with the hardware manufacturers as well. But the hardware manufacturers and the carriers, they're not going to trust anything unless they can be end-to-end verified. That's really, really important. And that's the reason why this works.
Is there any other kind of expiry type stuff around the passport? Because outside of the source and destination number, I mean, you could still just rip that off and use the passport at some point later in time.
That's always been a slight vulnerability in stir shaking. So I wish I had a better answer for you, but that is a problem.
Do we have any other questions? And can we get our next speaker up here? Okay, let's give Brett a round of applause, everyone. Brett, thanks so much, man. Yeah, if you leave it up there, that would be amazing. Thank you. Don't look at me like that. I work here. How's everybody doing? Everyone awake? That food made me a little sleepy, huh? It's good. So carrying on into our afternoon, we're going to have Alexander Blum presenting from Blockzone. Maybe it's time to reveal yet another prize. Actually, something that Livia's already told me, there's quite a few clinics. Or, yeah, I know. But usually we give like some time away, don't we? As part of our raffle. Are you looking at me to like tread lightly? Is that what you're doing right now? Are you overworked? Yes, it might not necessarily happen while you're sitting here, but one of the prizes will be some one-on-one time for you to talk about your ideas and anything you pretty much want with the OpenSIPS team. And that's usually something we give away every year. That's probably mid-level as far as prize value goes. I myself would rather have the Owl Labs.
So, a question mark to start my slideshow with. So the question is, who am I? And if you haven't listened to the introduction, you would know, right? So what would you do? You could ask me, of course, and then you would have to trust me to give you the right answer. So I might not be telling you the truth. So you'd still be wondering, who am I? So what would you do? You would turn to somebody else, a third party. It could be the organization here, or it could be Google, or it could be a bank, for instance. And then I would go to one of these three, and they would tell you who I am. So this works, and now you know my name, but the problem is Google or the organization or the bank would know a lot more too. They would know when I asked for this information and also what information was exchanged. So in terms of my privacy, this is not doing a very good job. So let's do something completely different. And we're going to use self-sovereign identity. And this means it's still you wanting to know my name. And we give everybody a name, so I'm the holder of the information that you want. And you are the verifier, you want to know the information. And number 3 is the issuer, they're the ones having the information. So what happens in this case, there's also a fourth entity, which is a registry, could be anything, it could be a blockchain or something else. And the first thing that's being done is that the issuer is going to register with the registry. So they confirm their identity there. It's a little bit like the PKI that was in the previous presentation, only here it's more general. So there's a complex way to do that, but basically let's say that the issuer deposits it publicly on the central registry. Now the next thing is that I'm going to ask the issuer for my personal information, And the issuer is going to return it to me in terms of a sealed certificate, and I'm going to store it on my device. And now the verifier, you, come and ask me for my personal information. And what I do is I return that information, and there we are. You want to know whether the signature of that information is to be trusted, so you go to the registry and find out if that's really an entity that can be trusted. So now we've gained a lot, because the entity, the issuer, no longer has an ID that a transaction has taken place. And also, he doesn't know what information is exchanged. And for instance, if we're talking about a number of items that you want to know, you might want to know my first name and not my last name, but you're not interested in my address, and you're not interested in my age, then I would just give you my name, and that's all. The user is in control. So if you paid attention to the previous presentation, you will have noticed that the carrier is in control. He has the information on you, and he wraps it up in a certificate, and he sends all of that stuff to the verifier. And in this case, I am in control, and I only send what is necessary in the situation. So we need a special protocol for this. It's called DITCOM, and it's a complex protocol. But anyway, it does the job. It encrypts the information. It sees that the information is transported, and it doesn't do more than that. And there's a little bit about the dialogue here. It starts with a plain text message that can be transported in any way. It can be transported by email, what have you. It's just to exchange keys and set up a secure channel. Okay, so this is my name, Alex Blom. We're there now. We found a secure way of communicating my identity, and the presentation is called SSICOMMS, and the subtitle is Adding SSI to Internet Communications. So, second part, identified communications. If we use only one channel, like in the previous presentation, this is the way it works. I place a call to a call center. The call center has a database with personal information, and I make the call, and I send my CLI, and the CLI is put forward to the database of the call center, and they check the CLI in the database, and it's there, and the database returns personal information. This is, of course, like my predecessor said, it is not information that can be trusted. I mean, very simply, spoof the CLI, and there you are, and what comes out of there is no longer to be trusted. So we can use two channels. Again, I make the call, and there's a second session, there's a data session going on, and the only problem we now have is to connect the two sessions. So that it can be done in different ways. One way would be to send an SMS. Another way would be to issue a session token and get the session token to the caller, and there you are. Let me see where we are. So this is how this works in practice. So session ID is passed on to the identity provider, like we had in the beginning, and the identity provider. Okay. And the identity provider provides the session ID plus the information to the verifier. So from what I showed now, we can draw some conclusions on what works best. In terms of communication, we want to use preferably one application, and we like to use a general communications application, and identify anywhere during the session. That's another thing. If the only way to identify the person on the other end is at the beginning of the session, of course that means that there's a lot of occasions where you don't need to pass that identity information. And it would also be nice if we can start a session by clicking just a contact in your address book instead of having to go to a website and scanning a QR code or something. And in terms of identification, we need SSI in order to preserve privacy. So that the information can be trusted to be correct. Excuse me. Somebody's calling. So, don't know who that is. And the other thing is the one providing the identity information should be in control of the transaction. So that's that idea that I don't give out more information than the other party needs. Okay, and so the last part is about our implementation, adding SSI to internet communications. So we built a mobile app, and it's made specially for identified communications, but normal, regular internet communications is also possible. It was part of an EU subsidized project. And this is about the app we built. You can add your own identity information to the app in any way, any kind of identity information. It can be something you thought of yourself, for instance, your gender, or it can be from what the bank knows about you. It can also be the telecoms provider. They're a very unreliable source in terms of personal information, but still you can add it. It doesn't matter, anything fits in there. And then you can make a call to anyone, and if this other person has the same application, you can exchange identity information. You can join any session, and you can text and email and do everything. It consists of 3 modules. This is the SIP module. It has it's rich internet communications. There's an SSI module that does the identity part, and then there's business logic and a SIP client again, and it takes care of what appears on the screen. And this is the way a typical session will work. Alice calls Bob. There's a SIP invite, she gets an OK back, and there's an egg, and then there's a first SIP text message, and it contains the DITCOM out-of-band message, and that is done to set up the DITCOM connection. And after that, Bob sends a proof request to Alice, which is part of the DITCOM protocol, and Alice sends a proof presentation back to Bob, and now Alice is verified, and the regular RTP stream can start. I wanted to start a little movie here. Let me find it. There you go. Here's Alice calling Bob. Bob, see? Oh, it's not showing. Just a second. I'm afraid the video won't play, so you can go to our website, blockzone.com, and that is where you can find the video. Okay? Thank you.
Did you get questioned already?
Okay, great. So we have time for some questions. Got a little bit of time for some questions. Where's our first question? Somebody out there. Again, thorough, huh? Oh, wait, we do have one.
So I just wanted to double check, the identity works in both directions?
Yes.
Like mutually?
Yeah. Once the DITCOM connection is set up, it's very easy to. Once the DITCOM connection is set up, you can easily Bob can do it. It's in the application as well. There's like a button that says verify the other person, and it works.
Those DITCOM connections that go back and forth, what protocol are those using? Is that out of band or is it
DITCOM is a communication protocol, and it starts with an out-of-band message, which you use in the SIP client to send it to the other device. And once the SIP client receives this out-of-band invitation, let's say, then the DITCOM connection is set up, and from there on, it's DITCOM taking care of the messages and the encrypted envelopes and so on.
Yeah, but that's not happening in SIP, that's over the top?
No, SIP is the one establishing the contact, and once that's done, it's entirely within the SSI module that you saw in the end. Right?
Thank you.
Do I have another question? Yes, we do.
the calling parties can decide what information to include. How do you prevent them from putting in misleading or fraudulent information? I understand that the message is cryptographically signed,
yes.
but it's signed, you know that it came from a particular certificate, but that person's saying what identifying information to put it in, and it's quite difficult to tie that certificate back to the truth of the signed information.
So you're asking how to attribute the received information to the issuer, right? That's in the identity information that's being transmitted is signed by the issuer. So you would go to the registry, which registry is contained in the message. So you would go to the registry, and there you would check the signature of the issuer and get back an answer. This is the issuer, and that way you know that the received information is signed by the issuer. So as long as you trust the issuer, then you're okay. Right?
Any other questions? Let's give Alexander a round of applause. So it's that time again to nourish our souls with some caffeine. I just want to once again recognize SIPPulse and our dear friend Flavio for sponsoring the upcoming coffee break. Well done, sir. Effortless, right? Effortless. So do you have anything special that you want to share with the group? Oh, you're going to try to play the video? Okay, well, that's pretty cool. We're going to see the video on the way out. And it looks like they're not quite ready for us, but almost. It's windy out there. Bring your jackets.
So the video is playing if you're still here, and you see Alice calling Bob, and Bob is receiving the call, and they've just established the DITCOM connection, I think. And you see we were verified, and there's the information of Alice appearing on the screen of Bob, and it goes both ways. So here you see the information about Bob showing up on the screen of Alice. And my idea is where you can set your information, and it works with video as well. So there's again the information of Alice showing up at Bob.
All right, I'm glad we got that right before we're heading out here. So, off with you. Nourish thy soul. Thanks again, Alexander. You still want to do this? Okay. How many people are using Homer? Wow. Well done, people. Well then, without further ado, Rita Lopez.
Thank you, everyone. So, hello, I'm excited to be here today. My name is Rita, and I work as a DevOps engineer at QXIP since last summer. Well, since I'm new, and this is my first time at OpenSIPS, and this is also my first time presenting at a conference, I will say some facts about myself. I have a master's in electronical and computer engineer, and my master's was mainly focused on telecommunications, and my dissertation was about network-driven handover in 5G. So back then I was on the radio side of telecom. My first job was during my master's final year. I was an assistant teacher of C programming language. And after it, and while I was writing my dissertation, since I didn't want to become a programmer and I really loved telecom, I started to work as a VoIP engineer in a CPaaS company. And this was the place where I first heard about Homer as well, OpenSIPS, high-throughput, free switch, and all the fun stuff that we all know and use. And yeah, I've been working on the VoIP world since back then, almost 5 years ago. And as I said, last summer I joined QXIP to work on a different perspective on VoIP. So telemetry, statistics, and all of that we use. Now, my presentation is called Why You Should Use Homer to Monitor Your Calls and Your RTC Network. And okay, you made my point. Almost everyone here already know Homer, but just in case is someone new like me here, Homer is a framework for analysis and monitoring of any VoIP and RTC traffic coming from any capture agent. So it means that you can use OpenSIPS, high-throughput, free switch, you name it, asterisk, for example. We are compatible across almost every agent that you may think and desire to use, so we are vendor agnostic. And then you have your calls going through your favorite agent. You send hub towards Homer, and then you can troubleshoot your calls. So you have everything in one place there. You have the to, the from, logs, call flow. You can export, share the pickups, everything, right? So on my first slide, I already answered the question, and the best part, of course, it is free. Homer is free. It is open source, as usual for QXIP. So, okay, I already sold my case, but there's more reasons why you should use Homer. And keeping up with open source wonders, let's talk about eBPF, because eBPF will become the new secret ingredient for you guys to improve monitoring and analysis of your RTC traffic. But what is eBPF? eBPF stands for Extended Barcode Packet Filter, and it is a technology that allows you to capture every traffic on your kernel space. eBPF comes from its father technology, which is just BPF. And the reason of this extension, of this improvement, was because with BPF you could indeed traffic everything but on the network layer. And with eBPF you can capture everything until the application layer, which is exactly what we need in RTC, right? So eBPF takes advantages of the kernel space, which oversees and controls the entire system. And it is no more than a lightweight virtual machine that allows you to run sandbox programs within the kernel space without the need of changing the kernel source code and without the need for kernel modules. So yeah, as you can see, super innovative and super important to us. One point that maybe you don't know is that TCP/LAN, that we all know and uses BPF, but not eBPF. And again, eBPF is open source. Okay, how does eBPF work? We need to recall that, first of all, eBPF works on the kernel, so you need a Linux machine. And in your Linux machine, we have the user space and the kernel space. The user space is where we do our day-to-day job. It's where we develop programs, applications, SDKs, libraries, everything, right? But what is the kernel space? The kernel space is where the file system exists, it's where the process management exists, device management, basically everything related to maintaining and protecting the operating system and the hardware. And what is the purpose of the kernel besides this? The purpose is to abstract the hardware or the virtual hardware and to provide the API called system calls that allows your applications and programs to run and share resources. But one interesting thing is, in the kernel there are sub-layers and subsystems that exist to share these responsibilities for your applications to run properly. And these sub-layers and subsystems allow for a certain level of configuration, and these are the level of configuration that you may use when your program needs a specific behavior. But what happens if your program needs something that is not available under this level of customization? Well, until eBPF, you had two options, native support and kernel modules. What is the meaning of native support? Basically, you would need to reach out to the kernel community and try to convince them that your issue and your behavior is something that adds on to the community and is not just a you problem. And eventually, if you convince the guys that this is good, then, okay, they need some time to develop the code, make the change, make the patch available, and then you need to download it and upgrade your kernel. So as you can see, this is kind of time-consuming and not guaranteed, so it's not a super awesome option. And then you had kernel modules. And what's about the kernel modules? Basically, they are also not a great option because you are risking corrupting your system. Because developing kernel modules means there are no safety nets whatsoever. You are developing your code on the kernel and you are risking everything. Like if you do a mistake, because, well, those can happen, just, well, new laptop, that's it. And furthermore, let's imagine that you have the skill to develop a kernel module, which, awesome, then you are great. You also need to be prepared to verify the code once in a while, because with every new kernel patch, you risk that your kernel module is no longer compatible, basically. So you need to verify the code from now and then, which is also kind of a bummer, right? And with eBPF, this goes out of the window, because eBPF allows you to change the kernel behavior according to your needs without needing any modification on the source code and without needing to develop a kernel module. So eBPF is the best of both worlds, super easy to use compared to the other two options, and complex enough to get the job done. Okay, now more into the specifics. How does it work really? So eBPF works based on events, and these events are called hook points. So every time the hook point happens, eBPF does its magic. And what events or hook points can you define? Basically, you can define trace points, K probes, and U probes. So anything on the kernel space and on the user space. As you can see already and already perceived, eBPF is super powerful. But how can it be safe, or safer than kernel modules? The reason for that is the existence of the verifier. So whenever you produce an eBPF program, then you load your program into the kernel space. And the first step is a verification step. And this verifier is the one that makes one of the biggest difference and most important from a kernel module to an eBPF program. Because here you are not risking corrupting your laptop, you are not risking like having a vulnerability, because the verifier will ensure that for you. If your program is not safe, it will get rejected, never runs, that's it. Okay, this verifier makes a lot of verifications, but I want to highlight 4 today. And the first one, it's a logical one. Of course, it ensures that eBPF program does not corrupt or otherwise harm the system, logically. Second one, it checks for infinite loops. Your program needs to run through completion. And we all did this mistake before, so no need to shame. It happens, and the verifier is ready to ensure it. Third one, it checks for anything memory related. If you have null pointers, if you are trying to access dynamic memory that is in fact restricted, the verifier will take a look and ensure that the program is safe on that perspective. And the last one, the fourth one, and probably the one that matters the most now, is that the verifier checks that, okay, who is trying to load the eBPF program into the kernel space? Does it have the right privileges to do so? Which really means, is it root? If it's not root, by default, the verifier will reject your code. There is one way to go around this, which is enabling unprivileged eBPF in your laptop, but the community is advised against this approach, and the reason for that is because hackers have been exploiting this as a strong vulnerability, because you may imagine, like, if eBPF allows you to capture everything on the user space, the kernel space, then it's a strong vulnerability. So maybe don't use this option, or if you really need it, use it with strong caution. Okay, so this is a summary of everything we checked until now in terms of how it works. So the first step, you need to, of course, create your code, define the hook points, everything, and then you get the code compiled. You load the code into the kernel space, then the verifier ensures everything is okay, and if it is, then the hook points, depending on what you define, get attached. And we arrive to the final step, which is execution. And guys, remember that execution is, okay, the final step, but it's in fact a loop. So depending on the hook points, the data gets scraped into the kernel space and sent out again to the user space. And on the user space, you can retrieve the data using eBPF maps. And that's it. So it runs on and on until the completion of your program. Okay, now that you know how eBPF works, why do you need it, right? Because until now you have been troubleshooting your calls just fine. You didn't know maybe about eBPF at all, and you still troubleshoot calls, right? Because you use agents like ngrep, sngrep, tcpdump, tshark, everything. So maybe eBPF is an overkill for you. But, well, the fact that is not. And the reason for that is eBPF is much more of an improvement than an agent. When you compare, there are a lot of points where eBPF outperforms a normal agent, but the most important point for us is performance, because RTC, working on RTC means that all the servers that we are working on have high performance requirements, that's for sure. So let's imagine that you have a T-Shark running 24/7 on the server, and you would do the shift from this T-Shark 24/7 to an eBPF program. You would see the difference on the resources. It would be drastic. Like the improvement would be, you would change from a Fiat Punto to a Ferrari, basically. So you can see already, it's the most important point that I want to highlight today, because this is the most important for us all. But yes, I will give you, there is a con to eBPF, which is the learning curve. You need to learn about eBPF, you need to have a certain knowledge about how the kernel works, because eBPF works there, so yes, you need to invest some time learning this new technology. So why should you spend your time there studying this all? Because if scalability didn't convince you, then okay. Let me tell you more, because we are all engineers and you care more about than just troubleshooting calls, hopefully. So there are 2 points that I want to highlight that are not part of the monitoring and observability today, which is my point, but are important to us as engineers. For example, load balancing and DDoS attacks mitigation. And why can you use eBPF for these two? Because from the name of eBPF, packet filters. So you have access to the source IP, destination IP, and everything in real time. And also you have access to the server's metrics like disk I/O, memory, CPU in real time as well. So you can create rules, dynamic, that don't change. You don't need to create a set of rules for load balancing in the peak hour and then when everybody is asleep. You don't need it, because with eBPF, this is dynamic. You have everything dynamically, you define one rule, and that's it. And for DDoS attacks, it works on the same way, right? So you have access to all the information that you need to start and detect and alert someone that probably you are under attack. And yeah, these are all the most important reasons why eBPF outperforms completely an agent and why you should use it. Let's imagine now that after this blah, 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 you are not caring because, I don't need to care about infrastructure. I don't need to care about load balancing DDoS attacks, that is not my field, and that's fine. You just need to troubleshoot calls, and you still think that my blah 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 is not enough because you are doing just great with agents. Again, you are wrong, and the reason for that is the increased concern about TLS and encryption. Like nowadays, almost all the traffic is already encrypted, and it can be maybe that some of you are decrypting the traffic as soon as it reaches your network. It could be. And if you are doing that, just in case, first of all, it's already strongly discouraged. But yes, you may do it because you have access to the private key. So if you know how to hack around it and use the private key to decrypt the traffic, that's possible. So you can still use Wireshark, TCP dump, and get to know everything. But in the future, with TLS 1.3, the private key is already embedded in the TLS handshake. So no more private key, then what? How can you troubleshoot, right? So basically, this is to say eBPF will become the norm in the coming years, so maybe start to studying it now would be great, right? And now you are thinking, okay, but what if there was some open source tool that already scraped eBPF from the RTC network? That would be nice, at least I can start from a place other than zero. Well, Alexander made your wish come true. I don't see him, but okay. Yeah, so Alexander made your wish come true. We have indeed an agent that scrapes eBPF from the RTC network, and that agent is called RTC agent. And it greatly differs from any other agent because, as you can see, it does not require any code modification or patches, does not require access to the network interfaces and packets, and it traces functions used for sending and receiving data. Well, this means what? This means that you can trace every sent and received packet independently of the protocol in place. Again, if it is TLS, it doesn't matter because it runs on the kernel, so not an issue. And another common issue that we have is packet fragmentation. Again, all the packets on the kernel are reassembled together, so packet fragmentation, gone. Gone, no more packet fragmentation to harass us all, so another benefit. The only requirement to use this agent, RTC agent, is to have the kernel version 5.2 or above. That is the only thing that you need to have. And actually, one thing that I can say about this kernel version and eBPF technology is that you may compile your eBPF program just once and run it everywhere that you want. You don't need to compile locally. No, you compile just once, you export the code, and you run it everywhere that you desire. Okay, in terms of the hook points we defined in RTC agent, mostly were you probes, but you are more than welcome to add anything that you may need, P proofs, K probes, you name it. You may desire different things than us. So, of course, check out the repo on GitHub and contribute or give us your feedback. Okay, now that you know how mostly how eBPF works, and now that you have a RTC agent, which is the eBPF scraper, you need a place to send everything, the logs, the metrics, the traces, the pickups, and OMER 10 is here for that. So OMER 10 is an innovation, but in terms of the SIP, RTCP, and HAP part, everything is the same. So you can still see your call exactly as before, you can export, you can share, all equal. So what's the difference? What's the improvement? The improvement comes with the metrics, logs, and traces, and that part is powered by Querying, which is another product, as usual, open source that we have. And Querying is a polyglot observability API, and it is compatible with any agent that you may think and use, like OpenTelemetry, Prometheus, Tempo, Loki, Elastic, I don't know. Probably anyone that you choose, we are compatible. And this is where also we insert the eBPF. This is Querying. Another difference was with the UI, so which changed the UI to integrate with Grafana. Now OMER 10 is presented in Grafana. And the reason for that is because, well, Grafana is widely used in our community, everyone is comfortable. We know that creating dashboards is super intuitive, you may create alerts there as well, so why not? We just thought it made sense. Okay, so this is the UI of OMR 10, everything in one place, as you can see. So right now you may have OpenSIPS running for the signaling part, and then you have RTC agents scraping the metrics. And you remember those times where there was a network issue, and proving that the network issue was the source of the call degradation is hard. And sometimes the hard part is data correlation, because until now you needed to go to 5 different platforms because everything is spread out. You check pickups in one, telemetry in the other, then you, but this server is not here, you need to go somewhere else, and you need to pinpoint and correlate manually. Take the timestamps, everything, and it's super time consuming and sometimes becomes impossible. And OMR 10 is the missing piece of the puzzle that we try to deliver here with this, trying to fix this issue, because now you are able to have everything in one place, so it's easier to correlate and hopefully makes your life much easier. Okay, more into the specifics, as I said, OMR 10 in terms of packets, as before, everything as before, the call flow is available, and actually guys, the call flow visualization is a Grafana plugin, so this is where you can contribute if you want to. In terms of logs, so hopefully this works as you would expect. You should have a label, export the label, and then you search for the value. That's it, that's simple. In terms of metrics, they work exactly in the same way as the logs do. Traces, you need to know the service name, and that's all. And in terms of profiling, this is where eBPF enters the chat, and we are compatible with eBPF profiling, of course, and also native language profiling like Rust, Go, Node.js, Java, and many more. Okay, how I am not tracking the time. Okay. Okay, so for the last topic of my presentation today, I wanted to show you guys some options for AI. How you can have AI improve your life in RTC, and how you can have the results in OMR. So, AI is for sure the biggest bubble since COVID-19, we all know it, and probably some of you don't want to endorse in this bubble, because you are thinking that you would need to spend a lot of money, and you really are not so up to it right now. Well, firstly and foremost, there are a lot of ways where you can use AI to improve your life. Let's start with that. And from all of them, the 2 ones that I want to highlight today are conversational AI and sentiment analysis. So conversational AI is the possibility to have an automatic reply to the first interaction with the customer. So the trick here is real time. You need to give an answer and you need to give it fast. It's real-time communication. Whereas sentiment analysis is useful to understand the customer mood, like if the customer is being well treated, or otherwise if the customer is getting super frustrated and more frustration as the time progresses. So this is more as a aftermath, and it's good for future improvement. How in a similar situation we can do better, kind of approach. Okay, related to the bubble that AI is, even though, yes, it is a bubble, it seems that it is here to stay at least for a little while. And, okay, I searched many sources online, and this was one of them, Global Market Insights, that said that speech analytics market was valued at $2.5 billion USD in 2023, and it is estimated to register a compound annual growth rate of 70% between 2024 and 2032. There are many sources online that go around the same valuations, and some other sources actually estimate these super higher, because of course they are getting crazy. But this is all to say that, okay, even though it's a bubble, it is here to stay for sure, and maybe we can take advantage and be into an exploration mode without needing to spend any money. And how can you do it? This is the first approach I want to show you today. And this one is not in fact new. This was first shown at OpenSIPS Summit in 2018. And the trick here is what? So you have OpenSIPS for the signaling part and RTPEngine for the media. Then you need to configure RTPEngine for recording the media, and you pass this media through this speech-to-text repo from Lorenzo from 2018, which we changed yesterday, and it now works with Whisper that someone already talked today, so it's working. And then you get the transcription of every call, and it sends it as a rep log to Woman. So what this means is that you have the first foundation to do whatever AI that you want. If you want to do sentiment analysis, sure. Conversational AI, sure. You want to do something else, great. It's also, because this is the first step that you need. And sometimes it's the most complex. So yeah, this is how it started. And now let's see a more powerful tool from Maxime, that he will present this in depth tomorrow. But I wanted to give a shout out because this is really much more powerful than just a speech-to-text repo. With this one, you can do speech-to-text and text-to-speech. You can change the language, like from English to Portuguese to whatever you want, really. And it takes your AI to the roof, basically. So if you are already in a position where you have... Okay, I'm finishing. If you are already in a position where you can explore more than just speech-to-text, please check out this one, but Maxime will explain tomorrow. And that's it. So this is all that I discussed to you guys today. Please check out in GitHub and give us your feedback. And as always, contribute to the open source community. And thank you so much for your time.
It's nice to see the other half of the human race represented up here. Hey, can I get a couple of volunteers to grab some QXIP t-shirts back there? Please, 2, 3 people. Grab some sizes, bring them up here. I don't know if you guys knew, but these were available to you as part of your convention package. Summit package, if you will. Okay, well, put them right here. Whose birthday is in March? All right, give those guys some t-shirts. There's 2 back there. Launch those.
This one's lying. I see on his face. It's not one.
It's, wow. That's better authentication than stir shaking. How about, oh wait, we still got another March over here.
2 extra large. 2 extra large, wait. Yeah, of course.
Wait, what are you doing? Hold on, this is a controlled experiment. Take it easy. Hold your man back. Whose birthday is in August? All right, there we go. Come on, wait, the man's right here. That's it? Really? One person in August?
Doesn't make sense.
Doesn't make sense at all, huh?
Come on, we're all a little bit mathematician.
I mean, you're all a little too old to be COVID babies, but still. How about January? Who's in January?
Who's an extra large? No, whatever. January.
Way back on the end.
Almost.
All right, how about October? Wow. Well done, yeah! Any more Octobers? Don't get scared. All right, who implemented eBPF? Who's got the answer? Wait, you didn't even get your, wait, he invented it?
No.
Okay, he's still October. Who invented eBPF? Answer this question and you will get a t-shirt.
Who implemented it? In his own network.
Ah, okay. Who's played with it? There we go. Give those people some t-shirts. Clean yourselves up. All right, let's go for... give me the number. Who thinks they've been to the most OpenSIPS summits in this room? Who's the highest number participant? Wow, well done. Who's, let's see, third. This is their third summit. Give this, no, you already have one, man. Like, you've already been recognized. Third summit. What about the fourth? Wow. Third. I'll get the fourths in a second. You're going to be extra special.
Okay, we reached the last pile of the mediums. Yeah, and large, whatever.
Okay. We still have some people back there. This is their third OpenSIPS Summit. I said volunteers, not volunteer. Look at you, lazy bastards sitting over there. That's right. Okay, who's four? Is this who's got 4 OpenSIPS conferences under their belts? Wow. 4. 5? Give me one of those. So I'm going to take the rest of them. 5, 6, 7, 8, and 9. No.
I sent some two extra lunch for you to decide. I got like an Alex pack here.
Thank you for being so considerate and at the same time inconsiderate. Okay, look, Rita, thank you so much for giving us some information. Let's give Rita a round of applause. Now, I grossly missed any questions for Rita, but she'll be available for today and tomorrow. You want to talk to her one-on-one, which I'm sure some of you eligible bachelors do. She's over here. Feel free to reach out, but don't touch. All right, coming into us from the home, the motherland of OpenSIPS, Romania, Mr. Vlad Payu. He's been a staple here. Oh, you weren't even ready, were you? Stop blaming it on Razvan. No, he's Jesus. Okay, so without further ado, Vlad Payu is going to be talking about OpenSIPS deployments in the cloud. Vlad, take it away.
So, yeah, my name is Vlad Payu. I've been around in the OpenSIPS ecosystem for a while now. Today I'll be talking about some OpenSIPS deployment to the cloud. We're going to go through why it would be good to do this, and then we'll walk through a practical use case of just running an OpenSIPS-based registrar routing engine in AWS, going from the architecture and covering some implementation, some common challenges, and then hopefully we'll reach some conclusions. First, why in the cloud? Well, the number one reason would probably be high availability. Cloud providers usually offer built-in mechanisms for this, so basically you get the advantages of global reach. There's data centers pretty much scattered all over the world, and you get the added advantage of being able to be localized to your subscriber base. So let's say, I don't know, if your subscriber base is in the Middle East, you just can deploy to the AWS Middle East data center, and you should be close as possible to your users. And also, cloud platforms offer great mechanisms for redundancy, load balancing, failover, and simplified disaster recovery. Another reason for going to the cloud would be scalability. So you can do rather quick scaling both up and down. So this ensures that your service remains consistent, reliable, cost-effective, even with very unpredictable workloads. Another advantage would be simplified management and maintenance overall, again, driven by the tools that are available to you in the cloud by the provider, such as deployment automation, real-time monitoring, alerting, and overall just better security management. And also, last but not least, you would have faster integration. For example, in AWS, we have easy access to network load balancers, some SQL and NoSQL databases out of the box, message queues, you can use service computing. So you can have a much quicker route from, let's say, idea to actual implementation simply by using what's there available for you. So for the practical use case, I'll go through just setting up an OpenSIPS registrar and routing engine. In AWS, we'll be trying to support WebRTC clients. For the authentication part, we'll go with JWT authentication for those clients. We'll try to support mobile devices out of the box. That means supporting push notifications in an OpenSIPS cluster. And lastly, setting up peer-to-peer calls between those users and also dealing with PSCN termination for them. All of this will be, let's say, hosted in AWS, so we'll try to make strategic use of all the advantages that are there for us. That includes multi-AZs and auto-scaling groups for OpenSIPS, network load balancers using RDS, which is their SQL layer, let's say, DocumentDB for the NoSQL side. It's possible to use Cognito for the JWT identity management. Obviously, Amazon MQ if you want to push some CDRs or some events or whatever to there, and just using AWS Lambda functions for some serverless. The general architecture that we want to target is something like this. So we'll have our users going WebSocket secure to our platform. They would hit a network load balancer, which would convert the WebSocket secure traffic to regular WebSocket. Then that WebSocket traffic would reach an auto-scaling group of 4 OpenSIPSes, each split between 2 availability zones. All of the OpenSIPSes would talk between each other with the cluster module, basically synchronizing whatever information they need. And all of the OpenSIPSes would be able to control a pool of RTPEngines, again deployed in an auto-scaling group. We'd be using RDS for storing some provisioning data, DocumentDB for our federated subscriber clustering, and we'll be pushing CDR data to Amazon MQ. So let's see how we would go ahead and do all of this with some examples from the OpenSIPS scripts. So first of all, as part of the listener, OpenSIPS, we just have to listen on regular WebSocket. Of course, this is the usual AWS setup where you have a private IP and you're advertising that interface as a public one. In this particular example, the network load balancer will be handling our WebSocket secure to WebSocket conversion and deliver it unencrypted to OpenSIPS. This has several advantages, like we would have a centralized place for our certificates, which is the network load balancer. So then it would be much easier to update or renew our certificates. We wouldn't have to reload all the OpenSIPSes or restart them or whatever. We would just change the certificate on the network load balancer itself. We'll get reduced complexity in OpenSIPS because, of course, it's much easier to handle WebSocket unencrypted versus encrypted. There's just simply less work for OpenSIPS to do. We would have a reduced attack surface. Again, if, let's say, if further vulnerabilities are found with OpenSSL or whatever, TLS library, we wouldn't be dealing with any of that in OpenSIPS. We would basically rely on AWS to upgrade their network load balancer so they're no longer vulnerable. And of course, we'll take advantage of being able to deploy the network load balancer in a multi-easy deployment, so we'll make sure our load balancer is highly available. For the authentication part, we'll just go with the classic JWT authentication mechanism. So that means checking if the authorization is bearer. So if somebody is trying to authenticate with regular digest username and password, we'll just reject the request. We'll just take bearer JWT authentication. And then we'll go to the classic of taking the token from the authorization header, extracting the claims, the headers, and from the claims we have our issuer. Here the issuer can be your Cognito, let's say assigned URL, or you can opt to implement your own, let's say OAuth 2 endpoint, which is advertising the public key. But whatever route you're taking, it's best to check who is the issuer of that JWT that you are receiving. Obviously, you want to only authenticate your users and not just some random guy which has a JWT from Google, let's say. Another thing to verify with JWT is usually it's expiry. You don't want somebody to get a hold of some old JWT that you issued and just authenticate with that. And after you've checked that it's not expired, you would do your magic to fetch the public key from the provider, so either from Cognito or your own server. And then it's just simply about calling JWT script authorize, pass it the token, the key, and if all's good, it means the signature is valid and the user is authenticated. So here, there's not much difference if you're going with AWS Cognito or if you're managing your own key. For the registration side of things, for the users, we will be going with a federated user location approach. So if you remember the initial architecture, we had 4 OpenSIPSes with a network load balancer in front. So that means that effectively each node will get sort of 25% of all the pool of subscribers that are registered at a certain point in time. And we'll be using an OSQL document DB in this example for storing the mapping between which AOR is registered on which OpenSIPS node. So basically the flow would look something like this. When a guy just decides to register, in this example it's Alice, she would go to the network load balancer, that would send her to one of the OpenSIPS nodes, in this case OpenSIPS 1. It would then save in local memory the mapping of Alice being registered here, and it will also write to document DB that Alice is registered on OpenSIPS 1. Then when Bob would call Alice, he would also go to the network load balancer. Let's say in the case he goes to a different OpenSIPS server, that OpenSIPS server will look up in its internal memory and see that, no, I don't know where Alice is. Then OpenSIPS 2 would go to document DB, get the node where Alice is registered, and then it would know automatically to call Alice through the other OpenSIPS, and which will eventually send the call out to Alice. Fortunately, much of this routing complexity is abstracted from the script writer by OpenSIPS, simply by using clustering in combination with the user location and registrar modules. So you would just configure the clusterer module, point it to RDS where you store the full list of OpenSIPS nodes in the cluster. And then in user location, you would just say that your working mode preset is federated CacheDB cluster. You would point it to the cluster ID by using the location cluster, and then point user location to document DB so it automatically knows where to get the information about where AOR, which node each AOR is registered to. So in terms of scripting, a lot of magic is done under the hood. The registration and invite processing looks fairly similar to one single OpenSIPS node deployment, let's say. For register, you would just call the save function, obviously after doing JWT authentication, and the save would automatically save the AOR in document DB for you. Then when we get to the invite processing on the ingress node, on the incoming node, we'll call lookup with the global flag, query the document DB, and automatically fork the call to all of the nodes which hold the call destination, AOR. And then same on this ingress node, on the branch route, we would look, are we going to a peer OpenSIPS node, so that basically is item 9 over here. And if it does, we probably want to take that call path through our internal network and not send it through the network load balancer. And on the receiving end, we would just check, yeah, did we receive this call invite on our local socket? And if we did, it means some other OpenSIPS node figured that we are holding the call destination. So we would just need to call lookup here without the global flag. We are just looking up in our internal memory. So just by doing all of this, you would have the ability to get the users registered and call between themselves no matter where, on which node the network load balancer actually sends them to. For push notifications, again, fairly similar. OpenSIPS tries to abstract a lot of the complexity away from the scriptwriter. So what you need to do is to just configure the pn_enable parameter in the registrar module, set that to true, set the list of providers that you want to accept. And then just by doing this, your SIP clients will be able to send the classical push notification ID and the provider as part of their register requests. And then automatically, when calling lookup, in order to deliver the call for these push notification enabled devices, OpenSIPS will call this event route UL contact refresh for you, where you can actually trigger the push notification, wake up the device, and then when the device registers, finally OpenSIPS will automatically forward the call to it. Like a basic call flow would be that Alex is calling Bob. OpenSIPS would asynchronously start waiting for Bob to register. We would call the push notification provider to wake up Bob, which would eventually reach the phone. Bob would register, and then OpenSIPS would automatically send the call back to Bob. So all of this is done automatically by OpenSIPS. You don't need to do anything for it, except this is not really our topology. In our example, we have multiple OpenSIPS nodes. So in case Alice is calling Bob, the network load balancer might throw her to OpenSIPS 1. It starts waiting, wakes up Bob, but Bob might reach a different node entirely, which isn't waiting for Bob to register. So eventually, the call will time out because nobody registered here. So basically, these are complications of using a network load balancer, which might deliver the call someplace else. One quick idea we could try is to get Bob to register specifically on OpenSIPS 1 as part of our push notification. The problem here is that over here we have just WebSocket unencrypted, so it's not possible for a device to use WebSocket unencrypted directly to our node. So we would have to script our way through this time. There will not be any automation. So when we call Bob from Alice, we have to have this OpenSIPS wait for it, wake him up, he reaches a different node, and then from this OpenSIPS 2, we have to figure out that Bob has a pending call on OpenSIPS node 1. And if he does, we have to fork the register over to OpenSIPS 1. And then once we get here, the automated part about sending the invite out will happen. The invite will go to OpenSIPS 2 and finally reaching Bob.
Also, a parameter to the push notification.
Yeah, but the problem is you cannot go straight to the node. So if you try to force a parameter to go to the node, you will not be able to, because we are encrypted and the devices only speak encrypted to the load balancer. So we would have to script part number 8 here and basically fork the register further on, use probably path support, so that when the invite is generated, it automatically goes to OpenSIPS 2. I didn't want to take too much time here to go over this. I guess the lesson is the routing flow gets pretty complicated. It can end up involving several nodes, 2, maybe 3, maybe 4, depending on what's the setup that you have. The good news, the OpenSIPS script logic is flexible enough and powerful enough to allow you to implement basically all of this logic here. For PSTN routing, we would use the dynamic dynamic routing module, so no surprises here. This is also integrated in the cluster support, so we can have all our nodes be aware of the state of all of our carriers, and when we want to route out to them, we will just call the do_routing function. The problem is we have all these like 4 OpenSIPS nodes, and they might reload at different times or different moments. So we need to have a way to ensure that all our nodes have the same data in memory. And OpenSIPS 3.5 has this generate data checksum parameter. If you set it for each reload, basically OpenSIPS will generate a hash of each partition that it has loaded. So that would be something that you would want to monitor in your monitoring system, basically, to ensure that all of the nodes actually do have the same data in memory. And since we got to monitoring, here one of the easiest ways to handle this would be by using Prometheus. Setting that up is as simple as just loading the module, configure it which is the root, HTTP route where it will serve the Prometheus statistics, and then just set up this statistic parameter as many times as you want for all of the statistics that you want to automatically have exported to Prometheus. In this example, I'm just doing some active calls, statistics, some registered users, and the shared memory usage. Again, this assumes that basically you can only export what is an OpenSIPS statistic. The problem is that not everything is a built-in statistic in OpenSIPS, so you would need a way to define custom things or export custom things. Some examples here are like how many dialogues you have in a profile. That is not a statistic, so that's not something that you can easily export to Prometheus. How many calls per second are on a rate limit pipe? Again, that's not a statistic, so you cannot export it directly in the old way. But in the new OpenSIPS 3.5, you have this ability of just configuring an OpenSIPS route, and there you can script whatever extra stuff you want to add to Prometheus. So you can script, okay, how many RTPEngines are disabled, how many dialogues are in a specific profile, and so on. And you can just throw that out as well to the Prometheus HTTP endpoint. So basically, we kind of went a little bit fast, but from the OpenSIPS logic point of view, we should be set up to support this architecture. I didn't cover much of the RTPEngine side, but that isn't really very different as opposed to what everybody is doing right now. So you would just configure the RTPEngines and call RTPEngine engage. OpenSIPS will just pick up a random node from the pool. Now let's get a little bit to the scaling part. So we have these 2 auto-scaling groups. One is OpenSIPS, one is RTPEngine, and we need to kind of do some things when, as part of our monitoring, the AWS conditions are met that we need to scale either the cluster up because we have increased demand, or scale down because we have too many instances spawned and they're just sitting idle. For the OpenSIPS scale up, obviously you have to build the instance, but after you set everything up, you need to insert it into the cluster table and trigger cluster reload for all of the other OpenSIPS nodes to now know that, okay, there's a new peer in our cluster. And here, one option would be to use AWS Lambda for that, for getting the current nodes in the auto-scaling group and just triggering the cluster reload MI command. Scaling down is a little bit harder because you might have still traffic, still users registered there, or still ongoing calls. So if you want to scale down, you need to first drain the chosen instance. That means making sure it receives no new requests, so it's no longer in the load balancer pool. You would have to forcefully end all registrations. So basically killing the TCP connections of the user, then those specific users will go back through the load balancer and get redirected automatically to another node. And depends on your policy, you might want to wait for the active calls to end but here you need to be careful about stuck calls. So you definitely need to have like a timeout here about how long you wait. And then, yeah, just delete from cluster and trigger the cluster reload JSON RTC. Another thing to be careful about is you have to maybe clean up document DB, because if we are just, let's say, killing one of the OpenSIPS nodes, there might still be AOR mappings in document DB saying that Alice is registered on OpenSIPS 4. So if we take down OpenSIPS 4, we also need to clean up document DB, or else we'll end up with a lot of garbage there. For the RTPEngine side, it's again fairly easy about scaling up. You need to set up the instance, insert it into the RTPEngine table, and trigger RTPEngine reload across all of the OpenSIPS nodes in the cluster. Scaling down and crashes are, again, a little bit different. In case of a scale down or crash, you have to move the media from the respective RTPEngine that crashed, or you want to take out to another node, and obviously deleting and reloading. How we do that from the scale down crash, basically each OpenSIPS node would detect that, okay, RTPEngine 1 is down or about to go down, and then we would go to another RTPEngine node, getting new media ports, and then re-inviting both call parties through the new RTPEngine. Luckily, OpenSIPS allows you to easily do this. You can just call the RTP relay update function, say that you want to move everybody from the 10.11.11 node to the 10.12, and OpenSIPS will internally deal with all of the re-invite logic for you. That's kind of what I wanted to discuss about. Some takeaways are, yeah, the AWS is a great place to deploy your OpenSIPS solution. Things to look after are that more complex network architecture often lead to more complex SIF flows. OpenSIPS does do a good job of, let's say, outsourcing this complexity whenever it can. We've seen examples in the push notification side and the registration clustering side, but for certain scenarios you'll have to get your hands dirty, and the good thing is the scripting language is flexible and adaptable enough that it allows you to build all of this functionality. And yeah, that's all I had. Questions?
Not yet. First, a round of applause for Vlad.
That was deep.
That was deep. Do we have any questions? I have time for one question. You're okay?
Has anything changed in terms of the path support? So when you save to user loc and have a federated backend data store, like you have a call route from a server that the registration doesn't live on to the server where it does live on. You said that happens automatically. Is that part of the cluster? Because normally you would have to have added a path header, and then, like, I remember back in the day, you'd have to loop it to yourself, and then you could get, you could call save after the path header's been added, and then that would get it added to the database in user location, so that when you did the lookup, it would be restored as a route header. But that was all manual previously. Has that changed with the cluster, or is something else happening that allows it to find the server where the user is actually registered and then send it there?
No,
six-part question.
nothing has changed. So you would still have to script 8 and sending the register over. The good thing is that you do have some better clustering support, so in theory you can broadcast to all of the nodes saying, yeah, Bob needs to be contacted in OpenSIPS 1, so everybody going there can knows that OpenSIPS 2 knows that it needs to send a call to OpenSIPS 1, and then yeah, just path support, send it back. So this is the part where you need to get your hands dirty and script
That's
itself.
fine, yeah.
Maybe sometimes if you ask Bogdan, this will all be integrated, but so far no.
No. I mean, there's ways to do it now. It's just, I thought you said
It's
it
not
automatically, and I was like, wait a minute.
That, with all the other feature requests, are down in the ladies' room, so, okay, Vlad, thank you so much. Give him one more round of applause here. So, take it easy. This doesn't belong to you guys. I think the next presenter has their own. So thank you. We appreciate it. Norm, a staple here as well. Been around the block a couple of times. Got lost around the block once or twice. He's, uh-oh. Here we go. There we go. Patience. Norm, if I what? The hell do I look like? Somebody get this man some water, please. Over there? Somebody? No? Nobody. Nobody's got your back.
Hey everyone. It's been a long day and wait a minute. Oh, this is me good without my notes. Hold on a second. Hang on a second. My time's running out. Here we go. Now I've got my notes up. Give me 1 second.
There is no water, just so you know.
All right.
I do have love for you, but there is none.
Okay, here we go. So I don't know why I'm even looking at my notes right now because I'm gonna go off script before I even started. We had some great talks, and Brett's talk was good. He mentioned he's been involved for a long time. He mentioned OpenSIR, and I'm like, oh yeah, I remember those days. I first got involved with OpenSIR. I think my first patch that my first PR was for Free Radius. That was a long time ago. And I'm glad to see a big crowd here with OpenSIPS. OpenSIPS is a great project. Back then, when OpenSIR was around and I first was using this, I owned an ISP. I'd started an ISP, an internet service provider. Early days of the internet, pre-VoIP almost, you know, OpenSIR and SIR were really the beginnings of open-source VoIP. And back then, my ISP was up in northern New Jersey, and there was another ISP, a competitor, that was a little bit further away, but back then we had monopolies that, well, we still have many monopolies all around, telephony monopolies, telecom, and we really didn't compete against each other back then. We were like close to each other, but not actual direct competitors. It turns out the world has turned, and I'm now working with Planet Networks. I want to thank them for helping me get out here and talk once again at OpenSIPS Summit. The discussion about high availability in RTPEngine is a little bit different than maybe some of you, because Planet Networks lays its own fiber. So we're actually running glass as the last mile. We've got deep background in hardware and in software and in networking. Thank you. Oh, man, so having the last mile, the ownership to the customer, is huge, because a lot of the problems, I don't say a lot, some of the problems that we have with pure cloud implementations, where all of your customers may be coming in over the internet, kind of go away. The fact that we've got such deep knowledge in the cloud, also the cloud and hardware, means that we also have our own hardware in data centers. So dealing with the cloud or network load balancers and having to deal with some of the problems that they have, because their focus is not always voice. Okay, their focus is hardly voice at all because they just, have a focus on HTTP and other technologies. We find that we're able to solve problems a little bit differently. So some of the designs and some of the HA that I'm talking about with RTPEngine, you'll see there's some similarities to what Vlad just talked about, but because we're not using, quote, a cloud environment, it makes our life, I won't say easier, but a little bit different. So that's kind of an intro. I'm going to talk about what you guys and gals are going to be able to get out of this talk. We're going to talk about some high availability topics, obviously. I'm going to provide some architectural components. Going to get a little bit into the weeds. Might get a lot into the weeds. I'm going to talk about design in the weeds, and we'll wrap it up, and hopefully you'll be able to take away one or two tidbits. So who's going to benefit from having HA and a redundant setup is the customer. And if anybody here thinks the customer isn't the most important person in the room, I think you've got a problem, because the customer is the one that pays the bills. They're opening their wallets every month or whatever your billing period is, and they're paying you money. And if you're not 110% focused on your customer, you're not in the right business. I've asked actually some people, some experts who some might even be in the room today, about high availability. And what their answers were was high availability and redundant solutions using our technologies. And I've heard that creating an HA system is too complicated. I've heard that it's, hey, you know what? It's okay to drop a call as long as the next one works. I've heard, and this is real life. I actually queried some of the folks I work with, or some of the folks in the community that I know. It's better to have a server just not crash than, that's their high availability perspective. And it's like, okay, I get it. I completely disagree. The goal for you should be, for us all, should be 100% uptime. Is that realistic? Obviously not. 5.9. 5.9's availability is 5 minutes and 15 seconds of outage in a year. That's what 5.9 is. I think that's not good enough. But, I'm also, we all live in the real world. We know that that's not always realistic. There is a point of diminishing returns. You can spend a lot of money trying to build, a super high availability redundant system, and at some point, it does not become cost effective. The cloud providers, we just saw, Vlad's talk about Amazon. The cloud providers say, hey, let's throw hardware at the problem. Hey, spin up more servers. There's some value to that. Maybe it reduces the blast radius. If the server goes down, it increases their bottom line because you're paying them for more servers. So, of course, the cloud providers have a vested interest in offering that kind of a result. Throwing more hardware at the problem, I maintain, is not a solution. It doesn't fix the problem. It sweeps it under the rug. It really doesn't solve the underlying problem. And I think we should be looking at where we can, where it's feasible to solve the underlying problem. As I said, there is no perfectly high available system. There are components that are just out of our control. I was at a carrier, not a carrier, I was in another company years ago that had a carrier that was in a less developed country that actually it was a telco that had some equipment down in a basement, and that basement lost power. It's like there is no amount of HA that we can put out there that is going to help that carrier's customer. That call's gonna drop, new calls aren't gonna work to that customer. So yeah, while the goal is high, setting the bar high is, I think, what we should always strive for. Getting there 100% of the time may not be realistic, and that's the way it is. What are you, hopefully, that are here going to gain? You know, I'm going to talk about some systems level architectures. I'm going to talk about DNS. I'm going to talk about RTPEngine and how that works with OpenSIPS and how we can try to make calls stay up in the face of failures, in the event of a failure. They will happen. I'm going to talk about virtual IP addresses, how they can be managed. Again, I can live in the world of virtual IP addresses because, as I said, in our environment, because of our ownership of the hardware, we can move VIPs around, virtual IP addresses VIP. We can move them around very, very quickly. If you go to a cloud provider and see how quickly they can move a VIP around, you'll look for other ways of getting redundancy and high availability. I'm going to talk about Keepable ID. You'll learn a little bit about another open source project that's been around, almost as long as me. I think it's been around 20 plus years. Keepable ID as a way to help manage these virtual IP addresses. Again, if you live in a cloud environment, Keepable ID might not be the best solution for you, or one that works for you that well. The recommendations and the design topics I'm going to talk about are just one way of solving a problem. Your particular business use case, will determine whether this works for you or doesn't work for you, or whether there's a piece of it that does and another piece that doesn't. I'm going to briefly show a little bit about how Docker can be used with OpenSIPS, because the world is moving towards Docker. It is a very good way of deploying services. I'm going to talk a little bit about clustering. You should see a little bit more. You saw a little bit. Vlad put up a little bit of clustering. I'll put up a little bit more clustering, but not that much. I'm not going to go deep into every single component and everything you can do, because there's just not enough time. And I'm going to talk about how to keep a call up you have going through OpenSIPS and RTPEngine in the event RTPEngine fails. You saw Vlad briefly talk about one of the commands that you can use. That's absolutely right. There are a couple of variations of that, but that's what we're going to talk about, and hopefully that's what you'll get out of this talk. So, Alice and Bob, these are our buddies. I don't know how they get any work done during the day, because Alice and Bob are really busy, setting up these call flows for us. This is very simple. Obviously, Alice is calling Bob. Bob's responding. Not much to talk about. But I just kind of want to level set. This is like a ladder diagram. There'll be a few more diagrams like this. No good talk can go without looking at the trapezoid, the SIP sequence diagram and the trapezoid. Again, you've got Alice and Bob keeping us busy. But in all seriousness, understanding the concepts on these two slides, on these two pictures, will go a long way to getting value out of this talk, and to understanding how HA and redundancy can help you. Starting with DNS. Again, this is the poor Alice and Bob DNS question. Alice says, "Hey, I've got an outbound proxy that my network folks or my vendor gave me, and I need to call Bob. How do I do it? I don't know where Bob is." So Alice has to go ask. There are other ways of doing this. As I said, I'm presenting one way of solving the problem. Your business case may have other. You may say, "Oh, I don't want to use DNS. I want to use something else." It's like, okay. The DNS server says, "Okay, hey, here's the IP address of OpenSIPS." Well, first, before Allison can call Bob, Allison's got to get to OpenSIPS. And so this is, again, a very simplified flow. Now, we start talking about what really is going on under the hood. You've got, Alice making a DNS query. We get a name authority response from the DNS server with a number of service addresses. Alice will then may then do an SRV query to get a list of potential OpenSIPS servers to say, "Hey, I have a call to go to Bob." Eventually, Alice will get an A record from DNS, and then an IP address. With the IP address, Alice can say, yep, send this call out to Bob. And a little complicated, but that's underlying DNS. This is an example of what the DNS records look like. As I said, at the very kind of top of the diagram, you'll see Alice gets just an outbound proxy. Alice is not going to get an IP address of a single OpenSIPS server. That would be silly. She's going to get an outbound proxy address, and you'll see the various lookups at the very bottom. You'll see the A records that actually provide an IP address of an OpenSIPS server that the DNS server will return. Now, hopefully, Alice's soft phone or hard phone or whatever phone she's got is smart enough to cache some of these. There's good and bad with caching DNS records. We're not going to go too deep into that because let's say she caches DNS record 1 and then 2 minutes later she makes a call and that server is down. Then she's got to go do various lookups or go to OpenSIPS 2 or whatever. So she would have had to have cached the SRV records first. So there are rabbit holes to go down with all of this. But at a high level, this is a way that we can have a pool now of 3 OpenSIPS servers, and how Alice, who doesn't know about them, can reach out to all 3 of those. Okay, now once Alice reaches OpenSIPS, so right, she's got the IP address, she hits one of the servers in the pool, one of the OpenSIPS servers in the pool. She says, "Great, I got to go call Bob." Well, ringing Bob's phone is great, but she would probably like to talk to Bob too. And so that's where you've got to bring RTPEngine in, or with deference to Max, it could be RTP proxy, it doesn't really matter. But basically, RTPEngine needs to get itself in the flow. And so again, the high-level diagram, the nuts and bolts diagram is here, and I'm not going to go into the details, other than to say that I've searched far and wide to find a really good explanation of this particular flow. You'll find PCAPs, you'll find various descriptions that are very technical that have your SDP listed there with various IP addresses and ports, and it's gonna be like, yeah, really, it's like, okay, my head's hurting after I draw some lines and pencil mark up the output. So I just decided to try to verbalize or put in text what basically happens. And at the end of the day, what's happening is Alice is sending her RTP to RTPEngine, and that's all she knows about. She doesn't know about where Bob is located. She doesn't care. She just says, hey, I'm sending it out there to RTPEngine. Bob's the same thing. Bob's going to send and receive his RTP to the same RTPEngine, and RTPEngine does its magic of bridging the media together. So, as I said, this is my take at trying to have a text version of everything. If you've ever been down this rabbit hole, you've probably only seen PCAPs, and then I don't know, maybe it's only me that finds those kind of difficult to decipher the first 10 times. Maybe after that, it's not as hard. Let's see. Okay, so now we're into OpenSIPS and the RTP relay module. Probably one of the greatest things to somebody that's ever written a script in OpenSIPS is RTP relay, which really hides a lot of the call setup. It hides a lot of this behind the scenes, which for me, I'm pretty happy about, because otherwise you got to do a little bit of scratching your head and going back and forth with reply routes and various configuration options inside OpenSIPS. Now, the RTP relay module does make it very, very easy. It can be RTP proxy, it can be media proxy, if anyone remembers media proxy, if anybody's using media proxy. But this just shows just an easy way. This is all you really need to get OpenSIPS and your media engine, and Alice, OpenSIPS, the media engine, and Bob talking to each other. which is a lot better than it used to be back in the day. To set up your pool of RTP engines or RTP proxy engines, you probably want to put them in a database. I guess they could go in memory if you wanted. But a database is nice because when you scale out, when you add a new engine, or if you want to scale it in, you can just change the database, do a reload, boom, that's it. You've got a new table. Now OpenSIPS is only going to use the engines that are in the database. It's kind of a nice way. It's not the only way to solve the problem. You could have dynamic variables, you can have shared variables, there are lots of other things you can do, but this is a nice way of setting something up, especially if you've got a pool of OpenSIPS servers and the pool is all pointing to the same table. The whole pool knows which RTP engine we should be using and which ones we aren't there anymore. The set ID column is really nice. Again, if you start to think about pools of engines, of RTP engines, you can separate your pools by geographic region, by customer, by anything you want. The example shown here is, very broad, just saying, what continent are you on? And, give me an RTP engine that's in that continent. Sure, there are other ways of solving this problem and separating your media engines. Media engines are actually pretty important. As great as OpenSIPS is, all it really does is sets up your calls and tears them down. The actual, the lion's share of your calls are going to be going through an engine of some sort. And so that's why it's very important to pay attention as to where they are. You want them to be close to your customers, to your endpoints. They may or may not, that may or may not always be possible, but it's a very important piece of the puzzle here to get, I won't say to get right, to not get wrong. So we've talked about some pools. This is high level. You may or may not ever want to have them all on one network the way I've got it shown here. And actually they're not. If you look closely, the IP addresses are a little bit different. You've got RTP engines over on a different subnet. But the idea is to define your devices, your servers, with external and internal addresses or interfaces. Now, yes, some cloud providers may have restrictions that say, hey, you can only have, depending on how you've set your VPC up, I'm not going to say which cloud provider, you can only use one NIC, one network interface card, one interface. Well, it is possible to have both a public and a private IP address on a single NIC, secondary address. It's like, okay. Do you want to do that? Again, your business is going to decide whether, your business case is going to decide whether you want to have both a public and a private IP on one NIC. You can do it, you can separate it, you can firewall them, that's okay. I think if you have the option that you should have a NIC for your public side and a different NIC for your private side. I mean, what can I say? The database, I just have an example of a database here. It's on the internal side, just to show what you would put on your internal side. But you would put, your database, you would put, any kind of a UI or graphical way of managing your pools there. You would put your Homer, shout out to, we've got 5 minutes left? Oh, Celeste already said I can go over. Really? At a time? Celeste said I can go over.
Absolutely not.
Celeste, are you here?
She hasn't cleared it with me.
Celeste, tell them I can go over, unless you guys are bored. So, anyway, so that's what I would suggest. Wait a second, here we go. So, in the event of a failure, this talks about high availability and failures, we have OpenSIPS failing. Its IP address can get moved to OpenSIPS 1. OpenSIPS 2 failed. Its IP address can get moved over to OpenSIPS 1. And the way that happens is using, as I said a little bit earlier, about setting up secondary IP addresses in Linux. I'm assuming everybody's using Linux. If you're not, too bad. With setting up a secondary IP address, you can see in blue, this shows an example of OpenSIPS everybody happy? Or is OpenSIPS 1 with a single IP? After OpenSIPS 2 fails, you see the IP address moved over, and after it recovers, the IP address or that interface goes away, or that secondary interface goes away. When OpenSIPS 2 recovers, voila, it's green. It picks up its IP address. Its IP address has not changed. Celeste, is it okay if I go over?
Norm, spend less time asking.
Okay, and the component that moves, the IP address around, can I have a sip of water, is KeepAliveD. KeepAliveD has been around forever. It's stable software. Lots of folks are using it. KeepAliveD has some various technical settings to make what I just showed in those pictures happen. I'm not going to go over them in the interest of time, but there are various scripts that can run that actually move the IP address and how you would track it. For example, it detected OpenSIPS is down because of SIPSAC. SIPSAC is another tool that's been around since forever, which by default sends options pings. We've heard a number of presentations talk about options being used to ping OpenSIPS. One of the nice things you can do with OpenSIPS, there was another presentation talk about the local cache. You can manage OpenSIPS outside of OpenSIPS using the management interface by updating the local cache. Here's some code that actually implements that. So if you put OpenSIPS into maintenance mode, it will reject options pings. KeepAliveD says, hey, it's not there anymore. OpenSIPS loses its virtual IP address, and guess what? It's now out of service and it can drain calls. Isn't that interesting? You can do the same thing with shared variables. So exactly what I showed you before, but with the local cache, you can use shared variables to do the same thing. Your business case will determine what works for you, what doesn't work for you. KeepAliveD, as I said, is the one that is actually moving these IP addresses around. Here's an example of a notify script that says, hey, once an OpenSIPS has been, a change of state has been detected in OpenSIPS, it will do some things. One of the things it's going to do is, if an OpenSIPS becomes a master, it will take over, it will say, yep, my cluster is active. Kind of goes to what Vlad was saying is OpenSIPS clustered together. You know, it opens the clusterer module has to know who's active. And so this is the way of getting OpenSIPS to say, hey, I'm alive. I mentioned Docker. How do you get some information about these virtual IP addresses that I had mentioned earlier into OpenSIPS's config? You can use the entry point in Docker. This is very standard. I'm sure everybody here has used Docker. And this is how you can get your virtual IP addresses and nodes into your OpenSIPS config. I didn't actually go into the OpenSIPS config, but it's pretty clear. If you have braces, in this example, if you have braces and the capital name, it'll replace the sed command, replaces it. Pretty simple stuff. In order for this to work with virtual IP addresses in OpenSIPS, you absolutely must, this is not negotiable, you have to set IP non-local bind. This is a Linux thing. If you want to go down that rabbit hole, you can. It's a syscontrol setting. It has to be set. If you don't set it, this won't work. I'm going to leave that at that. What am I looking at? Okay, so here's the OpenSIPS config showing 3 different virtual IP addresses that I showed earlier. Yes, if you were to scale out and scale in and have things dynamic, it might be a little bit tough because these have to be statically defined. We don't have that ability. That will be a feature request to have these sockets able to be statically defined and removed, added and removed. Talked a little bit about the clusterer module. These are the clusterer settings for the setup that I just showed. And for VIP routing, Vlad actually talked about some of the problems with routing. I heard a question about, oh, how do you route from one to the other, from one OpenSIPS to another, when Alice is over here and Bob's call is over there? Yeah, that's a pain. And it's not that it's hard, it's not terribly hard, but you just have to go through the process. And the OpenSIPS folks have already determined how, with virtual IP addresses and with some of these problems, that there are these 477 commands. And if you go down this path and you start getting errors, you'll realize how valuable this command is, as well as being able to control your sockets and your outbound proxy, your $DU. Yeah, Celeste says I can take some time.
She did not.
So, okay, I'm almost done. So where am I? Okay, so these are, okay, a little bit more technical, but showing some of the failover scenarios when both OpenSIPs are up, and Alice is in one place and Bob is somewhere else. Here's an example of OpenSIPS 2 when it owns both the VIPs, the VIP for the downed one and the up one. Above the yellow box, you'll see a little loopback. That's what we were talking about before. It's a little bit of a pain. I kind of like the NoSQL solution that Vlad presented. I'm not sure I'm completely on board with that yet, but that would potentially get rid of that little loopback call, which kind of sucked. Okay, then there's RTPEngine. RTPEngine has failover built into it with Redis. I show on the right-hand side why that's probably not a good solution. Am I over time? I've got 30 seconds.
No, you're not.
I'm at
You're
29,
over time.
29,
You're over time. Wrap
Okay.
up.
Okay, so I'm gonna wrap, but I will post the slides. If you want to reach me after the talk, then I will. I'll be here all week. We can chat about this or anything else, but I'll post everything online. If you have any questions, please reach out.
Thank you, Mark.
Fortunately, we don't have any time for questions. We're getting on to our next presenter. Celeste Mangani from QXIP. This is the last presentation of the day, so let's just take a quick minute. Actually, I won't. SWOT's up! You ready? Celeste Mangani.
Thank you, Alex. Hello, good afternoon. For who doesn't know me, my name is Celeste Mangani, and I am the CFO of QXIP. And today I'm going to present you something that goes a little bit outside of the presentations that we've been hearing until now. So all day there were many technical and very interesting presentations, and my purpose here is to move the ball a little bit on the other side. So what businesses can do. So if you have an open source project, you're an engineer, and you want to build up an enterprise and organization over it, what we can do. So basically, we are going to talk about some analysis, let's say, that we do for business strategic planning. And in particular, we're going to talk about SWOT. First of all, one step back. Every day we find ourselves that we have to make very important decisions, and most of the time it's very hard to understand what's the path that we have to take. This is pretty normal in our daily life, and when we are talking about business decisions, it gets even harder. So, going back, SWOT is one of the tools that we can use when we find ourselves in these situations. The first time that I heard about SWOT was watching Silicon Valley, and I'm sure that many of you did the same as me. But I didn't take actually what was the real purpose of it and how it could have been used in real life. And basically what SWOT is a strategic planning tool that we can use when we have to take important and critical decisions, which can be, for example, if you want to start a new department in our organization, or if we want to see if a new product could be potentially profitable, or how they did if they want to decide if it was the case to let blame die. So that is one of the tools that we can use. But what is SWOT? So SWOT basically is just an acronym. and it means strengths, weaknesses, opportunities, and threats. Back in the day, it was done basically via whiteboard. You would divide it in 4 different squares, and each of the square was one of these 4 words, and you would start putting sticky notes inside the strengths, weaknesses, opportunity, and threats. Nowadays, it's usually done on a digital way. And basically, how it is used and for what it is used, the purpose is to evaluate internal and external factors that are affecting your organizational performance. And a lot of times it's hard to understand, it's hard to understand what's the difference between strengths and opportunities and weaknesses and threats. So the easier way to get these is to divide it basically between internal and external factors. So strengths and weaknesses are part of your internal organization, are factors that are internal in the meaning like strengths, what are your resources and capabilities and the expertise that you can bring. And on the weaknesses, we are talking about the barrier that are internal. So lack of resources, for example, or outdated technologies, and these sort of things. In terms of external, we are talking about the things that comes from the outside world towards your organization. So we are talking about, for example, competition, we're talking about market trends, we're talking about legal or economical laws that might impact your organization. How we start a SWOT? Basically, to conduct a SWOT, the first thing that you have to do, you have to ask yourself questions and reply to them. So, what do you do well? What are the resources and the capabilities that your organization can exploit? And on the other side, what are the resources that you're lacking? Or what are the competition, what is doing? And what could be those opportunities that you might miss or that you could benefit from. So these are the different questions that you should ask yourself, and in the moment that you start putting in all these factors, you come up with your SWOT. So let's do a real example. So let's conduct a SWOT analysis, for example, to deciding whether it is the case to incorporate a company to commercialize an already well-established open source project. One tip, remember to keep the list of your SWOT factors as short as possible. So I'm talking about not more than 5, 6 factors for each quadrant, because otherwise it would be not easier to analyze, and it would not get the same goal as you would expect. And it's very important that the factors that you put in are aligned with the real scope of your SWOT. So if one of your strengths is that your office has a very good coffee machine, it might not be something that is so aligned with the purpose of this SWOT. So, is this the end of our SWOT? Yes? No? Well, most of the times, yes. So usually when you do a SWOT, you put in your factors, and then you start to see, is there more positive factors, or do we have more negative factors? And from there we decide a yes or not, basically answer. But that's not the real point of doing a SWOT, because the SWOT should help us to create a strategic planning, and just saying yes or not is not making a strategic planning. So what we do, we need a couple of steps more. The first one is to create a matrix of all the factors that you have aligned inside your SWOT, and basically it's just making a list and giving a code. Usually this is the coding that we use, so for the strength it's S with a number, and moving forward with the other part of the SWOT, and we will use this in a later step. Then what we do, we basically start mapping the SWOT factors with what is called a KAME framework. And these help us to create a more comprehensive analysis, plus it helps us to identify what are some actionable insights that we can actually put in our strategic planning. And the second step will be doing the interconnection. So we'll start identifying what are those dependencies between the internal weaknesses and the external threats, as well as we try to find what are the potential synergies or conflicts that there might be between those factors that we find out. But what is the CAME framework? The CAME framework, also CAME is an acronym, and basically it's, as we see here, a way to use those factors that we find out inside the SWOT and giving them an actionable measure that we can use in our planning. So C stands for correct weaknesses, A, address threats, M, maintain strengths, and E is explore or exploit opportunities. And basically by conducting this type of analysis, we can help the organization to develop a real strategic initiative that can help us to correct the weaknesses, address the threats, etc. How we do this? Basically, we identify what are these weaknesses that we have, and we start to analyze and develop strategies that help us to correct and mitigate them. Same we do with the adaptation to fight the threats. So we try to find those strategies that help us identify, that we identify from the SWOT, and we start to adapting to create some organizational practices or processes or new structures that will help us. We do the same for the strengths, and we do the same for the opportunities. It's very important that we try to make sure that the plan that we are making is actionable and it is aligned with our organizational goals. We do some real examples. So when we're talking, for example, about the correcting the weaknesses, we said that one of the weaknesses from our SWOT was the resource constraints. So we try to identify, for example, some strategies that will help us to address these weaknesses. So, for example, we seek for funding for hiring new contributors or new people, or, for example, it could be outsourcing part of these functions, that it can be externalized. So a full engineering company might decide to externalize accounting or marketing or HR functions, for example. In terms of adapting to fight the threats, a way to do this is try to, for example, differentiate our project through, for example, a unique feature or a unique user experience, and then try to stand out from our competition. In terms of maintaining the strengths, one of the main strengths of an open source project is the open source nature and the community. So, for example, being able to engage and collaborate with different contributors would help us to create new opportunities. And to explore opportunities, for example, we can integrate with the emerging technologies. So being able to look ahead in the future and see what the market might need from time until now. It's now the end of our SWOT. Sorry guys, I need another minute of your time. I hope you're not too tired, because there is one last step that we have to do to make it functional and really give us this strategic planning that is going to help us to make our organization successful. So the next step is what we call DOS. Also, this is an acronym, is the SWOT on the other side. And what actually we do in this step, we start making the interconnections. So we start taking the internal factors, so the strengths and the weaknesses, and we mix it with the external opportunities and threats, and we start to see how we can actually create and use those benefits and those things that our organization have to create a planning for the future. So, for example, and here we come the matrix, why we did the list before, because in this point is where we start to combining the different factors from the different quadrants of the SWOT to create an actual planning. So, for example, creating this sort of events, so being an OpenSIPS Summit would help us to use the community and the expertise of our engineering resources to create new innovation and create a new solution and try to understand what is the market demand. We do the same when we put together the weaknesses and opportunities. So these are the WO strategies. So for example, in this point, we can try to diversify our portfolio and try to address the market uncertainty via collaboration and partnership, for example. We do the same between strengths and threats, so S and T strategies. And at this point, for example, we can use, again, our open source nature and the expertise of our engineering resources to compete against the competition landscape. And then last, we do the same with the weaknesses and the threats. So WT strategies, also in this case, again, we start taking the factors that we have on our weaknesses and we mix it with the threats and we see what we can actually strategize and do and put in our planning. And the last of all, we have to always do the monitoring and reviewing. The SWOT is not a one-time analysis that you do, but it's something that should be by time being reviewed. And we have to continuously monitor the effectiveness of the strategies that we are implementing. And we need to stay flexible and we need to adapt as the needs are changing from the market and from our internal organization itself. When I'm talking about monitoring, what does it mean? Monitoring means creating KPIs. So from the next couple of slides, I'm not going to talk about all these, I'm just showing it to you. You can see it from the PDF of the slide later. But basically, these are the most common KPIs that are used on business as corporation goals, let's say, in business strategy. And when we are talking about KPIs, we are talking about and monitoring, we are talking about KPIs that are need to be measurable and achievable. So these are just some examples. Just to show you how it's done, basically we have to look at the different perspectives. Perspectives usually are finance, customers, internal processes, HR and trainings, and then we have to find and decide what is our strategic objective. We have to look at what is the operational objective, we decide an indicator, and then we give it a critical value. We could also include the temporary indicator, so how many times do we want to do this assessment is something that we have to monitor and reassess on a monthly basis, on a quarterly basis, on a yearly basis, etc. And this, apart from the common goals that we have and that you can see from these slides, we can also introduce some KPIs that are more specific to our discussion today. So, for example, we were talking about open source project. We might include goals that are related to this. So, partnership and collaboration result, as well as how many community events do we want to participate this year, and the number of contribution or contributors that we want to have on a yearly basis, and the community engagement. We want to reach 1,000 stars on our GitHub project. And these are the KPIs. More or less, we are there. So just to finalize it, I want to give you a little bit of insight regarding what are the benefits of integrating these sort of tools in our organization. So we have strategic planning benefits, which means that with these tools we can help organizations to identify what are the strengths that we need to leverage, what are the weaknesses that we need to address, and what are the opportunities that we should try to capitalize, as well as what are the threats that we need to mitigate. It helps us give us an holistic understanding of our organization, the bad and good that are part of our enterprise and organization. It helps us to align the efforts and to create a better communication and collaboration inside our enterprise. It helps us with the risk management, because once that we know what are the threats that are coming from outside and what are our weaknesses, we can create basically a contingency, and develop a contingency plan to address them. It helps us to identify what are the opportunities that we can take advantage of, as well as have a continuous improvement of our planning and strategy. Just a couple of implementation tips. So the leadership should be involved in this process, and it's very important that not only the leadership but all the teams and the different departments, because they can bring a different point of view. To be able that you have many departments and people, team collaborating, you have to train them. They need to understand what is the SWOT and why they should be involved in what are the goals of this sort of process. And the KPIs, very important to monitor and to help us be flexible and readapt, especially if we don't do this just once, but we continue trying to increase and be better in our planning. So a little resume of what we have said. So the first step is doing the SWOT, and then we have to put it inside the KEM matrix, and then we'll do the interconnection with the toes. At the last of it, we'll do the monitoring of it. So now that you know this, there is the first important decision that needs to be made, and this is start contributing to open source, and help us with the star. In my KPI, I have that by the end of the OpenSIPS Summit, we would reach 1,000 stars on GitHub in our creating project, so please help me. And thank you very much.
Very well done. Do we have some questions here? Anybody want to feedback a little bit? I know there's someone over there. No. Again, very thorough. Well done. Let's give Celeste a round of applause. So let's have a couple of quick points to be made. Tonight, dinner starts at 8 p.m. at El Coso. Does anybody here not know how to get to El Coso? Has not seen a pin somewhere, directions somewhere? So everybody who is coming to dinner knows where El Coso is, right?
No.
No? Where were you on my first part of the question? What's an El Coso? Okay, so there is, I think Bogdan sent out a bunch of them. Jazz hands. If you have any questions about how to get there, see one of the OpenSIPS people or one of the organizers. We'll be happy to get you corrected, but you can't really lose because there's a park right over here, literally across the street, and on the other side of that park is a row of hotels that are on the beachfront. So, if you go about 1/3 of the way down after you cross through the park, on the street side, you'll see El Coso. El Coso. E-L space C-O-S-O. What? Stop yelling at me. I was getting there. Somebody asked what an El Coso was. So, we will be there on the 3rd floor. The entire rooftop will be ours. From then till 1 a.m. However, there are a couple of caveats. So, dinner will be served promptly at 8. It will be served until 10 p.m. During that time, you are free to get wine, beer, soda, water, whatever, with your meals. Once the meal is over, we will have our one cocktail presented by the OpenSIPS team, conference, and our sponsors. And from that point on, you're free to stay till 1 a.m. However, the bar becomes a cash bar at that point. You are responsible for watering your own holes. If that's not clear, I'll be happy to make it clear to you at 10 p.m. there. When I say that it's shut down, start digging in the pocket. Before we go, what we want to do is just here at the very end, just as we convene, and I step on the view, I want to get everybody up here. So leave all your stuff there before you pack it up. Just get up on it here. I'm going to get a group picture. We do this every year. So please make your way to the back. Tall people in the back, short people in the front. Horizontally charged people can lay down. Do we have photographers? It's on? You're on it?